For all those who appreciate the work that we're doing here on Standing for Truth, please hit that subscribe button because we are just getting started.
All right, guys, it looks like we are live, and I want to thank everybody for joining us today on Standing for Truth. On Standing for Truth, we focus on the truth of biblical creation, and today we have an awesome guest with us. I am extremely excited that Michael J. Oord can be with us today for this incredibly important presentation and topic. Mike has done a great deal of amazing work on creation and the global flood of Noah. And he is best known for his work on the biblical ice age, which is exactly what we are going to be discussing here today, is the ice age. So I want to thank everybody in the audience. Please also tag me with your questions at Standing for Truth. That way I will see your questions. Typically our chats get lively, and today is definitely going to be a good show. So I am going to bring in Mike Oord and our award-winning co-host, George Bond. Thanks so much. Gentlemen, Mike, once again, it's so great to have you here.
Hi, you're welcome.
Well, I want to say, again, thanks for giving us your time for today's important show. And we have a lot of new viewers and subscribers since your previous presentation with us on the global flood and the recessive stage of the flood. If you wanted to take a few moments to give everybody a brief introduction as to who you are, maybe what you're doing in terms of creation research, and why you find this topic so important, Mike.
Well, we have a huge amount of challenges out there, not only from the secular world, the university, and even from our neighbors and friends on how do you explain this? How do you explain that? And so I deal with the questions on the flood, and there's a huge amount of questions of the flood. By the way, bringing the flood back to Earth history solves many of them. Now, some of them are unsolved, mainly because we don't have the data for a lot of them or the time to do it. But it excites me that we do have answers. And if a person is willing to be patient and check us out and see what we say about certain things, they would be most impressed. We have over 50 years of creation research that we've done, like the Creation Research Society Quarterly, Journal of Creation Answers Research Journal. So we have answers, and I'm just happy to be part of that. And so it excites me to do this. And there's a lot to do, as I'm sure a lot of people know.
Amen. Amen. Great introduction, Mike. And I want to recommend your previous presentation and audience Q&A with us to everybody in the chat. Anybody who's new to this channel, please check that out. I do have it in the description box of this video, as well as some links directly to some articles that you can find from Mike on the creation.com website. So we've also got George here with us. Thank you so much, George. A few introductory words from yourself.
Good morning. Actually, very early in the morning. By the way, SFT, I go to my mailbox every morning looking for that award. I still haven't got it. So, good morning.
I'm going to travel
morning,
to Australia and deliver it to you personally.
Yeah. Can I start the proceedings by saying it's a pleasure to have you here again, Mike. For those that haven't really had the pleasure, we had Mike around 6 to 8 weeks ago regarding the receding floodwaters. I urge those that haven't watched it to do so. It's in our playlist. For anyone who hasn't read much creationist material, you'll find Michael's volumes, and I mean volumes of papers and articles, is written on many creationist websites. His wealth of information and work is cited by many other creationists also. I believe, Mike, last time we spoke, you said you had a list of over 500 projects that you would love to complete. So I guess in your case, it's a work in progress, Mike.
Oh, yeah. I mean, I have about 15 projects going, but I keep saying I have 500 years worth of research left to go.
Well, Mike, true to my form, I always start off with a bit of a joke. You'll be happy to know that some scientists from Berkeley were successful in getting a grant in order to determine the height of a flagpole. So they looked and looked at the pole. They had their toolbox and their measuring tapes and everything, and they couldn't figure out how we're going to do this. We don't have a ladder that long. So a woman walked by and asked, "What were you doing? What are you trying to do?" We're supposed to find the height of this flagpole," said one of them, "but we don't have a ladder long enough." Oh, well, the woman looked at the spanner and a tape measure from their toolbox. She began to loosen a couple of bolts at the base of the flagpole and laid it down on the ground, took the measurement and announced 6.5 meters and walked away. One scientist shook his head and laughed. He said, "A lot of good that does us. We ask for the height and she gives us the length."
Yeah.
All right.
Very good.
Mike, back to seriously now. Having watched your video on the Ice Age twice now, I'll admit, I have to express my ignorance before having seen it. I was not aware of a lot of what you stated in that video, but rather than steal your thunder, I'll wait till your presentation. For those that are listening, of particular interest was how the mammoths and other mammals got to the far north, and the freezing of the mammoth's stomach contents and how they preserved in the permafrost. My research shows that as far north as Greenland, there is abundance evidence of moderate climate just 700 to 800 years ago. Now, creation research, our friend John McKay and Joseph Hubbard have a documentary on this called Fire and Ice. For those wanting to check that out and see what evidence I'm actually talking about, you can find that in that documentary. However, I'm sure our audience are here to hear from you, Mike, and watch you rather than me. So I'll let you take it away.
The floor is yours, Mike. We can get right into the presentation if you'd like to, and I can share your screen as well.
Okay.
Thank you for that introduction, George, as well, and a good joke to start us off with. I appreciate it. And here we go, Mike. I've got your screen pulled up.
Can you all see it?
Yep.
Yes. Looks good. Looks good, Mike.
Okay, this is my standard talk on the Ice Age. And the title is an Ice Age, only the Bible can explain it. Very provocative subtitle there, but I will explain it as I go. Anyway, there's hundreds of earth science challenges. And here's a list I just wrote down over a 5-minute period. Some of these I've worked on. Here's more of them. Anyway, the Ice Age is one of these challenges that the secular scientists give us. So this is going to be about the Ice Age. And through the Ice Age model, biblical model, we can answer some of these other ones that I've listed here. The results of these challenges, there's hundreds of them. I read about them all the time in the secular literature. They cause many to doubt God's word. And they cause tens of thousands of atheists and agnostics. Some of the people think these challenges are so solid that the Bible can't explain it. It's caused tens of millions of Christians to fit evolution and deep time into the Bible as a result. It's enhanced the local flood myth. It's resulted in a mass exodus of youth. So these challenges are important for us to answer. And this is what I spent 45 years doing. A closer look at challenges. Many do not realize that most of these are also challenges to evolutionary geology. When I research a topic, I find out that a lot of times when you dig below the surface that It's challenging to them. They can't explain it. In fact, there's numerous challenges to deep time and uniformitarianism. Also, we have to realize that we're not going to solve all challenges. And one of the reasons is because there's not enough known in the earth sciences. So we got to be patient with challenges and check into them and do research. And many really do not know that the creation flood ice age model has solutions to many of these challenges already. Some challenges take a long effort, long time. So it's not going to be done overnight. We have a lack of workers and funds. So those are some of the reasons why we have some unanswered challenges. Anyway, let's talk about the ice age. First of all, what is an ice age? Well, you can't really find much of a definition except that it's a great increase in snow and ice. Currently, 10% of our continents have ice on them now, mainly Greenland and Antarctica. During the ice age, 30% of the land surface was covered by ice, mainly in the high latitudes and locally down to the mid latitudes and in many mountainous areas. Also, it was the last major event in Earth history. Last major event. And I'm going to come back and revisit that at the end. Okay, actually, there are 5 ice age periods according to the secular uniformitarian. There's the Pleistocene, less than 2.6 million years. The late Paleozoic, about 280 million. The late Ordovician, 450 million. Late Precambrian, several of them during that time period. Some of them supposedly are global glaciations, which brings up an interesting conundrum as how do you glaciate the globe? And not only that, how do you melt it? Big problems. I've dealt with these before. And also there's mid-Precambrian glaciation. So there are generally 5 major ice age periods. There's some minor ones in between. Anyway, it's the Pleistocene is the real ice age. And they claim there's 50 ice ages now in the Pleistocene, but it's mainly their last that is the one that's correlated to the biblical ice age. The reason for the other many is due to deep sea cores, wiggles in deep sea cores. You don't see that evidence on land. Anyway, the Pleistocene ice age is real, but only the last is equal to the post-flood ice age. The other 4 can be explained by gigantic submarine landslides during the flood, because they're from the flood. And I wrote a book about this quite a while ago, documenting this, Ancient Ice Ages or Gigantic Submarine Landslides. Anyway, here's the challenge of the ice age that they give us. Each ice age takes 100,000 years, at least in the last million years. Before that, it was every 40,000 years, they claim. The glacial phase is approximately 90,000 years, and the interglacial phase is 10,000. Now, we live in an interglacial phase right now called the Holocene. And there's been, like I said, about 50 regular repeating ice ages during the past 2.6 million years of various intensities. That's what they claim now. And that's the challenge that they give us. And here's a quote from the anti-creationist Arthur Strahler. He says, increasing the duration of the ice age by a factor of about 10 greatly increases the stress upon the creation scientists who must compress the events of 15 million years into 4,000 years of post-flood time. Well, this guy's got a huge book with challenges for us, and he did a lot of research. So he looked into our stuff, and so he got some things right, like the post-flood time, and other things he's got wrong. So what's this increasing the time by 10? Well, they decided because of other geological phenomena, mainly ice-rafted debris in deep sea cores, dated as Oligocene or Eocene, early Cenozoic, Paleogene for other people. And therefore they decided that, well, these came from Antarctica. Antarctica must be 10 times the age we thought it was. So overnight it becomes 10 times the age, where it started about 40 million years ago. And the Eocene reached a maximum at 15 million years. So that's the challenge it gives us. We need to not only explain the ice age, but also the Antarctic and Greenland ice sheets, and that they say takes 10 times as more time. What do we do with challenges? This is my theme verse for all research. In fact, it's a great theme verse for life. Examine everything carefully. Hold fast to that which is good. 1 Thessalonians 5:21 from the NASB. I can't emphasize more of that word carefully. You got to go beyond the superficial. See, you can go on online and see a lot of challenges they give us, like I saw one the other day on the Ice Age. So, and it sounds kind of convincing, but when you look at it carefully and bring back the Bible into Earth history, you know, there's a whole different way of looking at it, a whole different explanation. And so this is my theme verse for research. I examine everything carefully. So I need to kind of back up and kind of, first of all, answer a few questions. Was there really an ice age? See, there are some people, even a few creationists, that don't believe there was an ice age. Well, where are you going to test to find out whether there's an ice age? Well, you go to places that are glaciated currently and look and see what glaciers produce on the land. And then you see if these similar features are found elsewhere. And of course, here's the beautiful Athabasca Glacier in the Canadian Rockies. And it was out here in 1890. Practically all the glaciers in the world have shrunk due to a little global warming. I emphasize a little global warming. But what you see glaciers do, they produce these ridges and mounds of all kinds of rocks. Like here's one right here in front of it, a ridge of debris that was left. That's called a end moraine or terminal moraine. And along the edges, you find where the debris has been piled up along the side as the glacier advances. They're called lateral moraines. And here is a picture of the lateral moraine to the north. You see it's got some good-sized boulders in it. It's just a pile of rocks, various sizes, all mixed up. By the way, I was young and stupid when I took this photo. I actually went up on this ice, this Columbia ice fields, Athabasca Glacier. Had a lot of crevasses. I was pretty dumb, but I survived. And then you find scratched boulders. The boulders are scratched because they, at the bottom of the glacier as it moves, the boulders scratch the bedrock and the boulders get scratched. And sometimes the boulders will shift because the ice is plastic, can shift. And it can form scratches on the boulders in different directions. Like here, there's 2 directions, right in here and right in here. So that's typical. And then the bedrock is scratched in the direction that it moves. These are typical of glaciated areas today. Do we see these areas in places that are claimed to be glaciated? Indeed, we do. This is west of where I used to live in Great Falls, Montana. I live now in Bozeman, Montana, about 150 miles south. And here's the Rocky Mountain front in the background. And in the foreground, you see this mound of, and you see boulders at the top. And it continues over here. You can see it's just a mound of debris of actually rocks of all sizes. It was continuous in here at one time, but it probably broke through here because of it dammed up a glacial lake and cut through here. And of course, that's where they put the reservoir. And when you look at the close-up of the terminal moraine, you see rocks of all sizes in a jumbled mixture, just exactly what you expect for glaciated areas. And then you find some scratched rocks in that terminal moraine. And when you hike up to the top of the Rocky Mountain front, this is the first cliff in the Rocky Mountain front. It's 800 feet high, about 250 meters high. And yet you see the scratched bedrock moving from west to east and down into the high plains about 20 miles east to where it ended. So this area was glaciated. But this area in the summertime gets up into the 80s or in centigrade, 20 to 30 degrees centigrade for high temperatures. And so no glacier is going to survive in the Rocky Mountains or in the plains today. Very, very far from producing any glaciers. And then you find that a lot of the mountainous areas in the western United States were glaciated. And glaciers came out of the mountain valleys onto plains, like here's one at Enterprise, Oregon, Northeast Oregon. And you see this horseshoe-shaped feature right in here with a dammed up, over-deepened lake like a fjord. And when you this feature would not form in the flood, as some people have tried to tell me. Anyway, this is a special shape from a glacier coming out onto a valley and piling up a lateral and a terminal moraine, like you see in presently glaciated area. And when you look from the lake level at the lateral moraine, you can see the trees for scale. This lateral moraine is 600 feet tall. When you look at what's in the lateral moraine, you see it's rocks of all sizes and generally a finer grain matrix. Like here's a granite rock right in here, a lot of granite in those mountains. So this area was glaciated. Enterprise, Oregon, Northeast Oregon gets up in the low 90s for high temperatures in the summertime. You couldn't glaciate the Wallowa Mountains today. It's very far from creating an ice cap there. And then you find all these erratic boulders. Here's a famous train of erratic boulders that stretch 600 kilometers from near Jasper, Alberta, Canada to Cutbank, Montana. This is a quartzite. Look how angular that is. By the way, this is John Wood Merapi for scale. This is southwest of Calgary, Alberta, Canada. It couldn't have rolled down in the flood. It had to be transported in an iceberg and deposited. And this probably was a glacial river between the Laurentide ice sheet in central and eastern Canada and the adjacent United States, and to the west, the Cordilleran ice sheet that covered the Rocky Mountains and moved down off the Rocky Mountain front for maybe about 50 kilometers. And here's a really interesting boulder. This is about 180-ton argillite boulder. So you can see it's a shale. Argillite is a slightly metamorphic shale. It's in the Willamette Valley, southwest of Portland, Oregon. It's about 200 kilometers south of the furthest southern extent of the Cordilleran ice sheet, which is Olympia, Washington. And by the way, this type of rock does not outcrop anywhere in the state of Oregon. And you couldn't have rolled this. By the way, it outcrops in northern Idaho and western Montana, near where I live. And this part of the Belt Supergroup rock from the Belt Basin, 20 kilometers plus of sediment in a deep hole deposited. Anyway, the glaciers, it's deposited down here. What's it doing down here? And it's angular. Well, the only explanation is the Lake Missoula flood, where the valleys of western Montana ponded to 600 meters by an ice dam in northern Idaho. And then it broke through that ice dam and flooded eastern Washington and carved it up, moving 80 miles an hour through there, and moved through the Willamette Gorge and spread out in the Vancouver, Portland area, with all kinds of erratic boulders spread over the Willamette Basin, which is what you're seeing here. And this unique one had to be carried by an iceberg from as far away as western Montana, which indicates that if you had a Lake Missoula flood and you had an ice sheet that was at least 2,500 feet thick in northern Idaho, you had an ice age. And here's a quick summary of the Lake Missoula flood. Here's the valleys of western Montana. I lived down about in here, and it filled it up 2,000 feet deep right there. And it carved through that ice into glacial Lake Columbia, and then it carved up eastern Washington. 50 cubic miles of basalt and silt was eroded. The green areas where the channel flowed. And here it is from space. You could see the path of the floodwater of the Lake Missoula flood. It was 10 times the combined flow of all the rivers in the world. Huge. They rejected it for 40 years because it was too biblical in scale, until they realized that there's hundreds of pieces of evidence for this. And so when you add up all these areas where it shows glaciation, this is the general area of where it was glaciated, generally down into the mid-latitudes of the United States and the mountains of the West. This is a schematic. It's not meant to be accurate. And here's an area not glaciated somehow, right in the within about 300 kilometers north of its furthest extent. And here's Alaska. Only the mountains of Alaska were glaciated, but the lowlands were not. Major mystery of science, which I will say something about towards the end. That's where you find the woolly mammoth fossils, the horses and the bisons in the lowlands of Alaska. And then the same thing in Eurasia. There's the general location of the ice. It's rather controversial how much ice was here, by the way. By the way, this is an old schematic from one of my books from the 90s. So that's questionable how much ice was here. And now they believe the Barents Sea north of Norway was glaciated. And some more mountains besides the Alps were glaciated here. It's just a schematic. The central mountains of Asia, the mountains of Siberia, only the mountains, but not the lowlands. And that's where you find the woolly mammoth fossils by the millions, especially in the New Siberian Islands here and in the adjacent coastal area in the permafrost. So this is the general location of the ice. 30% of the land surface was covered by ice during the Ice Age. So there was an Ice Age. Can mainstream sciences explain the Ice Age? Remember, I said that they are always challenging us, but I find that they're challenged also. But in order to know whether they're challenged or not, we need to know what it takes for an Ice Age. What do we need? Here's the requirements for an Ice Age. Cooler summers. Winters are already cold enough most areas. In fact, most areas would benefit for a warmer winter because the warmer the air, the more moisture it holds. So you can produce more snow. Then secondly, greater snowfall. You need much more snowfall. And it has to not melt during the summer. So it builds up year by year. So it persists for many years. You just can't have a climate change for 1 year. By the way, how much cooling are we talking about? What kind of numbers? Well, a man did a computer study of to see where the 1 inch line or more snow areas occurred after the summer melt in Canada. And he cooled off the average summer temperatures of Canada by increments of 2 degrees centigrade, about 3 degrees Fahrenheit. So when he cooled it off to 12 degrees centigrade, his 1 inch line was in northern Canada, there and northward. That's where his 1 inch line, cooling off 12 degrees centigrade in the summer. That's about 20 degrees Fahrenheit. And that's where his 1 inch line was left after the summer melting, and supposedly it would increase with many more years, and that's where your ice sheet would start. But the thing is, the ice went clear south of the Great Lakes into the mid-latitude, so you need a lot more cooling to get it down that far. And by the way, the glaciers didn't develop in northern Canada and move at a glacial pace down to the northern United States. In general, they form more or less in place. There was a soft movement because the slope, they moved by the surface slope mainly, and so the surface slope was always be to the south, so you'd have scratched bedrock down towards the south. So it generally formed more or less in place. So let's try Minneapolis, Minnesota. This would work for many places along the edges in northern United States. The summer temperature averages 70 degrees Fahrenheit. That's 21 degrees centigrade. That's the high and the low both. So you have to cool off Minneapolis to at least 32 degrees Fahrenheit. But by the way, snow melts mainly by solar radiation, and it can melt at well below freezing. As anybody that lives where I live knows, when you get a spring storm, it dumps a foot of snow, sun comes out, it's 10 degrees Fahrenheit, and it starts melting at 10 degrees Fahrenheit. So when do we get net melting then? What temperature? How far down do we have to go below 32? Well, I went to a paper on Antarctica, and the Antarctica gets net melting along the low altitude edges when it rises to 14 degrees Fahrenheit from the journal Quaternary Research. So I'll be more conservative and say that if the average temperature of Minneapolis is 20 degrees Fahrenheit in the summer, then the ice will start building 1 inch, a foot at a time, then the next year even more. So that's a summer temperature drop of 50 degrees Fahrenheit. Where are secular scientists going to get a temperature drop of 50 degrees Fahrenheit for an ice age? And by the way, you need a climate change just not for one summer. It's got to be many summers. So as you can guess, the ice age is actually a severe problem for uniformitarian scientists because they only have to explain this by climate change with present processes of climate change. What sort of present processes of climate change would produce this much of a temperature drop? Well, they haven't really got the foggiest idea. They appeal to something in the past called the astronomical theory of the ice age, or the Milankovitch mechanism, caused by slight changes in the Earth's orbit with time. And so you get slight changes in radiation, very slight. And they say, well, that did it. Well, no, that's too weak. And creation scientists, Jake Hebert and myself, have written a lot about the Milankovitch mechanism. That it's way too weak. So they got a serious problem of finding a drop of 50 degrees Fahrenheit. So as you might think, it's a problem. And so a lot of experts on the ice age admit this, like J.K. Charlesworth in the book Quaternary Era on page 1532. Yeah, it was a 1,700-page book on the ice age. I loved it. It was very detailed. He was a very thorough researcher. He says Pleistocene, by the way, the word Pleistocene or Quaternary is their time scale for the ice age. Pleistocene phenomena produce some good theories, an absolute riot of theories ranging from the remotely possible to the mutually contradictory and the palpably inadequate. And by the way, there's over 60 theories on how the ice age formed. And by the way, that was in 1957. This is modern times, right? And we know so much more. Well, oh, do we? Well, let's get another reference from 1997. U.S. News and World Report dedicated the whole issue to the 18 top mysteries of science. Some of you might have noticed that some of these mysteries are strange and are actually mysteries of their own making because they believe in evolution, like this one right here. Why should males exist? Well, in evolution, you should only have one sex that reproduces asexually. They can't figure out why there's a male and a female, and they write books and articles trying to figure out this great mystery every year. And guess what? This is where the biblical worldview has evidence hands down, because it simply says in Genesis, God made them male and female. But some of these are real mysteries, like what causes ice ages. So that made the top 10. What causes ice ages? They don't really know. In a more recent theory by David Alt about glacial Lake Missoula and its humongous floods, yeah, they have to believe in more than one glacial Lake Missoula flood, by the way, about 100 of them now during their last ice age. Anyway, he says, 2001, although theories abound, no one really knows what causes ice ages. They don't know. It's a huge problem to them. And in 2008, these two researchers said in the journal Nature, the most widely read journal in the world, perhaps the longest standing puzzle in the earth sciences is what caused the northern hemisphere ice sheets to come and go. Long standing, 200-year puzzle. So it is a problem to them. But can we explain it? Can the biblical worldview explain the ice age? Well, we need to know when it occurred, first of all. Was it before the flood? During the flood? After the flood? Well, it's obvious it's after the flood because these moraines and erratic boulders are all on surface features with thick sediments below them, sedimentary rocks from the flood. So it obviously followed the flood. So we can place it within a transitional climate between the flood and the present climate. This suggests strongly that the flood may have caused the conditions necessary for such a radical climate change, the ice age. And indeed, that is the case. So what about the flood would do it? Well, the flood was a great tectonic event, volcanic event, meteorite impacts. lots of volcanism. So at the end of the flood, you'd have a shroud of volcanic dust and aerosols. An aerosol is a particle about a micron, one millionth of a meter in diameter, and they are so small they float up in the stratosphere for a couple of years, and they reflect the sunlight back to space, cooling mainly the summer over land. Doesn't affect the water, and doesn't affect the winters because of other heating features. Also, the fountains of the Great Deep and volcanism would cause a warm ocean at the end of the flood. This is a very key feature, this warm ocean, as well as the volcanic aerosols. And these mechanisms would persist after the flood, but wane with time. Wane because the volcanism decreases with time. Also, the warm oceans cool with time. And we can time the ice age by the cooling of the oceans. A very physical mechanism, cooling the oceans. So, Genesis flood can fulfill these requirements by the volcanic dust and aerosols during the flood, and even after the flood, there was huge volcanism, and the fountains of the Great Deep and volcanism causing the warm water. Here's a schematic showing dust and aerosols. Dust settles out in weeks to months, but aerosols will settle out in a matter of years to even up to 10 years, reflecting some of the sunlight back to space. Anyway, as evidence that there was a huge amount of volcanism during the Ice Age, Charles says signs of Pleistocene, that is Ice Age volcanicity and earth movements, are visible in all parts of the world. You see them, a lot of Pleistocene sediments, in a lot of ocean sediments from the Pleistocene. So a lot of volcanism occurred during the Ice Age to replenish the particles that fall out with time to keep the Ice Age going. So here's kind of a schematic of warm oceans at high and mid latitudes. Huge evaporation. And by the way, the key for the warm oceans is the warmer the temperature, the greater the evaporation. For instance, you can evaporate 7 times as much water vapor into the atmosphere at an ocean temperature of 30 degrees centigrade than at 0 degrees centigrade. 86 degrees Fahrenheit versus 32 degrees Fahrenheit, 7 times. And by the way, it would be at mid and high latitudes where the oceans would be a lot warmer than today's ocean. So you have a lot more water vapor in the air at high and mid latitudes. And volcanism and dust in the upper atmosphere falling on the cold land. That's kind of a schematic of it. So, do we need 100,000 years for an ice age, or even 40,000, as the secular scientists claim for each of their ice ages? So how rapid was the ice age? This is my evidence that the ice age was very rapid, right here. This is it, Jenkins. Indisputable proof that the ice age caught these people completely off guard. It dumped on before he got out of the outhouse. No, seriously. I had to estimate the starting temperature right after the flood and the ending temperature when it reached glacial maximum. So what I did was the cooling of the ocean drives the ice age, times it. It'll cool by cooling mechanisms, mainly conduction of heat to the colder air and evaporation. Evaporation is approximately 3 times as efficient as conduction. So by evaporation and conduction, you cool the surface layer of the ocean, and it sinks down to the bottom, and you have a huge overturn of the ocean as it cools. Significant effect for the bottom of the ocean, which no creationist has really got into yet. So, based on the cooling, the cooling versus the warming temperature would be the sunshine. So, I use this. It's called a heat budget equation. It's just like you turn on the heater and the air conditioner in a room, and you see which one's stronger. Well, in this case, the air conditioner was stronger, ended up cooling the room. In this case, cooling the ocean. And so it cools with time, so you can time it. So I assumed we went from 30 degrees centigrade average down to 10 degrees centigrade average. By the way, the average now is 4 degrees centigrade. So you reach glacial maximum before you reach the temperature today. So with 20 degrees centigrade cooling, I plugged it into the heat balance equation and used maximum minimums for these variables because there's no way to be accurate. I just wanted to bracket. So I got a maximum of 1765 years and a minimum of 174 years to reach glacial maximum. Best estimate was 500 years. Then you got to melt all this. First of all, you got to figure out what the average height of the ice sheets was. So I used maximum minimums for variables and got a range. And the best estimate for the northern hemisphere is 2,300 feet. For Antarctica, about 4,000 feet. Those are the best estimates. And then you got to melt it. And the best way to melt snow and ice is to use a physical equation of us that uses physics of snow and ice melt, that uses the heating terms, subtract the cooling terms. Once the ice gets up to 32 degrees, more heating causes net melting, and it starts to melt. That's how it works. So I use maximum minimums for this heat budget equation for snow and ice. The main variable is the albedo, or the reflectivity of the snow. That's a very key variable, and the climate models are horrible at modeling the change of albedo, which changes radically snow ages, for instance. So I use maximum minimums for the albedo, and I got a range along the edge, 40 to 100 years to melt. Best estimate 70 years. For the average ice thickness was 40% of the secular scientists, and there's lots of evidence for that thinner ice sheet than what they claim. I have 2 articles for the Scandinavian ice sheet and the Laurentide ice sheet in the Journal of Creation of the last couple of years. So time to melt, the interior is about 200 years, but the periphery about 70 years. The periphery is along the edge. So the total time for an ice age is only 700 years. This is an example where we use different variables from them. We use biblical variables, the flood, and we get a rapid ice age of 700 years. And they claim there's more than one. They used to say there's 4 ice ages. For 60 years, they used to claim 4 ice ages. In fact, everywhere they looked, they saw 4 ice ages. Now, that's interesting. Why did they only see 4? Well, actually, when you look at the glacial debris on the continents, you see evidence in most areas of only 1. So was there more than one ice age? Well, actually, I believe there was 2 ice ages. There was one before the flood around the Garden of Eden. And this is the Earth's first ice age right here. I got to explain this a little bit. In that when God created man and woman, he created us with no sin, and we had perfect communication at the time. But it doesn't work so well now. And since sin entered the world, communication is broken down. In general, to be very general, women have sensitivity issues and men have clueless issues. Anyway, seriously, there was only one ice age. And in most areas, you see evidence of just a single ice age, like this quote from the journal Geology. A single late, the title of this, a single late Wisconsin Laurentide glaciation, Edmonton area in southwest Alberta. Edmonton's in central Alberta. Great places for glaciers, ice sheets to occur. And so they're saying that there was only a single one. It was in the late Wisconsin and of the Laurentide. Anyway, that's what you see. And notice what they say in that. Glacial reconstructions commonly what? Assume a multiple glaciation hypothesis in all areas that contain a till cover. Till is glacial is jargon for glacial debris left over. So they assume it, and if they see some complications, maybe some till here, or maybe some sand and another till. You see, oh, that's two ice ages. That's how they did it. And that's how they came to 4 ice ages until the 1970s. And then the Milankovitch mechanism took over and claimed there's 50 now in the Pleistocene based on deep sea cores. And how does that work? Well, they take these cores and they measure all these variables down there and they wiggle around an average. So then they say, when it wiggles this way, it's a glacial. When it wiggles this way, it's interglacial. I think these are climate changes during the ice age, but they would say each one is a separate ice age. So we would interpret them a lot different than they would. So another question, they claim the glacial interglacial cycle is still here. Therefore, the next ice age is about due. And will there be a future ice age? Well, a lot of people think so. In fact, some people even think global warming will trigger it, which is kind of crazy. But anyway, here's the challenge they give us about the next ice age. They say we are still in the glacial interglacial cycle. Interglacials last about 10,000 years. The last ice age melted 10,000 years ago. Uh-oh. We're about due. And in fact, in the 1970s, for those people that like global warming, we actually had global cooling from 1945 to 1975. Global cooling for 30 years, during when carbon dioxide was going up tremendously. That's why there's more to all this global warming than what the hype is saying. Anyway, we had global cooling, and sea ice increased. And so a lot of books were written about the next ice age coming. Can we survive it? Articles were published in Newsweek and so forth. And so they said that ice age was coming. Anyway, in the New York Times, this was published. In the past, if the past is any indication, the Earth is at the end of another such warm period, poised to descend into a new ice age. That's from the New York Times. And we believe everything we read in the newspaper, do we not? I don't hardly believe anything from the newspapers anymore. Anyway, the rainbow is a sign that there'll never be another flood. And the flood caused the ice age. Therefore, there'll never be another ice age. So those out there in the audience that were sweating it can relax. And by the way, this gets back to my title of that the Bible explains it. Only the Bible can explain it because of the flood. Now, at this point, I go through the bonus features if I have time, which I do in this case. And besides the ice age, you had a lot of other things going on after the flood. Many, many different things going on. Just think of that, all that moisture being added by the warm oceans. That would cause a lot more precipitation in areas not glaciated. The climate would be a lot different. The general circulation would be different. Things would be quite different during the ice age. So I've gone into other areas. There's a lot of areas left to go. And these are features explained by this post-flood rapid ice age that the secular scientists cannot. And I'll go through these quickly, one by one. In my publications and resources, I go through these in a lot more detail. Anyway, the first one, deserts that were once wet. In Southwest United States, we had all these lakes. Even in Death Valley down here, which I don't show, had a lake 600 feet deep. Here's a lake right here around the Great Salt Lake. It was about 10 times the size of Great Salt Lake, 800 feet deep, while Great Salt Lake right now is only 12 feet deep. So all these lakes in the Southwest United States that is semi-arid today in these enclosed basins, how did they get there? Well, I would say the flood probably filled them up to start with. As the flood drained, it kept water was left in pockets, and they actually increased. We know that they actually grew during the ice age. I will probably say a little bit more about that soon. But anyway, you find shorelines from these lakes all over the place. Like here's Lake Bonneville shoreline. There's several shorelines. The highest one is here's the Lake Bonneville level, and the Provo level is a lower one. Anyway, you see shorelines all around where these lakes were. Here's one in east of the Sierra Mountains in California. where you had a monolake that was about 800 feet deeper, called Lake Russell, and here's the shoreline on it. This shoreline happens to be right on a terminal moraine coming out of the valley from the eastern Sierras. So the what's called pluvial lakes were associated with glaciation because it's right, the shoreline's cut right on an end moraine. And here is southeast Oregon. You find some low level shoreline features in the desert areas of eastern Oregon. And the Sahara was wet. In fact, people lived in the Saharas. There's a huge amount of evidence of people and animals. Like this drawing, you find tens of thousands of these petroglyphs on rocks in the Sierras. Sierra was green. In fact, James Weller in The Great Sahara says this: the Sahara is a veritable art gallery of the prehistoric paintings. The evidence is enough to show that the Sahara was one of the well-populated areas of the prehistoric world. Yet there is man's work in the most inaccessible corners of the desert. Literally thousands of figures of tropical and aquatic animals, enormous herds of cattle, hunters armed with bows and boomerangs, and even domestic scenes of women and children in the circular huts in which they lived. It was green at one time, during the Ice Age, and even after for a while. So deserts were once wet. This could be explained by the greater amount of water vapor given off by the warm ocean. The woolly mammoths in Siberia. There's a woolly mammoth. It's a small mammoth. The Columbian mammoth was about 3-4 feet taller, the largest mammoth in the world that time. Spiraling horns, had 3 layers of hair. The outside was about a meter long, a hump on its head, a hump on its back, and a sloping on the front of its back, shoulders, and a slumping back. Anyway, those mammoths are found all through the northern hemisphere. You can see this red area here, but not in the central areas, the northern areas where the ice occurred, which indicates they're associated with the Ice Age. Some of them are in the southern part of where the ice occurred, and they either were there before the ice got in there or afterwards. So they all went extinct. And them and many other animals. And they don't know why the mammoths disappeared. In this book by Larry Agenbrod and Lisa Nelson says, why did mammoths disappear from the earth? This question remains one of the great unsolved mysteries of the past. Anyway, it can be solved by the post-flood rapid ice age, where probably about midway in the ice or early in the ice age, they got up into Siberia, crossed into Alaska, down the ice-free corridor in the United States, and some made into Central America. So this can all be explained by the rapid post-flood ice age. And why they would live in Siberia? Well, you can find out that if you took off the sea ice in the Arctic Ocean and left the temperature of the water at the freezing point of seawater, which is 28 degrees Fahrenheit, what kind of winter temperatures would you have in the Arctic and in Siberia? Well, this is in centigrade. The North Pole would be 40 degrees centigrade warmer in the winter, 20 degrees in northern Siberia. So a lot warmer in Siberia, just getting rid of the sea ice and keeping the temperature of the ocean water at 28 degrees Fahrenheit. But it was probably 70 degrees Fahrenheit at the start of the Ice Age, indicating you'd have a lot warmer temperatures in the winter over Asia. So the animals, some of them that can't tolerate much cold, can round the Bering Land Bridge into the United States that way. And of course, there's all kinds of onshore flow of warm air into Alaska and Siberia. Also, there's a strange mix of cold and warm weather animals and plants in glacial debris. This is called disharmonious associations. And we can explain the cold ones during the Ice Age, but what are these warm weather animals doing there and plants? By the way, this is not an anomaly, it's the rule. of a mixture of cold and warm type animals. In fact, this book, Quaternary Extinctions, Graham and Lundelius, say late Pleistocene communities were characterized by the coexistence of species that today are allopatric, that is not climatically associated, and presumably ecologically incompatible. Disharmonious associations have been documented for late Pleistocene, that is Ice Age floras, that's your plants, terrestrial invertebrates, lower invertebrates, birds, and mammals. It's the rule, not the exception. How do they explain it? Well, they don't, because their ice ages are bitterly cold winter and summer. But in the post-flood model, we have warm winters. We have mild winters in many locations. In fact, one of the most outrageous examples of disharmonious associations is in Northwest Europe, where we have hippo fossils associated with cold climate animals like mammoths and reindeer. Anyway, early in the Ice Age, the warm onshore flow in the Atlantic Ocean would keep those areas warm. You'd have a very warm winter. You'd have warm summers for quite a while early in the Ice Age. So the hippos, and wet, by the way, warm and wet. So it'd be a great environment for hippos after the flood to migrate up into there. But as it cooled, glaciers started to form in the mountains. They were out of place. They couldn't escape. And so they ended up being buried with cold climate animals. And there's over 100 locations of hippos in England itself. For instance, Don Grayson said in that same book, in the valley of the Thames, southern England, for instance, woolly mammoth, woolly rhinoceros, muskox, reindeer, hippopotamus, and cave lion had all been found by 1855 in stratigraphic context that it seemed to indicate contemporaneity. In other words, they lived together. They try to separate them into interglacials and glacials, but why would, we're in an interglacial now, why would a hippo want to migrate up to England in this interglacial? Doesn't make sense. Anyway, there was mass extinctions at the end of the Ice Age. Why is that? Well, here they are. 100 species of large animals disappeared in North America. That's 70%. And these are animals over 100 pounds. Europe and Asia lost 40%, Australia 90%, South America 80%, Africa only 20%. That's the latest statistics. They've changed a bit because of more further knowledge. They don't have a good statistics from Southern Asia, but Northern Asia they do. So why is that? Well, they really don't know. In fact, it only happened after their last ice age, which is kind of interesting. Why didn't it happen after the other 49 ice ages? Well, maybe those other ice ages did not exist. So it's a radical climate change at the end of the Ice Age. Instead of warm winters and cool summers, which support your disharmonious associations, winters became even colder than today. Summers gradually warmed. The ice sheets melted, sent fresh water over the high latitude oceans, forming sea ice right away. So temperatures got a lot colder and drier and so forth. So this has been a mystery for 200 years. A book published in 1999 said, after many decades of debate, the North American end Pleistocene megafaunal mass extinction remains a lightning rod of controversy. The extraordinary divergent opinions expressed in this volume show that no resolution is in sight. Some think it was climate change that did it. Some think that man did it in a huge slaughter. Some think that man spread diseases. So lots of controversy. Some believe in more than one. Anyway, they haven't been able to solve it. So they got a lot of problems that the post-flood one can explain. Anyway, here's the one about the unglaciated areas in Siberia, lowlands. That's where you find the woolly mammoths and the other animals. In Siberia and Alaska, there were at least 40 different types of mammals besides the woolly mammoth. And they're found in permafrost, that is permanently frozen soil at the surface. And there's millions of them based on the statistics I've seen from the Russian scientists, especially the New Siberian Islands right up in here and the coastal areas adjacent to that. And if the sea level dropped 100 meters, huge areas of the continental shelf would be exposed. So it'd be no problem for them to go from Siberia into Alaska. And early in the Ice Age, there would be a ice-free corridor caused by what's called downslope foehn winds off the Rocky Mountains from northern Canada down into Montana, where I live. And so that's where the animals pass through that ice-free corridor. And when they try to model glaciation, it's very hard to produce glaciation in these climate models because they're so imperfect. Anyway, one model actually produced glaciation in 1994. It was published in the Journal of Climate. Anyway, they're celebrating. We got glaciation now. Siberia, Alaska, and the Yukon, including the lowlands, were among the first to glaciate. The first places to glaciate. They're great places for glaciers, but they weren't glaciated during the Ice Age. Anyway, they say we now have glaciation, but mainly outside the area where it existed during the last Ice Age. Oh, no. Yeah, the climate models have lots of problems, which is why I'm pretty skeptical again about catastrophic global warming. A little bit of global warming, I think, is true, but not catastrophic. In summary, the Ice Age was a real event not that long ago. It was real. We have to explain it. It is a major mystery for evolutionary Earth science. Noah's flood caused the transitional climate for an Ice Age. Yeah, Ice Age lasted only 700 years. We don't need 100,000 years for an Ice Age. There was only one Ice Age. Only the Bible explains the Ice Age because of the flood. That's going back to my subtitle. And there will be no future Ice Age. A few concluding remarks. Creationists have a viable mechanism for the last major event in Earth history, while evolutionary scientists are far from a solution. Then why should we believe them for all those older hypotheses? Hundreds of older hypotheses about the evolution of this beastie and its death and extinction. They have all kinds of just so stories, as I call them. Why should we believe them for any of them if they can't explain the Ice Age? Another concluding thought. The Ice Age is an example of what can be done with hundreds of other Earth science challenges to the Bible. And this is crucial. Time is not a side issue. Some people are embarrassed by a short time scale. But a younger time scale sometimes is a key to solving major mysteries that have been lasted for 150 years. Well, how so? Well, they know that the volcanoes cool. And so, but you know, the aerosols settle out within 2 to 3 years. And it came up, if they were pushed up in the upper stratosphere, about 10 years. So each volcano going off, it's stretched out to tens of thousands of years, becomes insignificant in the long, big picture. And so they discount volcanism as a major cooling event because of that. But what if we telescoped all those volcanoes that are post-flood, and even the ones that occurred during the flood? By the way, there's 700 stratovolcanoes, and they're probably all active during the Ice Age. If we telescope all that volcanism to within several hundred years after the flood, we have a major cooling mechanism for the summer. So time's not a side issue, but it's key. Another more concluding thought, the Ice Age is based on the flood. Therefore, the flood, one of the most despised events by the culture, is a real event of the past. Therefore, it is easy to believe the whole Bible, which tells us how to live here on earth and how to go to heaven. That's ended, but I'm going to tell you about some of my resources. I've been working on this for over 45 years, writing articles and books. So as a result, I got a lot of resources out there for all ages, all technical abilities. In fact, I'm publishing another one on the Ice Age, an in-depth one is being reviewed by Creation Ministries International. Anyway, my main book for laymen is Frozen in Time, the Woolly Mammoth, the Ice Age. And it's actually been changed, the biblical key to their secrets, instead of just in the Bible. And as far as ice cores, see, there's a lot of subjects. Ice cores are a big challenge, but when you delve into it and look deeply at it, they're not really a challenge at all. Anyway, there's a book you can get, and it went out of print for a while, but now you can get it print on demand from Institute of Creation Research, The Frozen Record, dealing with the ice cores. Yeah. And if you like DVDs, Kyle Justice filmed me showing these features in the Northwest states about the Great Ice Age. And also he did it for the Lake Missoula flood, the Great Missoula flood. And I even have a book on the Lake Missoula flood, comparing what happened, what did the Lake Missoula flood produce? And comparing the landforms that it produced with those that you see on the surface of the earth today from the runoff of the floodwaters. And we see the similar landforms, but at a huge scale for the Genesis flood. And so you can get that. Oh, keep doing the same mistake. Got to go. And we have some children's book that my wife and I did, teaching about the Ice Age in story form. It's a fun read for young people and adults alike. And we have a sequel uncovering the mysterious woolly mammoth. And for those that need something, a primer on geology, I wrote Exploring Geology with Mr. Hibb. The Ice Age has got a lot of geological stuff, so I've gotten into geology and geophysics over the years. And so this is one of the resources I have for children grade 6 and up, and even adults. There's one on dinosaurs too, I might add. And I wrote the weather book, which has been updated for newer material. It's a homeschool course also. And if you really want to know about global warming, I have a talk you get from CMI, the Great Global Warming Debate. I go through the data and tell you what the data really says. Anyway, I want to leave you with this verse. Your faith, from 1 Corinthians 2:5, your faith should not rest in the wisdom of men. That the wisdom of men is doctrines from the Enlightenment, deep time, the flood is not real, evolution that came later, by the way, because of uniformitarianism. It should depend on the power of God. God has the power to cause a flood, to create and do an ice age. No sweat. That's where our faith should be, not on the wisdom of men. And here's a few websites that would aid you. Creation.com is my favorite. Has over 11,000 articles for various age groups and various depth to them. I have a website, michael.ords.net, and on that I have 2 free ebooks you can get. Just read them. One is on the evidence of the runoff of the floodwaters in the field of geomorphology, the evidence that we had runoff that produced all these features on the surface of the earth that they can't explain. And then I have another book on where is the flood post-flood boundary, because I've worked inordinate amount of time to figure this out, because I have to separate what occurred during the flood and what occurred during the ice age, so that I have an ice age explanation for what occurred during the ice age and a flood for the flood. And so you can get this ebook, and I've published that book in a lot more detail on the Journal of Creation. So I'm going to open it up for questions now, and pass it back to you, Donnie or George. Still there?
Yes, yes, I was on mute, Mike. I didn't want to give you any background noise during that awesome presentation. I've got to say, that hour flew by. I can't believe it's over already. I'll be re-listening to this probably tonight. So much good information, Mike. Actually, if you wanted to just click that stop sharing button real quick, okay, and I think our main screen should pop up. There we go. There we go. We're good. I want to point out, Mike, a couple of thoughts that came to mind was I love how you point out that the global flood of Noah itself is the perfect event that fulfills the requirements for such drastic climate change, right? Necessary for the ice age.
Yes.
As biblical creationists, we have an explanation for the ice age, while the uniformitarians struggle to explain the necessary conditions for their multiple ice ages. And
cutting out.
Oh, am I cutting out there, Mike?
Yeah.
You're cutting out. So I didn't catch that.
Okay. It looks like your camera's back. Yeah, it looks like it was It was cutting out a bit. George, could you hear what I was saying, brother? Was I cutting out at all?
I could hear you, but Mike's camera was freezing up a little bit, so I think that's why he couldn't hear you.
Yes. Yeah. It looks good though. It looks like whatever you did, Mike, seems to be fixed. But overall, I just want to point out great presentation, and I want to thank you so much, Mike, for all your amazing work. And last thing I'll say before we get into some questions, I'll hand it over to George. We've got a great lively chat. I want to thank everybody in the chat for their amazing support. We've got a ton of questions, super stickers, super chats coming in to help with the show, help with the ministry. But I like the way you ended it there. You pointed out that a young Earth that the scoffers deny is key oftentimes in solving the major mysteries that have been around for over 150 years. So that was a great point, and that really resonated with me. So thank you, Mike. George, I'll yield the mic and hand it over to you for a few words, brother.
Yeah, I'd just like to add a couple of things to what Mike actually said in support of the Ice Age. For those that don't know, there's been some considerable amount of work being done on fossils in Greenland, where they found fossilized leaves, and they could identify the species of these, or they could identify these leaves to a species of tree. And they found that these trees would only actually survive or grow in moderate Mediterranean type climates. So Greenland, for example, was once moderate in terms of climate, and also from written historical records from the Vikings. For those that don't know, the Vikings actually moved to Greenland, and they actually cultivated crops like corn. So Greenland was once lush and green. And as Mike mentioned, these mammoths would have moved to where all the green vegetation was, and they moved further north. And that's how they got caught in that ice age and buried by it. So, Mike, I hope I haven't said anything contradictory to what you said, but that's what I know about Greenland and some of that area adjacent to it.
Okay. You got to determine what is flood and what is post-flood there. Yeah, Greenland has warm climate vegetation at, in the Cenozoic, as they would call it. But this goes along with warm climate vegetation in northern Canada, Siberia, and Antarctica. You find a lot of paleoflora, as they call it, showing warm climates at high latitude. So this just drives them crazy. In fact, the last one, the Pliocene, which was just before the Pleistocene, that had very warm climates. So it's very difficult for them to explain that. But I believe that's from the flood. That the vegetation, as well as some of the animals, like lemurs in the Axel Heiberg Island and Ellesmere Island and Queen Charlotte Islands of Canada, 80 degrees north. All these, they were transported up there by the flood, is what I've concluded. Now, there is a report that underneath the Camp Century ice core, they recently realized that there is some vegetation at the bottom. They found the bottom core after being missing for 50 years, and they analyzed and they found leaves and twigs, and saying, well, it melted about 200,000 years ago. I mean, they think it's been there for millions of years, by the way. So I'm going to write a little article on that for the Journal of Creation starting tomorrow. So that's post-flood there, and yeah, a lot of interesting things on the paleoflora, and I've published several articles on the paleoflora before.
Now, Mike, there are skeptics, and they point to ice core data where they identify deuterium and oxygen-18 isotopes.
Yeah,
and they actually cite peaks in the ice cores to identify 8 unique periods, suggesting there could have been up to 8 ice ages or glacial events, which sort of goes against that one ice age that you mentioned. So how do you actually explain those ice cores and the isotopes found in them?
Oh, yeah. Okay. In fact, I've got a 5-part series being published in the Journal of Creation as we speak. 2 parts have been published, and the next issue, which will come out in about 3 months, maybe part 3 and 4 will be there. I've reviewed. They reviewed all the first 4 parts sent to me, and I've sent them back. So I'm trying to I go through all that stuff. Well, first of all, you look at Greenland and also West Antarctica, you see evidence of only one ice age there. You get only to the bottom, you find what they believe is interglacial, but that'd be the warm period caused by the warm water before it glaciated on Greenland, for instance, like the lowlands of Greenland where those deep ice cores are drilled. But it only shows one ice age. It's only East Antarctica that shows many. And Vostok shows 4. It's Dome C that they key on that shows 8. And it's by the wiggles in the oxygen isotope ratio. First of all, they date these ice cores by matching them to the same wiggles they see in deep sea cores, which were dated by assuming the 100,000-year eccentricity cycle in the Milankovitch mechanism. So it's all big circular reasoning network on how you date Antarctic cores, because you can't date by the annual layers like you can in Greenland. Has nice annual layers just at the top. They thin out and they get diffused and messed up midway down there. But Antarctica has 2 little snow each year, and it blows around, so you can't have annual layers. So you got to go by assumptions. So they date it by deep sea cores, which are dated by Milankovitch. So there's a huge circular reasoning network, not only with ice cores, deep sea cores, but pollen cores, lots of other things that kind of fit it all into this Milankovitch mechanism, they claim, that cycles because of the changes in the Earth's orbit. Jake Hebert and I have written a lot of papers on this subject, if people want to look at the in-depth literature on it. But we would explain, like the Dome C. Let's take the Dome C. It has 8 wiggles. First of all, those first 4 wiggles, low down, are not very impressive. They're not very big wiggles. It's only when the top 4 wiggles where you really get some good oscillations in there. Well, in this series of papers I'm doing, and it's the same thing in Greenland, but different. There's a different situation. But in Antarctica, I believe that these oscillations with rapid accumulation of ice are decadal oscillations in volcanism that occurred after the flood that are unique to each hemisphere. Each hemisphere is separate because you don't have much exchange in the atmosphere or the oceans between the hemispheres. And so the volcanism in the southern hemisphere causes the lower, more glaciation, faster accumulation, and other variables that are correlated with it that causes the glacial wiggles. And when you have a lull in volcanism, it goes to it goes up. So I've correlated all these things, and due to decadal oscillations are oscillations that are a couple decades, maybe anywhere from 10 years to 50 years. That's the time scale, and this would occur during the post-flood rapid ice age. During ice buildup, you'd have these causing these oscillations. And I published the basis behind this in 1990 in my in-depth book, which is out of print. That is due to oscillations in volcanism in each hemisphere.
Well, that's an incredibly informative answer, Mike. That was awesome. I appreciate that. We do have a a super chat that came in. A super chat is just where our supporters will donate to the ministry with a question attached to it, Mike. So this question comes from Nephilim Free. I appreciate the support and the question. He says, question for Ord. Is there much movement towards accepting that ice layers do not represent individual years in the scientific community?
Oh, no, there's no movement in the scientific community. They've assumed they've been there for millions of years, and each annual layer, and like on the top of Greenland, and it's like this on West Antarctica too. That's about that thick of ice, about 20 to 25 centimeters. And as each build up each year, it pushes it down and squeezes it to the side. So each annual layer thins and thins. And if you assume it's been there a million years, each layer becomes so thin, it's as thin as a dime by the time you reach the bottom. That's your annual layer. In our time scale, you can have 6 meters of ice for the first several years. And so it would compress some to say 3 meters, but all the wiggles from storms are not diffused out when you have a higher precipitation rate. So they would be counting storm layers and layers within storms, these oscillations, as a year. Well, we would consider them storms or within storm oscillations in various things like oxygen isotope ratio, because the storm layers annual oxygen isotope has an amplitude about the same as the annual layer in Greenland. So that's the difference. And they're totally into uniformitarianism, millions of years, and they have this model. They date it by flow modeling is one of their dating methods. So it becomes paper thin, and so they count all kinds of wiggles. We know that there's a lot of circular reasoning going on, because when they first counted in Greenland, they got 85,000 wiggles. But when they got about near the bottom of the GISP 2 ice core, drilled in early 1990s, and they counted 85,000, but they said it was wrong because, according to the Milankovitch theory, it should be 110 layers by that level. So guess what they did? They went back and redated the bottom 500 meters using a sophisticated laser light mechanism that has a resolution, instead of 8 millimeters, it's 1 millimeter. And guess what? It got a lot more wiggles down there in that bottom 500 meters, and it magically became 110,000 layers down, or years at the bottom.
Wow.
Circular reasoning based on the Milankovitch or astronomical theory of the Ice Age.
I know this is a bit of rough maths here, Mike, but I was doing a bit of research last night, and I got these numbers from the Australian government Antarctic program. They state that the mean thickness of the Antarctic ice sheet is 2.16 kilometers, with the maximum known thickness of the ice sheet is 4.8 kilometers in the Terrier Dell. Now, I being an engineer, I like a little bit of maths, so I sort of compared that with the average snowfall or thickness of ice above. Sorry.
Oh, I think Mike is cutting out a little bit there. Mike, it looks like your camera might be frozen. It looks like we got you back, Mike. So I'm not sure. It looks like it.
Anyway, I see a lot of questions. Chat.
Mike, it looks like you're. It looks like
freezing.
Your camera might be freezing. Maybe.
Oh.
Mike, maybe shut off your camera for now, and we'll see if we can save some bandwidth. But well, it looks like we got you back, Mike.
Camera, I guess that's.
It looks like we do have you back, though, Mike.
Okay. I have a lot of questions that are piling up here. I see them.
Yes. I want to get to these questions. Maybe we'll do a rapid fire Q&A. Mike, are you hearing us again? Is your connection back?
Yes.
Okay. My
Yes.
recommendation. Okay, perfect. My recommendation would be next time, if it does happen again, oftentimes if you click the stop cam button right next to the mute button,
Okay.
that'll save bandwidth and you won't have that issue again. So
Okay.
so George, we're gonna fire through these questions.
Okay. Okay, I'm gonna do that right now.
There we go.
That's good.
So that should solve the issue.
Okay.
So our next question would be, well, let me see here. A question just came in. At least I could put this one on screen. Question from Baldy Cat. I appreciate the question. What is Michael's view on climate change records specifically?
I'm getting
Are we losing you again, Mike?
Yeah, I can't hear him.
He might want to, I don't know if it's an internet issue or what. He might want to jump out of the stream and then jump back in, just kind of refresh it. Because the last time he was on, we had him on for almost 3 hours with no issues. So maybe if you wanted to just refresh it. Mike, can you hear us at all?
Yeah, I'm hearing you now.
Okay. Sometimes an easy fix is to leave the stream and then click the link and come back in just to refresh it. But if you can hear us now, we can kind of move on and hope that things are fixed from here.
Okay.
Okay, we'll try this for now.
Send a question.
Okay, so the question comes in from Baldy Cats. He asks, what is Michael's view on climate change records?
Well, they've been taking measurements of temperature. Now, there's a lot of glitches in those temperature records. So they claim about 1.6 degrees Fahrenheit or 1 degree centigrade warming since about 1880. But, and especially in the polar areas where it's amplified because the snow and ice is melted. So I believe all those records, but I think the temperature record may be exaggerated, but I'll take it for data to start with. And we know the CO2 has been going up, but we can run correlations.
Mike, it looks like you're kind of breaking in and out. I think we're losing you. Did you want to maybe exit the stream?
Rising.
Yeah, Mike, we can't hear you. It might be a good idea to leave the stream and then come back by clicking that link.
Oh wow!
That Standing sent you in the email.
It sounds like it's a connection issue, possibly on your end, Mike. So sometimes if you were to, we've had this happen before with guests on, and typically when they leave the show and then kind of refresh and come back in, usually that fixes it. And then George.
Yep.
I'm going to go over a couple reminders and announcements for the. Okay. I'm going to go over a couple announcements, George. If you wanted to mute yourself and give Mike a quick call, because he did give us his number to give him a call if there's any glitches. And at the same time as you're doing that, I can go over some reminders with the audience. Might be a good time. So I wanted to remind everybody that tomorrow we have our third event for the Genesis Flood Week on Standing for Truth. We have Sal Giardina back with us. We're going to be discussing how geology demonstrates and confirms the flood. We're also going to be having a Q&A that kicks off at 8 p.m. EST. So make sure you're here, bring your questions. Should be a lot of fun. It's going to be Sal's second time with us. And let me see. I think I got... Mike, it looks like your camera is... Can you hear me, Mike? We've got you in the stream, Mike, but I'm not too sure if you can hear me or if your connection's improved at all. Okay. We'll wait for George to call.
I don't have his email with his phone number standing.
Okay, here, let me get it for you real quick, because it's definitely a connection issue. Let me see. I'm going to put it in the private chat, George.
Okay.
Just 1 second.
Hello?
Oh, there we go.
Mike, we got you. Can you hear us, Mike?
I got some great questions here.
Yeah. Is the connection improved, Mike? Can you hear us?
So, what are we going to do?
We can definitely start asking you some of these questions, Mike. I just want to make sure that your connection is okay and you can hear us at this point. Are we coming through, Mike? Can you hear us? Okay, I'm going to give Mike a call real quick, just so.
United States and for connection. The internet's up.
We do see a couple comments in the chat. Somebody saying that they had this earlier on their podcast. The internet gremlins are out today, he's saying.
Can I suggest something standing? Michael, is there someone else in the household that may be using the internet at the same time?
Okay, here, I'm going to go on a intermission here, and I'm going to give him a quick call. So I'm going to put so we'll be back in just a few minutes, guys, just so we can fix this. We'll try one more time with Mike.
He's coming back.
Any improvement at all, Mike? Okay, we'll be back, guys. I'm going to go on a brief intermission. I'm going to give him a call.
Yeah, there.
Mike, can I ask? Is there anyone else in the household that may be using the internet at the same time as yourself?
No, because I have the laptop up in my office and I have the other computer here. So
Okay.
no, I got both computers. And I can hear you. I heard that.
Maybe there's an improvement. We might be good now, Mike. So is our audio coming in okay now?
Yes.
Okay. Maybe we're in luck. Maybe it was just a couple minutes there of connection issues. But if you can hear us, we can jump right to the next question if you want.
Okay, let's go for it.
All right.
SFT, standing, would it help if you turn off your camera as well?
I can try. I don't think it's coming from my end, but we'll see if there's an improvement. And there's so many questions there. So George, since I just asked the one on climate change, you pick one of those questions and we'll run with it. Maybe we'll go with Ryan the Raptor guy's question, George, since he asked it a while ago. Go ahead, brother.
Okay, Mike. Ryan the Raptor guy has asked a question. Does Dr. Ord think the unfossilized rhinos, horses, and other animals at the ashfall fossil beds from the flood or post-flood. I'm not familiar with the ashfall fossil beds. Is he talking about the Ashley fossil beds?
No, ashfall fossil beds in northeast Nebraska. I'm familiar with them.
All right.
That was a tough one. I had a debate with Carl Frody about it. He thought they were post-flood. I examined it twice, the site and other features. And even though there are features there that would indicate post-flood, I determined I think it's flood. And I gave several reasons. I have 33 criterion to determine the boundary, and I use those criterion. One of them was a formation of gravel, quartzite gravel from the Rocky Mountains that was spread clear out into Nebraska that was associated with them. And that's a flood signature, a spreading of resistant gravels. By gravel, I mean up to cobble size out there. And that's to me is a big signature that it was from the flood. And let's see, what else? There were several other things. And some of the animals that were fossilized were not ones you see during the Ice Age at all. There were some really strange ones. But like I said, there are other indications that it's from the flood. So that's a tough area. Most areas where I've evaluated the flood post-flood boundary, I've found it fairly easy. But that's one of several that I found it difficult. And I had to look at all the data I can before I made up my mind. And I think it's from the flood. And I've written about it. It's in the Creation Research Society Quarterly, what I wrote about it. And what Carl Frody wrote about it.
Mike, one of the evidences that I point to with the Ice Age is the frozen stomach contents of the animals that were fossilized. In the secular sort of scenario where you'd get an Ice Age occurring slowly and gradually over time, that piece of evidence just contradicts that slow, gradual Ice Age. And would you like to talk about that, the frozen contents in the stomach of the mammoths as evidence for a global flood and a quick Ice Age?
Well, it would be evidence that they were frozen pretty fast. So the main question has always been how fast. Bird's Eye Frozen Food Company said, well, it has to drop instantly to 150 degrees centigrade or Fahrenheit, I forgot which, below zero. Flash frozen, in other words. And I looked at the data and found that as far as stomach contents, you find some stomach contents with mastodons in the Northeast United States, and no one believes that they were flash frozen. Also, the state of vegetation in the stomach indicated different seasons of death for those mammoths. And a flash freeze would have happened all at once in one instant, according to people who've written about it. And so different seasons indicated that they died at different times. Also, I examined the digestive system for elephants. Elephants and mammoths are very similar. And the digestion system, the food does not digest in the stomach. There's acid there that partially breaks down the vegetation. The digestion occurs after the stomach for mammoths and elephants. So the stomach is just mainly a holding pouch for their food, and it's partially decayed, but you have to freeze it fairly fast. So I postulate a moderate freeze from cold fronts, from when it was much colder in winter in Siberia than now. And they're interred in the permafrost because they're in windblown silt, and the permafrost comes up into the windblown silt, as well as the cold air freezing it from the top. So it was a moderate freeze at the end of the Ice Age. And that's when they all went extinct at the end of the Ice Age. I hope I answered that question.
Yes, you did. That was a great question and great answer, Mike. Here's a question that has come in quite a bit, a question that I have on my mind as well. And since you're here, and I know you've written on this in your book that I've got in front of me, Rock Solid Answers, the question essentially is, do Varves, the existence of Varves, contradict young Earth creation and the global flood, Mike?
Oh, yeah. Well, a lot of secular scientists think so. But when you look at that extensively, which I've done, I wrote a two-part article on it in the 1980s in the Creation Research Society Quarterlies. I especially examined the Swedish Varves. First of all, you got to realize that these Varves are really rhythmites, alternating two or more subcouplets. They're rhythmites that form in 1 year, they believe. But you can form rhythmites like turbidity currents, distal or the finer turbidity currents will have multiple rhythmites. In the Muir Inlet, that was glaciated in about 1700. The glacier's been receding, and you've had heavy sedimentation, and you've had rhythmites form as much as one per day from the mud and stuff that's given off by the glacier that's receding. So you can form more than 1 year. So they're not necessarily Varves. They have to prove that they're a 1 year cycle, and they can't do that. And these Varve scales are just short sequences of rhythmites, maybe about we'll say 200 in one area, and then you go and they try to match the wiggles in the Varves, the dark and the white layers and the thick Varve layer sequence with the bottom of another. And so that's how they did this all the way up through in Sweden north, and got about 10,000 years. They did it in Northeast Canada and Southeast Canada, the Northeast United States also. And it's all superficial and based on assumptions that there really are Varves, that you can really connect them like that. Dozens of sequences connect the bottom and the top of one or the other. So, yeah, you have mechanisms to form rhythmites fast, and a lot of different types of scenarios. So the Varves really do not show what they think they are. They're based on too many uniformitarian assumptions.
Yeah,
Well,
Mike. Yeah, Mike. On that one, I believe there were cores done at Lake Sagutsu in Japan, and in two of the cores, they found ash layers, and the number of layers between the ash layers were different. So if they represent years, then why did we get more, Varves in one core than the other?
Oh, yeah. You have those situations. Also, the Green River Formation has 6 million of these rhythmites in some places. And yeah, they don't correlate between ash layers there either. So there's a lot more going on. And you can form these rhythmites rapidly by especially turbidity currents, what they call distal turbidity currents. That's after they're then transported a long distance, they thin out and they form layers. They form layers. And so you find a lot of these in the rock record, these rhythmites. And so they are always trying to make a case that they're Varves and or 1 year oscillations, and it's speculative on their part. And so a lot of this, like the Lake Sugistu, if I pronounced it right, in Japan, a lot of this stuff is just dated by assuming the Milankovitch mechanism, and that stretches out the last ice age 100,000 years and so forth and so on for each other ice age. And so they blend things into these time scales, and a lot of this is circular reasoning with dating methods that are questionable and based on assumptions and uniformitarian assumption. So there's a lot more that I can say and write about it. There's a lot more research projects involved in all this for the post-flood time scale. Anyway, that's about all I can say about Varves.
Yeah, that's a really helpful response, Mike. That was really good, and I appreciate that, especially on such a common objection from the uniformitarians, an objection that they almost say is unanswerable by us. But, you know, as you've shown here, you've given a great answer. I appreciate that. This question I have here, Mike, kind of brings us back to the post-flood ice age in terms of biogeography, because the question is, Mike, do floating log mats, do you believe they help explain at least some of the Earth's biogeography post-flood?
Oh, yeah. Land bridges. There was a land bridge between France and England that broke during the Ice Age, and that's how the hippos got over to England. There was a land bridge between Siberia and Alaska, and I think this land bridge was exposed early in the Ice Age because some of the mammals that I analyzed that rounded it and where they're found told me. In fact, I wrote a paper on that in the Journal Creation, I think about a year ago, on the land bridge, but others have to be explained by the log mats. For instance, I think the Australian marsupials have to be explained by log mats. First of all, I have a paper that I've submitted to Journal Creation on these marsupials, and first of all, when they found them, they thought they were all Pleistocene, which means the Ice Age period. But then because they date, they actually have a unique dating system for those marsupials. It occurs in South America and North America too. It's called stage of evolution. So when they find a particular marsupial, they say, well, that's a little different than what we expect. It's got a primitive feature here. Oh, primitive. Oh, it's got to be older. So let's shove it into the Pliocene or the Miocene. So they keep shoving these things back based on the stage of evolution. That's how they've been dating there for years. They have very few radiometric dates to lock all this in. And so it's all a house of cards. And then I always try to explain how we would explain. I mean, the Lord's led me to answer challenges. And so I got to say, how did they get there? Well, I think the only way we can explain them, they couldn't have got there by a land bridge from Southeast Asia, because there's too many deep straits in Indonesia between Southeast Asia and Australia and New Guinea. And so I don't think they could have got there on a land bridge, or I don't think they could have gone there by island hopping either. So the only possibility is by log mats, where they they migrated south, maybe in mass. I don't know why they stayed together, but it appears that they stayed together and ended up on the shores of the Indian Ocean somewhere. And log mats were floating around. Some were beached, and they got on these log mats, and they were spread hither and yon, and ended up in Australia, probably northern Australia to start with. And other features of that I noticed that would support this is that some of the animals that had to be on log mats were snakes, and other creatures besides marsupials, and some insects. So and they couldn't have got there by even a land bridge. So they have to come by a log mat regardless. So the log mat idea, I think, seems pretty strong. And so the article's in review right now, and maybe will come out in a year, depending on how fast. Publishing's very slow, by the way. Sometimes it takes 3 years for something to get out that I do. So I find it frustrating that it's so slow. By the time they get back to me, I've forgotten half about what I wrote.
Yeah, I can see how that would be frustrating. We kind of talked about that last time. And it's even frustrating for me. I'm addicted to reading these articles and papers. I've spent a great deal of time reading through your huge number of articles and papers coming out of CMI. And this question I have is it pertains to some articles you've submitted in regards to some possible objections regarding the fossil distribution of animals post-flood, including the marsupials, as it relates to your position on the post-flood boundary. Now, I know we could probably talk about that all day, but for the audience sake, especially some of the new viewers, I was wondering if you could touch on some of the content in those articles and papers that you've submitted in terms of refuting those objections. Mike?
Oh, okay. Let's see. I submitted them 6 months ago, 4 of them. The Australian one was, actually there was 2 of them for Australia. One was to explain how I would explain how they got there. And second, he did critique with the uniformitarian ideas. Then I had one on North America. The key question is, we have a lot of mammals in North America in the Cenozoic, and it's claimed that they have to be post-flood. So that's been the question all along, and I've examined that. And first of all, the person that challenges me on that set up several straw man arguments, saying that if I believe that those Cenozoic mammals are from the flood, what I have to believe is that before the flood, that they left North America, rounded the Bering Land Bridge to where the Ark was, somewhere in Asia. And then after the flood, they migrated back to exactly where, after the flood, for the Ice Age fossils, and they died exactly on their Cenozoic representatives in the Cenozoic rocks. Well, first of all, we don't have to migrate them from North America to where the Ark was. They could be living near the Ark or on one big landmass. North America wasn't existent then. Secondly, it was claimed that the climate would be too cold for them to round the Bering Land Bridge in Siberia. They were thinking of present-day climate. No, during the Ice Age, it was a mild winters and cool summers, as I said in my talk. So a lot of them would have no climatic problem rounding the Bering Land Bridge after leaving the Ark. And so mammoths and 40 other creatures, mammals, came into Siberia, Alaska, then down the ice-free corridor in Alberta and Montana, into the southern United States and Central America and South America. That's how they would go after the flood. And so So that there was some straw man. But anyway, I looked at the North America genera that were supposed to be in the Pleistocene, defined as post-flood, and the pre-Pleistocene was defined as a flood from my point of view. And I found out that a lot of these North American mammals, see, it's the claim that why would they migrate just to North America and die with their ancestors? Well, the problem is they're not necessarily North American mammals. You find them on other continents. You find them in Asia, in Europe, Africa. So we're not talking about unique North American mammals rounding the barren land bridge and dying above its Cenozoic ancestors, from my point of view. No, not at all. The Cenozoic mammals could be transported long distances from who knows where. So I've answered a lot of that stuff, but there's still questions that need to be explained. And I was planning on writing 2 or 3 more papers, but I got bogged down into other projects and have not got back to that. So it's been 6 months since I sent it in, and I haven't heard anything yet. So I don't know how it's going.
Well, I got to say,
that's a quickie on that.
That's great. That's a great answer. Extremely helpful. And I got to say, I'm looking forward to hopefully those articles being released at some point, and therefore going through them and reading them. So that was a great answer. And I think we all wish there was just more time in the day, given how many projects, just how many projects you want to get through. So, George, I know you had a question as well, brother. Yes. I don't want to hog the mic here, but George, go ahead.
Yeah, Mike, there was a question from Andrew P. that was posted early into our presentation. He's asking how to explain, and I hope I don't butcher this, and I hope you understand my pronunciation of it. He says, asking how to explain lacustrine indicators in the GRF and the Bidahotchi formation, such as exploded fossil fish, basin-centered paleocurrents, and Mar craters. That question is in the private chat if you want to read it yourself.
Yeah, I did. There's a lot that can be said. You got to figure out where the post-flood boundary is and all this stuff. And there's ways to interpret like the Green River Formation as post-flood lake, and there's other ways to look at it. John Whitmore and I had a debate about this very subject in 2006 in the Journal of Creation. You can get it all online from creation.com. And anyway, he pointed out what he thought was a post-flood lake. He wrote his PhD thesis on the fossil fish in the Green River Formation. We spent a week together out there looking at various features. And one feature I noticed he overlooked was that the huge amount of erosion in the area. That's the thing that first got me. You go to one of the basins, Fossil Basin, and you can go up over 2,000 feet up a slope. And all the sediments in that whole area were at least eroded 2,000 feet. Now that is an incredible amount of activity after the flood, but that's not the end of it. I discovered in the southern part of the Green River Formation that the Green River Formation was part of what's called the San Rafael Swell. That's a big bowing up of the strata, about 100 kilometers north-south and about 50 kilometers east-west. And the middle of it got eroded off, leaving the edges dipping away from the center. And by trigonometry, I calculated based on the 8-degree dip of the strata to the north, with the Green River Formation being the top formation, I discovered that the San Rafael swell was eroded about 17,000 feet. 17,000 feet of erosion in the center of it. And the Green River Formation was the top formation on that San Rafael swell. So what does that tell you? If it's post-flood, you got to deposit the Green River Formation over a huge area, 40,000 square miles, up to 6 kilometers deep near the Uinta Mountains, 6 kilometers deep. And then you got to bow up this swell, erode it, all after the flood, rode 17,000 feet. And where did the sediments go? They're not found anywhere nearby. They're swept clean off the continent. This is an obvious flood signature. And I published this article. You can look it up in 2009 in the Answers Research Journal. Not only that, the Green River Formation has so much oil in it that it has enough energy to supply the energy needs of the United States for 100 years. Where are you going to get that much oil after the flood in a lake and get that thick of sediments over a huge area? No, so much of it doesn't make any sense for a post-flood lake. But like I said, there are indications there that would indicate that. So something happened in the flood to account for some of those features that they talk about as evidence for the post-flood lake. And John Whitmore did challenge me in a few areas on that, and I haven't any answers on a flood formation. The flood waters were draining. So that's it for the Green River Formation. The Betahoche Formation is a little more complicated. You're going to see something about that for those that actually subscribe to the journals. Recently, Steve Austin and 2 others defended the dam breach hypothesis for the origin of the Grand Canyon, which I believed at one time until I went out there and looked closely and found so many contradictions that with time I gave it up. I didn't give it up right away. I was hoping those that believed in it would answer it. Betahoche Formation is part of this. But anyway, they wrote in the early 2020, they wrote an article in the Answers Research Journal. Well, anyway, I've done a response that'll be published in the Creation Research Society Quarterly in the next issue, going through their challenges and answering them. And the Betahoche Formation is it's intriguing. It's mostly a volcanic or fluvial deposit. There's a little bit of what's called lacustrine. Now, by the way, lacustrine, and this goes along with a lot of other paleoenvironmental deductions. Those are all based on uniformitarian assumptions. Lacustrine, generally what they call, they define it as lacustrine. They find some rocks, cobbles, rounded. Well, that's automatically fluvial up from a river. And so on and so forth. They got dozens of these paleoenvironmental interpretations, all based on crass uniformitarianism. You bring the flood back, and these things are not necessarily lacustrine, even though late in the flood you could have some pockets of lacustrine that look like lacustrine formations. That's probably how I explain the Green River Formation. So fluvial, of course, would be runoff. I find a lot of rounded rocks in Montana and Washington and Wyoming, and that were eroded from the western Rockies, clear out into central Saskatchewan, southwest Manitoba, central North Dakota, to 800 miles from their source. Rounded rocks, quartzites, resistant, tough rocks. And they would just say these are from rivers. Well, they're all over the place. They form sheets, billions, trillions of them, east of the Continental Divide. They came from west of the Continental Divide, 800 miles. So to them, this would be fluvial. To me, it'd be flood runoff. So you could see that the various mindsets define the terms. So the term lacustrine is a very vague term, as well as many other paleoenvironmental interpretations. I hope that answered the question kind of in a roundabout way.
Well, yeah. Well, that was a very in-depth answer. Actually, I think Andrew would be happy with that. I'm not sure where SFT has gone, but I've got just one more question to ask with regards to the magnetic polarity changes. You recall I mentioned the ice cores earlier, but
yeah,
they claim that there's been a number of magnetic polarity changes in those ice cores. How do we explain those?
let's see. I don't believe that they're in the ice cores. They're in deep sea cores.
Oh, sorry. Yes, you're correct.
Well, Humphreys, I think, has a great mechanism that during the flood there was a lot of oscillations in the magnetic field reversing rapidly. You can look in his material on that, and then but it continued after the flood and damping out during the ice age. And I go along with that model. Yeah, this is, and then they got a whole time scale called the Standard Polarity Time Scale. And this was developed in the 60s by potassium argon dating. See, they had to date all these accurate so that they can get reversals and normals with time. And I think there was a lot of fudging that went on in all that data. But by the way, in the 60s, the potassium argon dating method was not very good. And so I think there's a lot of shenanigans that went on in developing this polarity time scale. But be that as it may, we need to explain the evidence for reversals, and which are about 50% reversals in like lava rocks and in marine sediments too, and the normals. So I would use Russ Humphreys' a mechanism for the magnetic field. I think it's a pretty good model, and that explains them. And they continued for a while during the ice age. And by the way, they talk about dating these things. They have, if you saw the polarity time scale, the last reversal was about 780,000 years ago. Went from a reversal to the Bruns normal, and they use that boundary to date other things. By the way, lots of circular reasoning. But when you look at the literature on this, I should publish an article. It's one of those many articles I need to publish but don't have time. When you look at the Bruns normal, 780,000 years, you look at it, and there are short segments of reversals through it, about 10 of them, where the polarity went from normal to reverse really quick, and they call them excursions. One of the main ones is called the last camp excursion, 42,000 years ago on their time scale, where it reversed and lasted several hundred years and went back to normal. Well, with so many reversals and normals throughout this time scale, you can have very precise dates to really pinpoint all this stuff. And that's where the problem lies, is that it's just too complicated for them to really do that. The dating methods aren't that precise. And there's so many of these reversals, not only the main ones, but also these excursions, which are supposed to be tiny ones that last a short time. And sometimes they don't reverse totally the whole way. And so many of them, it's just a mishmash of polarity changes. So I consider it a big problem. By the way, paleomagnetism doesn't date anything because it's just a sequence of reversals and normals that if you include a faster sedimentation rate or a hiatus somewhere, you can make any sequence in the deep sea cores fit the polarity timescale by adding faster sedimentation, slower sedimentation, or a hiatus, a gap. And that's what they've been doing all this time to make everything fit and look like it's really consistent, and it's not. Anyway, I should write an article on that. Anyway, what they do is they have to date these reversals by other mechanisms. They got to say, is this sequence Pliocene 4 million years ago, or is it Cretaceous 100 million years ago? So they date by other mechanisms to put the same sequence in various slots. And so it has to be dated by other mechanisms. So in itself, it's not a dating method. It depends on the other dating methods. Same with the Milankovitch cycles. They depend on other dating methods to calibrate it. For what time periods, the Pliocene, Cretaceous, you don't know unless you date it by another method. So there's a lot of circular reasoning and correlating one dating method to another. So there's a lot of problems in all this. And I've only touched on the part of the iceberg above the water.
Well, I just want to say one thing, George, because I want to point out how I love how thorough your answers are, Mike, and there's just so much good information. Even in just this one show, we've had people in the chat point out, they're going to rewatch this a few times just to get all the information. I really love your passion on these important topics. And a question that came to mind based on what you're saying, because to be honest with you, your answers are so informative and thorough that you're answering a lot of questions that we have all in one. For example, the dating method question. I've heard the critics, I've heard the uniformitarians say, we've got so many different dating methods that all corroborate each other. They all correlate on deep time, right? But from the sound of it, you're pointing out that is that based on circularity, or what's the answer to that?
Yes, it's based a lot, mostly on circularity, where they correlate one method to another. In fact, Marvin Lubenow actually demonstrated this because, they don't publish a lot of dates, so you can't really check all this stuff. Anyway, there was a big dispute over Leakey's 1407 skull. I think that's the name of it. And they had to piece it together from several hundred pieces. And it was first dated 2.8 million years by 6 different methods, one of which was paleomagnetism, 2 were fossil dates. So 6 methods, and they all agreed it was 2.8 million years. And that's what they published. Oh, but the paleoanthropologist said that skull, which is pieced together, is too modern. It can't be that old. So they redated it and used 5 out of 6 of the previous dating methods. And lo and behold, they got 1.8 million years. And five of them agreed with that. And so he's in his book, Bones of Contention. The first edition he has it, but in the second edition he left it out. And I really had a problem with that. But anyway, it's published online on creation.com. You can obtain it there and show how these were all correlated, make them look precise. It's all through circular reasoning that they did this. And this is probably just the tip of the iceberg for this sort of thing, because we can't verify. Oh, by the way, they found some old dates on some of them to over 200 million years were some of the dates that they got back with argon, or potassium argon method. I can't remember which. And then they threw those out, and then they got other dates that were 6 million years and 4 million. They got a lot of dates. Anyway, they pick and chose the dates that were closest to what they expected. And it's admitted I got a great quote where they actually pick and choose the dates that agree with what they believe from geology. And John Woodmarape has other great quotes in some of his books on how they pick the date that they believe is true out of probably a smattering of dates. So anyway, it's all a bag of worms. if people want to know more about it, I actually have a book on dating called The Deep Time Deception, Examining the Case for Millions of Years,
Right.
put out by Creation Ministries International. So I do touch on these things. This book was written for total laymen that have no science background. So it's not very deep. They want to get some deep stuff, look at Andrew Snelling's stuff. But anyway, this is for laymen to get them started and to show the case that we can defend a young Earth. And there's lots of problems with these dating methods.
I've got that quote, Mike, if I can read it. It's by E.H. Andrews, Professor of Materials, University of London, and Head of the Department of Materials at Queen's Mary College. In a book, God, Science and Evolution, he says, quote, "Whatever the figures arrived at by the dating tests, they are weeded out before publication in scientific journals. If they do not accord with the preconceived dates assigned to the Evolutionary Geology column." And then there's another one by Richard L. Morga. He's Associate Professor of Geology at East Carolina University. He says, in general, dates in the correct ballpark are assumed to be correct and are published, but those in disagreement with other data are seldom published, nor are discrepancies fully explained. And I've got more quotes that say that, but yeah, the KBS Tough is an embarrassment, isn't it? With the
yes,
the range of dating methods that they used and the range of dates that they received that contradicted each other.
Right. I hadn't heard those quotes before, but I got other ones.
Yeah, like I said, there's heaps of them. You just have to search.
Yeah.
There's quote after quote of them admitting to the circularity. Mike, I want to point out that was a great answer, and you have so much good material available for everybody. That's why it's such a blessing to have you on. And I wanted to ask something based on what you were saying earlier. You were pointing out how you've had some cordial debates and dialogue with fellow creationists on some of these issues, right? And
yes, I have.
And correct me if I'm wrong, because I've read so much on CMI, but I do recall, I believe that you've had a written debate on some of these issues with Dr. John Baumgartner.
Correct.
Okay. I was kind of curious. What were a couple of those issues? What was the debate on, the bigger picture? I find that interesting, and I have read through that. It was a while ago, but it kind of came to my mind when you pointed that out, Mike.
Yeah, I think it was in 2002. There's an online debate in the Journal of Creation with John Baumgartner and myself on catastrophic plate tectonics. As some of you may know, I believe there's evidence for it, but since I read, try to keep up with 50 earth science journals, I find a lot of contradictions, problems with it that aren't solved yet. And I wish they'd work on them and solve them. And I can easily believe catastrophic plate tectonics, but I see so many problems with it that is why I'm skeptical of it at this point. So there's for instance, I've done a lot of work on what's called subduction zones, trenches. There's lots of anomalies there that make one question the plate tectonics and the catastrophic plate tectonics model. But one I just published in the Journal of Creation maybe 3 or 4 years ago was that I don't get into this too much. It's a subject I don't really like getting into. I don't spend a lot of time on it, but I do publish a few of them now and then. And one was 4 years ago, where I discovered that there's these deep sea fans. That's right, deep sea fans that started on the North American plate and spread onto the Pacific plate during the Cenozoic. They dated the Cenozoic. And if there was motion of the Pacific plate compared to the North American plate, which is about 6 centimeters a year to the northwest for the Pacific plate, in relation to the North American plate, which includes not only North America, but Alaska and Northeast Siberia. You should have seen about 1,000 kilometers change, and you should see no consistent deep sea fans going from the North American plate to the Pacific plate during the Cenozoic. And yet you do. You have one that actually crossed from southern Alaska, went south. And it's called the Zodiac fan. It actually is south of the Aleutian Trench, and even the fan is south, and it's a couple hundred meters thick. It's very wide. They know it came from Alaska. The paleocurrent directions and stuff indicate that, and it wouldn't be consistent. You wouldn't have seen a fan like that from Alaska if the Pacific plate was moving relative to Alaska. And then you go to northwest part of the Pacific plate. You have the Meiji fan that started the North American plate and spread onto the Pacific. And there's no disruption of that over the 1,000 kilometers it should have moved. The plate should have moved relative to each other. So I find stuff like that. And that's published. You can check it in the Journal of Creation. There's another one, the which isn't so convincing. It's the Monterey Sea fan that spread from North American plate near Monterey across the Pacific plate. And it doesn't show any north-south movement between the plates for all the Cenozoic that fan supposedly was being deposited. So I find lots of glitches. I think down the road, I'm going to spend more time looking at it. And right now, I don't spend a lot of time on it. And so 2002 was the debate I had with John Baumgartner on it. It's pretty old. And so you can read it on the creation.com website. And so he believes what he believes, and I believe a little bit of what he believes, but I was a weather forecaster for 30 years, and so when there's a lot of uncertainty, I would give probabilities. Like there's a 20% chance of rain today. You've heard them. And anyway, I use probabilities for some of these things. And so I give catastrophic plate tectonics a 20% probability of being right, 80% chance of being wrong at this point. But those probabilities can change with further information. I might end up believing it one of these days, but I need to be convinced on a lot of anomalies.
Well, so many great points there, Mike. And I do remember reading that. And I'd recommend all of the articles and papers that we've kind of referenced and sourced today. I want to respect your time because we are going on 2.5 hours, and therefore maybe out of these 1,000 questions we have, maybe I'll pick out one that kind of sums up many, because there's a question here that I believe does so. And the question, Mike, is, and I believe you've written on this too. I remember reading an article on this. Are fossils as neat and organized as the evolutionists would have us believe? Or are there any out of order fossils? Mike, what are your thoughts on that?
Oh, okay. Well, there's certainly a lot of out of order fossils with overthrusts, but I believe that many of these overthrusts are real. I was skeptical at one time, but I've come around to believe that most of them are real. Yeah, I run into them now and then. For instance, dinosaurs. I've run into 6 research reports of finding dinosaurs above the Cretaceous into the Paleocene, or Paleogene as the Europeans would look at it. And they've been eggs or tracks or something like that, or bones. And there's a statement by a famous dinosaur researcher that says that that we actually date the strata by the dinosaurs. You find a dinosaur, it's automatically older than 65 million years, and we don't find them above. So there's a lot of some circular reasoning there. And these other ones, they claimed were reworked. They have that one where in the Paleocene, it was eroded from a Cretaceous sediment, and the fossil went with the erosional debris and was deposited in the Paleocene. So that's usually what they say. But eggs and tracks, you can't do that because they don't erode. So they just simply redate the strata and say, hey, this is not Paleocene, it's Cretaceous. So they do that. But one in the San Juan Basin in New Mexico, they found some big dinosaur bones out there that were claimed to be Paleocene, above the Cretaceous Paleogene boundary. And the guy is sticking to his guns. I haven't read anything on it, but these are big bones. You can't really rework a huge dinosaur bone from the Cretaceous up into the Paleocene. So I haven't seen any responses. I haven't seen what they say about it. It's just kind of left hanging as far as I'm concerned. They probably don't know what to do or say. But this is kind of how they do. So you're not going to find too many out of place fossils because they make them in place, a lot of them. But there is order to the geological column in the fossil order. I go along with the general geological column and a general fossil order, but I've run into enough exceptions that I'm kind of skeptical of a precise order that they claim occurred based on evolution over deep time.
Mike, in a recent debate on this channel, an atheist who was debating a Christian stated that if there were fossils found, dinosaur fossils found above the iridium layer that was caused by the Chicxulub impact, then that would disprove evolution. I've got news for that guy. Dinosaur bones or dinosaur fossils have been found above that iridium layer.
Yes,
paleontologists have reported on it.
Right. And they just explain it away by several possibilities, of which I mentioned two: reworking and just redating the strata.
Yeah, that's why it's unfalsifiable, because they always have a rescue device for whatever contradictory piece of evidence that we find. And that's why it can't be a scientific theory, because they have all these rescue devices.
That's right. Rescue device is a very good term for them.
Yeah.
Well, I'd wonder, George, if that specific individual you are talking about, if he saw that information that he said would convert him away from evolution, if he would actually convert or do what Mike said, rework and resort to circularity, because I would probably bet on the reworking, as they're so good at. So that being said, I want to respect Mike's time. We're going on 2.5 hours, and I want to thank the audience for so many great questions. I mean, we could probably ask questions all day, and Mike, I could listen to you all day. You're incredibly thorough, and your presentation was awesome. It's a must watch. It's an honor to have you on, and we're happy to have you on anytime again in the future as well. So Mike, thank you so much again for giving us your time. I also want to hand it over to you for some final thoughts and some final words.
You're welcome for the compliments, and I hope it really blesses people. In fact, that's the point of the ministry that the Lord's led me to try to answer questions. And so I've done this, and there's a lot more to go. And so that's why I keep working full time, including Saturdays. I just hope hopefully the Lord will give me good health my later years. And so I will keep on keeping on, and I hope it blesses people.
Amen, brother. Amen.
Amen, yeah.
You will be in our prayers, of course, because you are an incredible blessing, and this really was a blessing, and so many people are profiting from it. Your answers have been incredibly helpful. George, thanks for joining me as well to help host this event that I think was so great. George, did you have some final words, brother?
I'd like to thank Michael as well, but I'd also like to apologise to him because it seems these streams just give him more ideas for more articles to write. So, sorry, Michael.
Yeah.
Never-ending projects.
I'm working on one that's going to be at least 5 parts right now. They actually discovered, or actually have measured, the amount of sediments in the ocean. And so I'm working that backwards because that sediment came from the runoff of the floodwaters, practically all of it. And you know what? The amount of sediments in the ocean indicate that the amount of erosion on the continents was about 1,900 meters. 1,900 meters was eroded during the recessional stage of the flood. And it's in the ocean, various places, especially the continental shelf. And they all got this all measured all over through the ocean. It's pretty hardcore. And so I'm working that and working it backwards to say, what does it say about the late flood? First of all, a lot of huge erosion, and I've calculated 3 areas of erosion that are giving me big numbers, so it's about right. And then we got to say, well, we have about 3,000 meters left of sediment on the continents. The exact number is variable. We're getting various researchers that give us various numbers. I'm doing this with John Reed and Peter Klevberg, and so if you have 3,000 meters and add another 1,900 meters for approximately 5,000 meters at the peak of the flood, what is this saying about the early flood? You got to generate enough sediment to have 5,000 meters at the peak of the flood. Wow. Where does that come from? I mean, there's a lot of questions working it backwards. We got 5 papers already semi-outlined out, and I've done almost the first 2. So that's what I'm working on right now.
And Mike, we've done quite a few streams on erosion. I mean, the secular erosion rates suggest that the Earth's dry landscape should have eroded within 10 to 12 million years. So that's a problem for them. Even when you consider orogeny or uplift,
right?
You still can't get that figure down like 10 to 12 million years. Like that's like the landscape eroding 300 times in that life of the Earth, the deep time life of the Earth.
Right. They got a lot of problems trying to explain that. But I'm trying to explain from the flood what's there. We finally found out what's there in the oceans, and I'm trying to figure out what's there on the land, and I'm getting different numbers, but it's getting to be about 3,000 meters about, if I averaged several of them. So that the sediments, where they're at, that tells us a whole lot. Huge. I think at least 5 papers are going to come out of this, and probably send them to the Creation Research Society quarterly. So your readers should subscribe to the Journal of Creation, the Creation Research Society quarterly. If they don't, they'll see all kinds of good stuff, new stuff by me and a lot of other creation scientists doing research.
And did you recently speak? It must have been a few years ago now, but on the Creation Conference, the latest one, I believe it was, Mike.
Which Creation Conference?
I think it was it 2016 or I can't quite remember what. I'm not sure if it was on the recessive stage of the flood, or I could be wrong. I've got it mixed up right now. I'd have to look it up. But yeah, I would definitely press my audience to subscribe to the Journal of Creation, where tons of good information is constantly coming out. And I think you said it last time in our presentation, Mike, where we all know we could attack evolution in deep time all day. They got so many problems.
Right.
But you are seeking to answer some of the tough questions, some of
Yes,
the
I am.
problems with the flood itself, and I really respect that, because you're coming up with so many good answers to essentially some tough questions and objections sometimes.
Mm-hmm. Yeah, and the Ice Age after the flood, that both periods.
Right, and that kind of brings us back to the topic that we were here today, to present and discuss the post-flood ice age. The ice age being best explained through, you could say, the ripple effect of the flood itself. So I really appreciate this presentation and the time you've given to us, Mike, because I think our previous presentation was about 2.5 hours as well. So I think we've got almost 6 hours of answers and amazing information from you, Mike. So I cannot thank you enough. I know George as well is extremely excited for these. So thank you again, Mike. Thank you.
You're welcome.
Thank you to the chat and all your questions. And God bless everybody. We'll see you tomorrow for another flood presentation with Sal Giardina. So everybody, God bless Mike, and God bless
George. Michael.
Yeah, you too.
All right, everybody. It looks like we are live, and I'm extremely excited for this. This is our third show this week during the Genesis Flood Week. I want to thank everybody for their amazing support during this past week worth of shows, specifically pertaining to the Genesis Flood. Yesterday, we had Mike Ord on for a show on the Ice Age. We had a great Q&A. I want to thank the audience for so many good questions. On Monday, we had Professor David McQueen, who touched on the end stages of the flood. So guys, this has been exciting. The week has flown by, and I'm really excited to present our guest for tonight, because we've got Sal Giardina back with us. Everybody remembers him from a couple weeks ago. We had Sal on with us for a presentation on erosion. And today we're going to be discussing physical geology of planet Earth versus evolution's deep time. So I'm incredibly excited to introduce our guest tonight. I'm going to bring him in. And we've also got George Bond. George, thanks so much for being here as well, brother. Sal, thanks again for giving us your time for tonight's incredibly important presentation. Sal, thanks for being here.
Glad to be here.
And George, thanks for being here as well.
No worries. This is a much better time for me. I didn't have to wake up at 5 a.m. in the morning, Donny.
Yeah, that was a little bit rough. I think we're going to give you that big promotion, George, because waking up at 5 a.m. yesterday, I didn't even know there was a 5 a.m. So, George, that was impressive.
Hi, Sal. Nice to see you again.
Hey, it's good to see you, George, or hear from you anyway.
So It looks like we've already got super stickers coming in. Once again, I want to thank everybody for the amazing support. Raymond, thanks so much for the super sticker. We have a good chat already, so please tag me with your questions pertaining to the topic. Sal is going to be starting off with a presentation, so just make sure you tag me at Standing for Truth. That way I won't miss your questions. So why don't we hand it over to Sal? You were here a couple weeks ago. We have had some new subscribers and new viewers. So if you wanted to give a brief introduction, and then I think we'll get right into the presentation, Sal.
Sure. I have mechanical engineering degree, a bachelor's. I have a master's degree in geology, and I was a former professional registered geologist in the state of Arizona for a number of years. And I was an Air Force pilot and instructor pilot, as well as a pilot instructor for many airlines, training crews to fly commercial liner aircraft like Boeing airplanes. And so I have a background in both the engineering and applied earth sciences. I'm also a minister of the gospel, ordained minister for 40 years, and we have a ministry called New Creation Ministries, which is a creation ministry organization.
Well, thank you for that introduction. Again, I'm extremely excited to have you with us here today, Sal. And on Standing for Truth, we focus on the truth and validity of biblical creation, and that includes the global flood as well. So I'm really excited for this. Before we get into the presentation, George, unless you had a couple words in terms of introduction, brother.
Well, Sal was a bit didn't mention everything. He also worked in the oil exploration industry as well. So I thought I'd just plug that in for you, Sal.
Well, I was an engineering geologist, not actually oil exploration. I was a geologist that worked with engineering firms to establish the siting for power plants, bridges, dams, things like that, to help assure that the siting is safe from a geology standpoint and a stability standpoint. I also did seismic analysis for foundation studies so that the engineers would have an idea of how to design for seismic earthquake activity on the structures.
Oh, okay. Well, I would have seen not specifically your work, but I was involved in bridge construction myself. So, not that earthquakes are a big issue in Australia, but yeah, you have to take into account some of that force as well.
Sure, you can find get earthquakes anywhere in the world. I mean, no area is totally totally immune to receiving an earthquake.
Yeah.
Okay, well, great introductions from the both of you. Once again, George, thanks for being here, and Sal, thanks again to the chat. Tag me with your questions, and Sal, I think we'll get right into your presentation, and we can share your screen, and I can put it up here for everybody. Here we go.
Okay, open my PowerPoint now.
Yes.
Okay.
Perfect. Okay, here we go. And whenever you're ready, Sal, the floor is yours. Take your time.
All right. Let's take a look, ladies and gentlemen, those of you viewing in to see this program. We're going to look at the is evolution and deep time, does it even matter? Well, of course it matters because the entire foundation of evolution theory and abiogenesis, the idea that life started from non-life by random chemical processes without any design or provision whatsoever, and the idea that biologic life and the entire universe actually has developed over billions of years. That's with a B, billions of years of Earth history. Of course, the students are inundated with this idea that the Earth has been around for billions of years, and the universe included. And if you become to understand and judge for yourself that the real evidence does not support this, because science, as you know, is all about observational evidence, right? You will observe things, test them, retest them, and draw your own conclusions. And this is observational science. However, the idea of evolution happening in the past and the Big Bang and such as that is simply a imaginative idea. It is not based on any kind of observation. It would not pass the scientific method today. So it's up to each person for themselves to decide by looking at what the world provides in the way of observation. Now, today I'm going to give you a data set of information. You'll get plenty of science here, observational science, not my own conjecture or imagination. You will get observational science, which I will show you shortly, so you can make up your own decision, because you ultimately are the judge and the jury. Okay, but the foundation of this presentation is to show you that the real world that we examine and see is actually conforms to Scripture, and you can depend on God's word for your life, and that the world system has not discredited in any way Scripture once you really examine the facts. You know that when a crime is committed, it's a one-time historic event that happened in the past. And if there are no eyewitnesses, which are considered to be direct evidence, you would have to investigate and gather all the information you can. And this comes under the area of sort of historical science, and that you have to weigh the information for yourself. The quality of the empirical evidence is exponentially related to solving the crime. Okay, so that we don't always have direct evidence. Most time, crime scene investigators, all they have is circumstantial evidence. In other words, if a person is considered to have committed a certain crime, we have to look at the various circumstantial evidence that is available. And once you come up with a number of evidences that point to the perpetrator, then the cumulative evidence points to a conclusion which unites all the evidence and therefore leads to a conclusion beyond a reasonable doubt. Let me just give you a very, very quick example, and then we'll get into the geology of how powerful indirect evidence is, circumstantial evidence is in a court. I have a brother-in-law that lives in the Swiss Alps in a small community there. And if I put 7 items on an envelope to send him a letter, just 7 items, his first name, last name, his street address, the number of his building, the canton, which is the village, the county, the country, guess what? over 7 billion people on the earth are eliminated, that letter gets directly to him and no one else, because those 7 or 8 items that I put on the envelope, all of those items in themselves would be considered circumstantial and would not get the letter to him and identify who it was to go to if I only had 2, 3, or 4 perhaps. But once you start to get the 7, 8 items of circumstantial evidence, it eliminates billions of other possibilities, so that there is no other possibility left, and you can draw a reasonable doubt and a conclusion yourself. And that's what circumstantial evidence is, and it is very powerful, and in the court is usually even greater than direct evidence. As the circumstantial evidence continues to surface, you can zero in on the truth by eliminating any alternative possibility of supporting deep time. So let's look today at just one data set of circumstantial evidence, which in itself is sufficient. The truth is usually relatively simple, folks, when many pieces of the puzzle are available. Why? Because that which is untruth simply cannot fit into the remaining unique structure of the emerging picture. Scripture contends that the earth is about 6,000 years old. We might say the earth is on trial, or Scripture is on trial. Is this a truth? Do we have enough evidence to support this? Well, how much evidence do you need? We are immersed in a dark age of science. How would you handle the realization that much of the foundation of modern science regarding origins is not credible? Now, we're not talking about operational science, which has given us cell phones and sent people to the moon. We're talking about origins, ideas about origins, which come under historical science, not operational science. Are you prepared to think out of the box? The persistent false idea of Earth's historical deep time hangs as a fog over of scientific darkness, obstructing forward progress in understanding the physical sciences. It leads many people astray from the biblical record. So today, we're going to look at the worldwide deposition rates and environments. Do they account for an observed physical properties of stratified rock formations, which we see today? On the previous program that I did a few weeks ago, we looked at the worldwide continental erosion, which shows that the erosion rates simply do not coincide with the idea of deep time. So today we're going to look at the depositional rates and environments that you find and that you can observe yourself. This is science. Observe science. Regarding the rate of sedimentation today, extrapolation of current worldwide empirical measured rates over deep time would result in excess of sedimentary cover over the earth. Although modern sedimentation rates are complex, folks, the range of rates is sufficient. These are the rates that have been measured worldwide. We're not talking about 1 or 2 measurements. And in a moment, I'll give you an idea that there are numerous measurements of sedimentation rates throughout the world. And they demonstrate at any rate exceeding 1 millimeter per 1,000 years, okay? Then the present volume of sedimentary rocks represents a very small fraction of those ever deposited. If the rates exceed 1 millimeter per 1,000 years, well, we're going to see that in a moment. Here is a worldwide depositional settings. You may not be able to read all these, but there are many, many areas of the world. This is just a short list, just to give you an idea where the rate of deposits, the rate of deposition of sediments on the Earth's surface has been measured. And I don't know if you could read a close-up of this, but in many of these areas, deltas and environments around the Earth, the rate of deposition is many magnitudes greater than 1 millimeter per 1,000 years, meaning that we should expect to have enormous amounts of sedimentary rocks around the Earth today, but we don't really see that. There's many, many more areas around the world that have been measured, and the rates of deposition are far greater than 1 millimeter per year. Here we got 226,000 millimeters per year, 2,800 millimeters per 1,000 years, etc. Now, the depositional rates that are measured worldwide force evolutionary geologists into a box, whereby they must reduce the total quantity of sediments in order to maintain the paradigm of billions of years. Now, how do they do this? Because they know that there should be much greater thicknesses of thousands of feet greater of sedimentary rocks have been deposited around the Earth. But we don't see that today. So how do they justify this reduction to what we see today? This is accomplished in their imagination by reliance on unconformities. Now, this was shown to be untenable in a previous presentation that I made. It's simply relegated to an illusion based on an imaginative pseudoscience. So let me just show you a little idea of what these unconformities look like. In the Grand Canyon, for instance, this is just one section of the Earth's crust, which many people are familiar with. You see, these are areas between layers that are called unconformities. There have various other technical names to them depending on how they were formed, but basically a uniformitarian geologist, evolutionary geologist, explain to people that there is a millions of years between certain layers have passed. Now, when we're talking millions, we're talking like 5 million, 10 million, sometimes 20 million. In one case, the spacing, the gap between certain areas, like here, span on the geologic column something like over 100 million years. So what are they saying? They're saying that during this period of time that there was no sedimentation going on, or there was simply erosion, that erosion was occurring for millions of years, and it is now destroyed any evidence of the geologic record between these layers. And thus they compress these layers down into a smaller column, because, as I said, we should have many, many more thousands of feet if deep time were in fact true. Okay, now let me explain something to you about the time interval between these layers. This is the proposed gap or time gap. If you walk out on any road surface today, as soon as they lay down the asphalt and it cools down, the moment it's laid down, it is starting to wear out any road. This is the second law of thermodynamics. Everything on this earth is active and eroding. There is no such thing as a period of millions of years where there is no sedimentation or there is no evidence of erosion whatsoever, because everything begins to break down and erode. And in the real world, when you subject a surface to erosion, you're going to find canyons, streams, gullies, cracks, etc. An irregular surface, not a planar surface, indicating that nothing has really happened for millions of years. This is a violation of uniformitarian theory in itself, because we know that the key to the past, the present, is not the key to the past, because we see in the present that everything it begins to deteriorate if left to itself. So these ideas of unconformities are simply imagination.
Hello, not available now. Please
Excuse
leave your
me.
name and phone number.
These ideas of unconformities are simply imaginative. They cannot exist between layers for millions of years and leave flat surfaces with no significant evidence of erosion. Science is all about observation. So currently observed environments of deposition, let's take a look at them. Today, on the surface of the Earth, we find these various environments of deposition. You may be familiar with many of these: deltas, glacial tills, alluvial fans, floodplains, mass wasting, debris flows, coral reefs, evaporates, peat bogs, etc., volcanic areas. These are areas that we observe on the face of the Earth today, accumulating deposits. Let's just take a look at some of them, and you'll see where we're going with this, because you want to see observational evidence, right? Not imagination. Here's the Nile and Mississippi River deltas, pictures of them, some of the largest deltas in the world, where the erosion products of the continent are emptied out into the ocean through a distributary channels, not tributary, but distributary channels that empty out the erosion products out into the ocean. And we can measure these very carefully, how fast they are expanding and how much sediments are going out into the ocean. Here is an area of glacial till. Can we identify these on the surface of the Earth? Of course we can. Glacial till is an unsorted sediment derived from the erosion and entrainment of material by moving ice of a glacier. The landforms form terminal, lateral, and medial and ground moraines. As the glacier moves forward, and sometimes when it retreats, it dumps, you might say, this eroded material out, but it's been subject to the weight of the glacier. It is very, very compact. Glacial till, I've worked in glacial till in upstate New York on my master's thesis, and the glacial till can be as dense as concrete, like about 150 pounds per cubic foot. So if it consists of unsorted, semi-angular rocks from silt, sand, gravel, cobbles, boulders, and up. Very dense, easy to identify, as well as the terminal and the lateral moraines that the material leaves when the glacier retreats. So you could drive right over an area of glacial till and not know it, but it makes a great foundation material because it is so dense. Alluvial fans, those people who live out in the West are familiar with these. This is the outward radiating sloping mass of alluvium deposited by a stream, right, which issues from a narrow canyon onto a valley floor. So coming out of the canyon, the erosion products spill out. It's unsorted, and it usually spills out in a fan-type deposit of unsorted materials, nowhere near as dense as glacial till. In fact, it's not even it's cemented together. It's usually a loose, gravelly, boulder and sand deposit. Now, you can drive over it. You may not be able to see this, but right here is a highway going right across the alluvial fan. And if you're on a cross-country trip in your car, you may not even notice that you're driving across an enormous alluvial fan. In fact, where many of these are side by side, they form what is known as bajadas. Overbank and floodplain deposits. Alluvial sediments that have been deposited on the floodplain of a river or stream by floodwaters that have overtopped the banks. Okay, now every river basically eventually will form a floodplain area and will, during flood stages, will deposit materials, usually finer materials of silt, sand, sometimes gravel, and in an area called the floodplain area. So that's why you don't want to build a house or structure normally in the floodplain area, because eventually it is going to be flooded. Here on the outside of the meander here, as shown here on the outside, we have a floodplain of material, probably calcareous muds and sand and loose material that has been deposited here. We can identify that as there are geologists that study current floodplain materials in the subsurface very carefully, what type of environments they are, so that they could identify them when they see it in a rock outcrop today. How about unconsolidated sand dunes? Now, you'll see in a few minutes where we're getting with all this, because these are areas of environments that are on the surface of the earth today that you can see for yourself. These unconsolidated sand dunes can be enormous. The largest one is the Empty Quarter. It's about 1,200 kilometers long and 650 kilometers wide, and it's in the Saudi Arabia area, and it's the largest sand dune deposit in the world, although there's many sand dunes, as you know. You might have come across some of them yourself all over the world. And the origin of this sand is an enigma in itself to most evolutionary oriented geologists, because the normal thing they will tell you is that this sand is formed, accumulated by winds from the erosion products of the surrounding mountains in the area. But an examination of sand dunes in most all areas, we find that the erosion products coming off the mountains are not carrying a fine monolithic type sand at all. We could identify the erosion products, and it's hard to account for these large areas of sand without considering that they were formed during the worldwide flood. Evaporites are sedimentary rocks formed which precipitate from the evaporation of saline solutions such as salt water. And usually the first to evaporate is calcium, followed by gypsum, and then halite, which is salt. So where you have a large body of water, saline water, highly mineralized, that evaporates over a long period of time, it will usually leave evaporite deposits on the surface to a large extent. And the Bonneville Flats, as known to have been a huge an area of standing water, which is enormous in square number of miles, which has long since evaporated and left these deposits. They could be easily identified in the rock record if we find a rock outcrop with evaporite deposits in them. Peat bogs, another area of wetlands, wet spongy ground of decomposing vegetation consisting of dead plant material. I bet many people in the audience today can recall driving across areas of peat bogs that have been elevated above them with a bridge or road construction material. These peat bogs can run for many, many miles. They're an area of deposition on the earth. Let's just look at briefly at volcanic deposition. Do we have that? Of course. Many areas of the earth are depositing currently volcanic debris. We have lava flows, pyroclastic flows, and lahars. Let's take a look at this illustration. When a volcano explodes, the material goes up into the upper troposphere and into the lower stratosphere. It could be going up to 30, 40, 50, 60,000 feet above the surface. This is the very fine material that goes up there. Now, folks, this is not smoke, okay? These debris, this pyroclastic debris that is actually silicate minerals. Most of the minerals of the earth from the volcano are of a granitic composition or a glassy composition of minerals of SiO2 plus other minerals. SiO2 is glass, silicon dioxide, okay? And these fine microscopic glass particles are blown up as minerals into the air. And if you fly through these, you're not flying through what you would call quote unquote smoke. You're flying through glass particles, which will destroy an airplane in a short order, jamming up the engine and flight controls. So this is a very dangerous type situation for pilots to avoid, especially at night. And eventually this material will fall out as pyroclastic ash deposits, pumice and scoria may result. Other deposits that are a little heavier will rush down the side of the mountain for many miles. They can be hundreds of degrees C in temperature. And you cannot outrun these deposits normally. They can go down a mountainside at over 100 miles per hour, be several hundred degrees Fahrenheit, and anything in its way will just get roasted. And so they're very dangerous, but where they have coarser material, they form lahars, which are deposits of much coarser material, of boulders, cobbles, sand, and gravel that can be deposited over extensive areas. So the point is, you could be driving on a cross-country trip across some of these lava flows, basaltic flows, and pyroclastic deposits without even being aware of it. And they're in many areas of the world. Here's a picture of recent deposition of volcanic rock at Mount St. Helens. These lahars have flowed out for many, many miles from the mountain itself when Mount St. Helens exploded. I believe it was in 1980, and deposited various types of volcanic material from basaltic flows to pyroclastic ash and lahars. Okay, here's the problem now. Here's what we're getting at. Okay. We find many monolithic geologic layers which extend over entire continents around the world. What do I mean by monolithic? They are basically a single type of mineral, such as sand or a very distinct layer of gravel, that can be identified for hundreds and hundreds of miles. Could be a shale layer, which is a fine layers of clay material. Uniformitarian geoscientists assure us that these layers were deposited by marine transgressions over the continents for millions of years. Now, let's see if this makes any sense. Let's just use some logic from observation, okay? What do all known depositional processes have in common that we, quote unquote, observe today? All occurrences on this earth are limited of aerial extent. And none of the depositional processes which we see today occur and are being deposited across entire continents. None of the present depositional processes can account for the uniform thickness and lithology of numerous formations which blanket vast continental areas. Today, no continent is accumulating a vast blanket of sediment representing a singular environmental process. Now, this is not imagination or arm waving or conjecture. This is just what we observe on the surface of the earth. So the present is not the key to what we see in the past. As an example, you all heard of the Coconino sandstone visible in the walls of the Grand Canyon. It's part of a vast continental slab containing a colossal 10,000 cubic miles of cemented sand. This is a monolithic unit, okay? In the walls of the Grand Canyon, it's very distinct and looks like this. It extends for tens of thousands of square miles in a uniform manner. And this is a picture of where it's been mapped across various states. And remember, this is only where it's exposed and we can map it. It's probably extent is much greater where it is not exposed. The St. Peter sandstone is 1.5 million miles square. Its aerial extent. It ranges from 100 to 300 feet thick, and it's proposed to students for decades and decades that it was formed by a slow migration of beach across the continent over a period of about 5 million years. Now this is the known aerial extent of the St. Peter sandstone. You can see it goes well up into Canada, down here into Mexico, a bit of where we are able to map it. It's a very distinct sandstone unit. And the question is there anything like that on the face of the earth being deposited today? Okay. We saw in the last presentation that I gave you that the coastlines of many countries are not transgressing across the country, but are being eroded away at a fairly rapid rate, so that the oceans are actually degrading the coastlines and reducing the land surface, but not migrating water across for millions of years. Okay, now if you had a tortoise that was capable of walking or paddling, you might say, creeping from New York to San Francisco, it would get across the United States in a lot faster than what you're being told this sand has taken to accumulate and creep across the country. In other words, the surface of this sand as it's being deposited, it's so-called, over a period of 5 million years is much slower than a tortoise, okay? And that the surface of the sand should have the environments which we just showed you. These are the common environments of deposition which you find on the surface of the earth today. But we don't find these environments anywhere in these units, in these monolithic units that are spread over continental areas. The Tapete Sandstone is an extensive formation that can be traced over much of the U.S., Canada, Africa, and South America. It's an international unit. It can be identified almost everywhere. I worked with it in upper state New York, near Canada, years ago in that area. It was called the Potsdam Sandstone, but it is the same sandstone unit that can be traced on a not just a continental wide area, but across international boundaries. It's found in Africa and Saudi Arabia. It's of enormous extent, and it's claimed to have been deposited over millions of years. But when we examine these rocks closely, we could see that they have been deposited by very rapid moving waters, very rapid moving waters to make these type of units. In fact, there are very large boulders in places of the Tapete Sandstone that have been ripped up from the underlying rock and carried along in here by very rapid waters. This is not a slow process of water creeping over the country for millions of years. So let's look at this. If indeed the present is the key to the past, as is claimed by evolutionary uniformitarian ideas, then the uniform strata extending over continental, intercontinental areas, how do we account for these uniform layers that extend for tens of thousands, sometimes hundreds of thousands of square miles without any indication of within those units of the environments of deposition which we see today? Where are the multiple environments of deposition observed on the Earth today in each of these layers? Do you get it? If these layers are slowly accumulating over the surface of the Earth for millions of years, slower than a tortoise can move across, then those upper surface layers should be accumulating the alluvial fans in places, river deltas, overbank deposits, storm layers, mass wasting. We can identify these types of environments in local rock areas, and volcanic vents and dikes, lava flows. Where are these within these uniform units? They're nowhere to be found. Something has happened in the past which does not follow what we see on the Earth today. In other words, the conclusion that these units were deposited over millions of years, if you presented this in a court of law, the opposing attorney would object as being non sequitur. Non sequitur in a court of law means the conclusion does not follow the evidence. You're showing us evidence, but your conclusion does not follow. This is the evidence, the observed evidence, the conclusion that they've been around accumulating, each one of these, for millions of years, some of them 20 million years, 50 million years, is not supported by the evidence today. Take a look at this little video by Dr. Ariel Roth.
About 70 miles due east of the
He's a
Grand
sedimentary
Canyon, an unusual
geologist.
rock formation called the Shinarab conglomerate has been uncovered.
The Shinarab is an unusually widespread and unusually thin rock formation that we find here in the western United States. It is only about 90 feet thick, yet it runs over an area of 100,000 square miles.
The Shinarab conglomerate covers the greater part of northern Arizona, Utah, western Colorado, and New Mexico. Most geologists agree that this extensive formation was deposited by water, like a river or a lake. But just how this was done is still not well understood.
When you look at sediments and so on, you can tell to a certain extent what type of environment they were deposited in. Now, it's not always easy to do this, but the Chenarb is so unique, it's fairly easy to say that it was not a lake deposit. Lake deposits very fine silt, clay, and a very even type of pattern. You look at the Chenarb, the pattern is not that even, and the sediments are very much coarser. It's been suggested sometimes that the Chenarb was deposited by river deposits, but it strains your imagination to think that a river would be depositing material over 100,000 square miles in such a thin type of layer. This is not the type of deposits we get from river at all. This wasn't a river or a lake. This was a catastrophe.
One explanation for the Chenarb suggests that a huge flood washed over highland areas, sweeping rock, sand, and plant material into a wide basin. This debris settled out evenly over a large area, leaving the extensive deposit we find today. The most important evidence for the flood idea comes from fossils. Both the Chenarb and the Chinle Formation above it have an abundance of petrified wood mixed in with coarse, rocky sediments, material that was certainly washed in from other areas. A flood of this size would be hard to imagine today, but it appears they weren't as unusual in the past. A number of these widespread deposits can be found in the record.
The Chenarb is not the only deposit like this we find. As we look through this region, just the western United States here, we find extremely widespread deposits, some of them larger than the Chenarb. Just above the Chenarb, we got the Chinle Formation, which is spread around for 175,000 square miles. And then you get to the Dakota Formation, which is not quite that unique. But that thing goes from this region here around the Grand Canyon, clear on up to the Black Hills of South Dakota. And on top of that, we have the Morrison Formation, which is characterized by dinosaurs. It has lots of dinosaurs in it. And that thing spreads over 400,000 square miles. It runs clear from Texas on up to Canada. And in the metric system, we're talking about over 1 million square kilometers for the Morrison Formation.
All of these formations have been explained in different ways, but the most common is local floods or some other kind of water activity, but always on a relatively small scale. However, these kinds of widespread water-formed deposits could have been made another way.
It is extremely difficult to conceive of local activity being so uniform and so widespread over such wide areas, such as where we find these formations. But these kind of unique deposits are just the thing we'd expect in a worldwide flood, such as described in the Bible.
With water covering the continents, sediments could have been easily deposited over wide areas. In addition, very different types of sediments from different places could be deposited together, one on top of the other. Widespread deposits of unusual sediments have been discovered on every continent. They are evidence of water activity on a much larger scale than anything we see today, but just the kind of thing we'd expect from an event like the Genesis flood.
So, folks, when we try to extrapolate from the present environments back to the proposed deep time of the past, we're continuously confronted with significant discrepancies. In other words, if you were to take a trip, you get in your car and you drive from Canada to Mexico, or from California to New York, across the country. As you're driving, you would drive across a multitude of these environmental deposits that we've previously showed you. Okay, that's what you would expect to see. Now, you may not be aware of it in some cases, just what you're driving over, but if you were a geologist, you would be more aware of it, that you're going from one different type of environment to another, and this is not what we see in the rock record. of the past. The present is clearly not the key to the past, because the rock record shows these uniform deposits spread over continental and sometimes intercontinental areas without any evidence of including within those units these environmental deposits that we've shown you as examples. So although evolutionists will argue to the contrary, the scarcity of evidence to support their theories of deep time becomes evident. Here's the reasonable conclusion you can come to regarding the deposition of the geologic column. Today, no continent's surface is undergoing deposition of sediment representing a singular environmental process. Current depositional processes cannot account for the uniform thickness and lithology of numerous formations which blanket vast continental areas. Therefore, the present cannot possibly be the key to the past, as is claimed by evolutionary geologists. The only reasonable explanation for the origin of vast continental formations requires the unique catastrophic conditions of a worldwide inundation of planet Earth. This conclusion relegates evolutionary deep times to simply an illusion. The proposed uniformitarian mechanism of a transgressing sea cannot account for the vast geographical spatial distribution of these essentially monolithic geologic units. The empirical evidence supports and in fact requires a worldwide catastrophic inundation as outlined in Scripture. Reasonable conclusion, deep time is an illusion, folks. Evolution's deep time on trial. Is the defense of historical deep time reasonable? I do not believe so. It is contended that the cumulative evidence is unified and points to an explanatory alternative corresponding to the biblical record. Who is wise out there? Let him give heed to these things and consider the loving kindness of the Lord. Folks, I have published a book which you can get from my website, because every person on this earth by default will choose to believe in either an eternal God or eternal dirt. You only have one lifetime to get it right. And for those of you out there who have know of friends, relatives who may not ever step into a church or a church service, this type of book, if you gave it to them, I'm sure they would read it. And before they get through even 20 or 30 pages, they will begin to understand that the only reasonable conclusion is there has been an eternal God which has designed all this and set it up. You can get this from my website, godordirt.com. This particular book that I published has a lot of illustrations, charts, photos, and even some tables in it. So it's not all text. You can get it as a ebook or a hard copy. You could order it right from the website, godordirt.com. And Donnie, if you'd like to have a time now for questions and answers, I'd be open to that.
Awesome. Well, thank you so much, Sal, for another Awesome presentation, a must-watch presentation. I want to recommend your previous show you did with us, as well as this one. We've got a lot of new people kind of just arriving in the chat over the last 5 or 10 minutes. So definitely, when you have a chance, rewatch Sal's presentation right from the beginning. So much good information, just like before. And I want to thank the audience for so many good questions, Sal. So we are going to have some fun for this questions and answers section, much like we did in the previous show. Before we get into any questions, though, maybe I will hand it over to George. George, if you had any comments before we get into some questions, go ahead, brother.
Yes, thanks, Standing. Yes. Oh, my dog. Hold on a second.
No problem.
That was very interesting, Sal. Just one thing, I might have actually tabled this question before I actually saw the presentation on Mount St. Helens, but can you explain to some of the skeptics in the audience, what did we learn from the Mount St. Helens eruption?
Well, that was a laboratory which gave creation geologists a field day because it helped to answer or it allowed them to see in real time, you might say, the environments, the volcanic environments that were produced in a matter of a few days and sometimes to a few weeks. And by examining those environments very carefully, we could now see in the rock record, understand similar environments that we see in the rock record. There are local areas where you could go out to a rock outcrop and determine that this was a lahars, or that this was a overbank deposit, or in this particular rock outcrop that only extends, let's say, for 20 miles or something like that. This rock outcrop, we know from examining things like Mount St. Helens and these environments, we know that this is an overbank deposit or glacial till, etc. But when you go to these vast units, monolithic units, we might call them, that extend for thousands of square miles, we don't find those environments in those, even though we can identify them in local rock outcrops from examining what we see on the surface of the earth. So Mount St. Helens was like a laboratory for seeing how quickly canyons could be cut, how quickly layers could be laid down. They don't take hundreds of years or thousands of years. Fine layers could be laid down in a matter of a few days. Vertical, there are massive logs that form vertically in the lake and then were buried with ash in a vertical position. And this explained how these occurred when we see them in the geologic record in places, which was always kind of a mystery, why we find sometimes logs in vertical positions.
Yes. Donnie, do you want me to ask another question?
Sure. Well, we've got a ton of questions that we've saved in the private chat, so I'm not sure which one you want to start with. Maybe I'll let you pick, George, and then we will try and get to as many of them as we can. So yeah, go ahead, George. Pick one of those questions.
No problems. Old Earth creationists say there is too much coal to be accounted for by the flood. Is this true?
There is too much, what? I didn't catch that word.
Coal.
Yeah. Oh, there's too much coal to be accounted for
by the flood.
We find these vast coal deposits. I mean, and again, what we see in the rock record is not occurring on the surface of the earth today. There are no environments like peat bogs. Most coal deposits, these layers, which can extend for hundreds and hundreds of miles, you could follow them out, some of them over 100 feet thick, very uniform. There's no deposits today on the surface of the earth that we could say are forming coal like that. The typical answer to that question by evolutionary geologists will tell you they were formed in peat bogs, you know, just vegetation being decayed in wet environments over millions of years. But there's no environment like that that can form these type of coal deposits today. So again, the present, what we see in the present is not a key to what we see in the past. These vast coal deposits had to occur from enormous quantities of vegetation being stripped from the earth and buried rapidly and spread over large areas.
Yeah, it was interesting. I actually dragged out one of my old university books on geology, and praise God, I flipped over to a page which this particular paragraph grabbed me, and I'll get to my point after I read it. It says, of all the elements that could make up most of the Earth, only iron and nickel are heavy enough to account for the density of the core. Iron and nickel are presumably concentrated in the core because they sank to the planet's center during an early molten phase, while lighter materials, including the silicate minerals, were displaced towards the surface. Now, the reason why this paragraph caught my eye was there are super heavy elements that we find in the crust. If the Earth was a molten ball of rock, why didn't these super heavy elements sink to the core like the iron and the nickel?
Well, that's a good question. I mean, again, it doesn't coincide with the idea that the whole Earth was at one point in a molten state, and then cooled off in layers. So all of that is a conjecture.
And the other interesting fact too, Sal, when you mention observational science, just in Australia, I mean, I come from Australia, so just in Australia, you'll find this on a website. Australia alone has 33% of the uranium resources and 20% of the thorium resources. So why aren't all these other elements more evenly distributed if the Earth was a spinning molten ball of rock? There are just so many of these evidences. They're observable evidences that just contradict that narrative.
Yes, much of evolutionary geology and physics and astronomy is self-contradictory by what we observe
correct.
in the Earth today. That is true. That's why it's up to each person to follow some of these things and draw their own conclusions from the observable evidence.
Donnie, up to you.
Sure. Let me pick a question here from. Okay, here's a good question, Sal. The question is, uniformitarians assert that chalk beds require millions of years to accumulate. Can chalk beds be accounted for in the young Earth creation model, essentially, is what the question boils down to.
Yes, creationists have addressed this many times. These chalk beds are formed by microorganisms, mostly diatoms, which have a silica test around them. They're single cell organisms. And we have found that during times of a certain temperature and chemical conditions, we can get a bloom of these type of organisms that are multiply thousands of times faster than what you normally would expect under certain temperature and salinity and chemical composition. These organisms could bloom. Now, during the worldwide flood, we had warm waters, obviously, from the earth coming up through from the lower, from the mantle, perhaps, and the lower crust of the earth, as is described in the Bible. And they were no doubt very mineralized from the evidence we see on the earth today. And we had environments that allowed these blooms of these organisms to multiply thousands of times faster and accumulate these type of chalk cliffs.
Well, that's a great answer there, Sal. And that's a common objection to the global flood model. And as you've pointed out, creationists have dealt with this. They've dealt with this for years. And I think this is a good question that kind of just came in. And it's a question from Godzilla Freak. I appreciate the question. He says, what is the best argument? So in your opinion, what's a good argument, I guess, Sal, from the other side, from the uniformitarian side? And then how would you respond? What would be a good way to debunk that argument? Just maybe something that comes to mind in favor of deep time or something against the global flood.
What is the best argument they have against the global flood? I'd have to really think about that. You know, they have so many objections that don't fit the data that we see. Perhaps it's the timing of it. You know, they feel that these units could not possibly have accumulated in a little bit over the year, according to the biblical record. But they don't recognize that the present is not the key to the past, that the processes which happened during the flood, as described in the Bible, are enormous, and the time frame is compressed because it's a catastrophe that is a singular catastrophe from the evidence we see around the earth, and it obviously did occur in a short period of time. So I think the time element is one of their biggest objections to it, because they can't conceive of anything beyond the millions of years that they propose.
That's a good answer. That's a good answer. And as you guys were talking about earlier, George and Sal, a lot of their objections can almost be defeated by a real-time example that we've witnessed ourselves in the eruption at Mount St. Helens, and how you guys were pointing out that
exactly
that event literally demonstrated how, you know, sedimentary layers hundreds of feet thick could be laid down in hours, 2 days. And even how canyons could be formed rapidly, and how coal seams could be produced quickly. So, you know, we do have and I always point out that that's a small scale event compared to the worldwide flood, right? Which would have been geologic havoc on a far greater level. So that's a really good response right there. And
yes, you're right. I mean, because we do have evidence that it does not take millions of years to form oil, gas, and coal. We can produce coal, oil, and gas in laboratories now. It was a matter of weeks. Now they have it down to a matter of days. All you need is some extra temperature and pressure, and the right, chemistry. We can produce bona fide coal. We can produce petrified wood now. You could order your furniture petrified if you want. There are labs that will petrify your furniture in a week or something like that. So we have real live examples of things that are claimed to require millions of years, but we know that does not require that amount of time. As far as rapid erosion, Mount St. Helens was one of those examples where canyons were cut right through volcanic rock in a matter of days from catastrophic mud flows. Sediments were laid down 30, 40, 50 feet deep, fine sediments in a matter of hours. So it was a tremendous example of what can happen, even though it's a much smaller scale. The time frame that doesn't require the time. I'll give you a little example. Most people may not be aware of. We have in Arizona, in northern Arizona, the Glen Canyon Dam. And it has a very large dam which forms a lake behind it. That dam has not spillways. It has a spillway, but when the water accumulated one time, this was maybe, I don't know, about 30 years ago, I'm guessing what it was. I've seen videos of it. The water flow for the winter or so was so great, it was going to go over the spillways and destroy the dam. And they had to let water out through the side tunnels, which they excavated through the mountains on the side, for the purpose of building the dam, for diverting the river in the first place. While they were building the dam, they have these tunnels they build, divert the river, build a dam, then they close the tunnels. Well, they had to make a decision to open those tunnels, right? And when they did, the one tunnel on the one side, I think it was the east side, the water flowed through the tunnel so rapidly. This was a tunnel that's about, if I remember the numbers, about 40 feet in diameter with 3-foot reinforced concrete walls, like a cylinder going through the rock. And the water took out the concrete and the rebar and the rock around it within a matter of a minute or so. And it would have destroyed and collapsed the whole side of the dam if they didn't close it down immediately. So we have conditions where water velocity gets to a certain velocity, it becomes highly destructive. And what is the term for that? There's a hydrologic term. When water gets to a certain velocity, it starts to implode. The gas bubbles in it, and if it becomes like a jackhammer. And they had videos of it. Thank God they were able to close it off, or the whole dam would have been lost, no doubt. But the force of rapid moving water can never be underestimated.
Amen. Amen. Great response. And I love how you point out that, what we're seeing here are just small scale events as compared to the worldwide flood. And even based on what you're saying as to how, for example, natural oil, gas, and coal have all been produced in a matter of days to weeks. And going back to that question about, what is one of their most, let's say, common objections to the flood. I always hear this objection that the flood would have resulted in too much heat, that it would have boiled the oceans, melted the crust, for example. And I believe there's a solution to that based on what we're talking about with the production of coal and oil quickly, because this process requires a lot of heat. So I think based on the fact, Sal, that there is a strong connection between the rapid formation of coal, oil, and heat and pressure, then the pre-flood world, being 90% green, would have been what I call the perfect battery to absorb or suck up most of that heat generated during the global flood. So that just came to mind because we've been talking about oil and coal and gas. So I just wanted to kind of throw that out there. George, Sal,
obviously, yes, you're correct. There were conditions which were able to, you might use the word, absorb the heat. And we're not aware of all of those, but of course the water covering the earth itself, I mean, water can absorb a tremendous amount of heat. I mean, and so that's one of its greatest properties of water, is that it's able to absorb a huge amount of heat.
That's a great point. If you've got miles or more of water during the flood, then that water could have acted as a shielding agent for NOAA and the Archive. So that's a really good point as well.
And later, that heated water was directly responsible for the formation of the Ice Age.
Right. Exactly. I like to point out that heat that they say is a problem is more of a feature rather than a bug. It would have helped get the plates moving. It would have helped produce oil and coal. It would have helped with the following ice age. So there's all of these conditions that we can explain based on the heat.
The other thing, Stanley and Michael Ward touched on it yesterday, with heat. If you double the heat, the Earth actually radiates energy to the fourth power. So, for example, if you go from 10 to 20 degrees centigrade, you actually radiate 16 times the heat out into space. So there are a lot of mechanisms where you can dissipate that heat rather than assume that it's all trapped in the earth and it's going to boil away and it's going to vaporize. There are so many other ways. I did a quick calculation which showed not only the volume of water in the oceans, but also the amount of water stored in ringwoodite, for example, over the entire earth. That and considering this specific heat of water, I think it's about 4,100 joules per degree centigrade. That can account for about 30 to 37% of that heat. And coupled to that with the what you mentioned about the heat required for coal production, oil production, limestone, the viscosity of the plates to be able to move at faster than normal pace. I mean, there are a lot of ways that heat can be answered with.
Right.
Great point. We don't claim to have all the answers to that.
No, yeah.
But we have enough of the answers, but we can observe what we see on the surface of the earth, and it is what it is and cannot be explained by uniformitarian processes.
Yeah,
right,
yeah.
exactly.
So we've got a skeptic in the chat who questions your sources. He states that the St. Peter sandstone and Tapete sandstone don't extend anywhere near the picture he showed. And then he says, posting maps from young Earth creation sources where all sandstone of a certain age is claimed to be one big deposit instead of many separate deposits laid by different bodies of water. What do you got to say to that? Like, he questions the source, and he says that it was laid over over many separate deposits.
Well, I think this person may be confused because as you go across the continent, the names of that formation of that deposit will change in local areas. In other words, we know like that the Tapete sandstone in the Grand Canyon, which is above the basement rock, right? It's the first sedimentary unit above the basement igneous and metamorphic rocks. We could identify that unit. It has quite a few characteristics. It's not monolithic, but it has identifiable particular characteristics. As you trace it across the country on the surface or in the subsurface, in certain areas it changes its name, but it is the same unit lying above the basement rocks. So it's what geologists call correlation. That's one of their jobs, is to correlate one unit with another unit where it's found in a different location where you can't physically touch it and trace it yourself across the ground. It outcrops in one area, it outcrops in another area, and you identify it, and in the other area it may have a different name. Like on the East Coast and the Northeast, it's called the Potsdam Sandstone, but it's the same basal sedimentary sandstone unit that overlies the basement rock. So it may be found in many different publications, but these units have been correlated by geologists as being the same units.
Yeah. Sal, he also makes a comment about the continental surfaces, he says, aren't being subjected to deposition because deposition happens underwater. And then he goes on to say there is plenty of deposition going on the Gulf of Mexico and the Mediterranean.
Well, if a volcano erupts, let's use Mount St. Helens as an example, okay? And it spews out lahars, pyroclastic flows, pumice, sedimentary rocks all over the area. I would say that's deposition.
Yeah.
Okay. If a glacier leaves glacial till on the surface of the earth in the form of various moraines and such that we could see, I would say that is surface deposition. Now, all those areas are being subject to erosion, there's no doubt, but they form by deposition in the first place. So I don't know what this person's getting at, but it's obvious that many of these areas are forming from accumulation. Now, as they're accumulating, this person is correct. They are at the same time eroding, and eventually the deposits moving out into the ocean basins, like we covered in the previous program.
Yeah, and we know the amount of sedimentation in the oceans can't account for all that erosion.
Well, the alluvial fans are obviously unconsolidated materials of large gradation of materials that are coming out from the erosion valleys of the mountains, right? They're being deposited on the surface of the earth. So that's an area of deposition.
Mm.
Well, those are some great points, great answers. Yeah, I wanted to make sure, George, that you got those questions and points out there from the critics, and you did a great job answering them, Sal.
I mean, does that make sense?
A question.
Yes.
Yep. Absolutely. Absolutely. This question right here, Sal, this is a question from Ord, and it sounds like it has to do with what your opinion is on a possible flood boundary, because his question is, do you have a preferred flood geocolumn? What layers are flood, what before and what after? So I think that's what he's asking, is what's your opinions on a flood boundary?
Well, that's a question that's facing creation geologists for many decades. They've been trying to determine where the flood ended, what is the boundary? And it was considered by quite a few geologists for many decades, to be in the upper Cretaceous sediments. But now there's been a lot more evidence pointed out by different geologists that the flood boundary is probably well up into the later rock of the geologic column.
And George, because I'm looking at these questions here, and unless there's one you want to ask, this is a pretty quick one. Sal, the question is, do granites need millions of years to form? So I guess, can granites be explained in the flood model, the young Earth creation model, or do they need millions of years to cool? To cool is the question.
That was thought that it was needed. Even many geologists, when I went through, graduate school, we were always told that granite requires hundreds of thousands to millions of years to cool slowly, and the slower it cools, the bigger the crystals it forms. We found, but more research over the decades found that that's not necessarily true. The crystal size is not necessarily related to how long the melt is cooling, number one. And number two, we're finding there are cooling mechanisms of fractures in the rock where the fluids move through the rocks, micro fractures, larger fractures, which we see throughout granite rocks in many places. And these have a huge cooling effect on the granite, so that granite can cool many, many times faster than what we previously thought. Now, I am not an expert in that field by any means, but there's quite a few papers on it in the last 10 years or so to indicate that these magma chambers forming granite could have cooled off very rapidly because of the quantity of fluids flowing through them during the worldwide flood.
Exactly. Great point. Great answer. George, did you have a question you wanted to ask Sal out of the list of questions we have in the side, or a question of your own?
I'll ask one from the audience, from Crimson Air.
Okay.
Is there any significant amount of ash layering within the sedimentary strata? If so, how does the flood model account for their deposition during an active one-time flood wave?
Well, when we look at ash falls and layers of basalt flows in the subsurface, the ICR has published some pictures on that, and I've published it on Facebook a few times, that what we see in the rock record are volcanic units that have dispersed in the rock record during the flood, that are hundreds of times greater in volume and aerial extent than what we see today in eruptions of volcanoes on the surface. Follow me? So in the subsurface, we can follow different volcanic units that came from a source area that go completely, like almost completely across the country, and estimate the volumes of materials that was spewed out at one point during the flood. And they are literally, the volume is hundreds of times, that 3 orders of magnitude greater than anything we're experiencing in the way of volcanic eruptions on the surface of the earth today. In other words, if you think the Hawaiian volcanoes are putting out a lot of lava and and ash and stuff, in the subsurface, it has been mapped enormous volcanic events in various areas, that again, the present is not an explanation of what we see has occurred in the past, so to speak, in the geologic record. Something has happened in the past geologic record of the earth that is on a greater magnitude than anything happening on the surface today.
I got a question here. This is a question from a critic. And the question, Sal, is, are you aware that the Earth's surface is constantly being recycled by plate tectonics driven by subduction? And does this help the case for the uniformitarian, Sal?
Well, this is a basic premise of evolutionary geologists, that the surface of the Earth, they teach you this in Geology 101, that the rocks are going through a cycle. It's called the rock cycle, and it's being subducted in areas, heated, melted, forming volcanic rocks. The volcanoes spew out on the surface, they're eroded, and there's a cycle of sedimentation and volcanic rocks forming in a constant cycle over millions of years. Again, it's all assumes under the assumption that these processes have been going on for millions of years. You have to start with that assumption to justify what's called the rock cycle.
There are two separate studies that I know of, Sal. One is I think the North American subduction plate, and the other one's the one off China or India. They've both looked at the actual temperatures of those subduction plates, and they found them to be reasonably cold. So if these things have been occurring for billions of years, they should be at equilibrium pressure, and they're not.
This is true. We have seismic equipment now. I forgot exactly the terminology they call it. It's like a 3D. They could give you a 3D picture to some extent of the subsurface in the mantle of the Earth, going down below the crust, going down hundreds of miles below the surface of the Earth. They could give you, using seismic equipment and very sensitive computers, to give you a 3D image of what these subduction zones look like. And it's exactly like you said, George. They could tell that these zones have been cooled off from the density and the temperature of it. And if they were if they were operating for millions of years, it just doesn't coincide with the idea that these subduction zones have been going down into the mantle for millions of years.
Yeah, exactly.
Actually, if I could jump in there, George, because Sal and George, that's a really good point, and that reminds me of an answer to the assertion that uniformitarians make. They'll say that, flood geologists and the global flood model doesn't make any testable predictions. And it's my understanding that Dr. Baumgartner actually made that prediction before these cold slabs were discovered, because specifically the catastrophic plate tectonics model predicts that if the pre-flood ocean crust was actually dragged down into the mantle during this runaway subduction process, and that actually happened thousands of years ago during the flood, then the cold ocean crust should still be cold today. And just like you guys pointed out, I believe it's modern seismologists, they're the ones that discovered the huge cold slabs of rock down in the core itself. It hasn't actually warmed up to the material around it. So that's a confirmed prediction made by a young Earth creation flood geologist. So I always find that fascinating.
Yeah, as we get more and more data in, it only confirms and supports the biblical record further.
Yeah, the other thing, Sal, I read a couple of papers just about a week or two ago about volcanoes and the CO2 gases they actually emit through into the groundwater, and then the trees actually pick up that CO2. And then what they found was the trees closest to the caldera, to those growing 30 kilometers away had different growth pattern rings. So I'm touching on the dendrochronology part, where they use this as some sort of evidence that they can extend the timeline of the carbon-14 dating through dendrochronology by matching the tree rings.
Yeah, dendrochronology has been addressed by many creation scientists in detail. And basically, from what I know about it is, of course, you have to try to correlate the tree rings in one area with tree rings in another area, and that is difficult to do in itself. But they found that tree rings are not like varves in claim to be, these laminae in lake deposits. They're not necessarily formed on a yearly basis uniformly. That various storms, droughts, severe winter conditions can affect the tree rings, how they form, how quickly they formed, etc. So it's not as straightforward as it would seem to indicate.
Oh yeah, I've got evidence, observational, empirical evidence, where trees of the same species within 10, 12 meters of each other have grown into different diameters. Now, either they've got, one has more rings or another one has thicker rings. Either way, you can't use the tree rings to match the trees.
Yeah, if you want to count, a big tree and go back a few hundred years, or more, on some enormous tree, you're probably in the ballpark. But to try to extend the tree rings from one area to another and correlate them, and then try to come up with a date of tens of thousands of years is a stretch.
Yeah, correct. I remember reading an article. I can't remember when or what article it was, but they actually found disparities between tree rings from one side of a mountain to the opposite side of the mountain, which shows you that, even though they're in close proximity, they grow at different rates and probably different ring thicknesses.
I don't doubt it.
Yeah.
Well, and that brings me to a question here. Sal, I'm not too sure if you're familiar with this specific topic, but the question is, it has to do with coral reefs. And the question is, since some modern coral reefs are very thick, uniformitarians assert that these must have taken millions of years to grow, therefore refuting a global flood. Obviously, this comes down to uniformitarian assumptions again, but what are your thoughts on that? Have you studied that at all?
Well, I haven't studied myself coral reefs. There are, geologists, marine geologists and stuff
Right.
who specialize in that. But the reports are that coral reefs, just like the chalk cliffs and such, they're formed by marine organisms that build the reefs. And under certain conditions, those reefs can accumulate and build certain ideal conditions of water chemistry and temperature. They could build at enormous rates that can account for the thickness of the reefs. But the other side of the coin is that in the rock record, especially limestones, we find it's reported in uniformitarian geology, many places where there are vast deposits of coral reefs in the limestone rock record. But what they don't tell you is that, as far as I know, no intact massive coral reef is ever found in any limestone deposit around the earth. It's all busted up, broken, fragments of coral. You could identify it as being parts of coral reefs, but the coral, everywhere you find it in the limestone records of the earth, for some reason it's all busted up and scattered around. In other words, there are no massive in situ coral reefs found in the limestone rock records of the earth that I know of. So again, it's an indication that the limestones were formed under catastrophic conditions of massive water busting up whatever reefs were in the pre-flood world.
Well, that's actually the perfect answer. That was extremely helpful. And that's a really good question to, I think from what I've seen, one of the more common objections from the critics that they think is pretty strong. So great response. And George, you might want to chime in on this question. Oh, yeah. I'm sorry. Go ahead.
I was going to add to that coral reef part, because this is an article I read, and I'll quote from it. It says, marine biologists have discovered that coral contains growth rings like those of a tree. A study by the Australian Institute of Marine Science, okay, so it's not somebody hypothesizing, has found a connection between coral growth rates and seasonal freshwater runoffs or floods from nearby land. From strongly correlated historical records of river runoff and flooding, the researchers determined that the coral colony in question had taken only 118 years to grow, or 1.8 meters. This gave them a new method for determining the age of all reefs that make up Australia's Great Barrier Reef. Based on this methodology, now listen to this, the outer barrier reefs, those furthest for the Australian coast, and in the deepest water, which are about 55 meters thick, would be less than, wait for it, 3,700 years old, not millions of years old.
Correlates nicely with the young Earth creation model. Well, that kind of brings me to this question from a critic, kind of based on something you guys were talking about earlier, George. And I know you like this topic too, so maybe you want to touch on it. But it's Andy Sist from the live chat. So I'm happy he's been giving us these objections, and they've been answered very thoroughly. But he's pointing to, he says, what are your thoughts on the over 20 different non-radiometric yearly proxies closely cross-correlating, calibrating C14 dating back to 55,000 years? Did you see that objection come through, George?
No, sorry. I was reading some of the notes I had. Whereabouts is it? I'm trying to find it now.
Yeah, he's saying that there is. How do you explain all the independent?
Why did all of you ignore the Intel Cal 20 C14 caliber? Well, I've had this discussion with Andy quite a bit on the comments section, and I actually stated to him, a friend of mine sent me some photographs of trees in his own block of land, as well as the street trees. They're all planted at the same period of time. They had the same watering, they're in the same soil, yet they grew at different diameters. I sent this information to Incal via their Facebook page over 5 years ago, and they still haven't replied to that. So if you think Incal 20 is some sort of be in or be all, why don't they reply to issues like the one I actually cited to them?
And that's some good points. What are your thoughts then, Sal, on this claim from the evolutionists that you've got all these independent ways of dating things that apparently corroborate each other and correlate to millions of years? Millions to billions of years. Is there any truth to that they've got all these independent lines of evidence corroborating that one conclusion?
I'm not familiar with quote unquote, all these independent methods that this person has in mind. All I know is that from studying the radiometric dating, that the only way it works is on paper in a closed system. And we know that in the real world, when you take a sample of rock out of the environment, wherever it is not a closed system, number one. So the major assumption that it's a closed system for thousands and millions of years is a fallacy from what we observe. Every sample you pull from the ground is open to the environment of an open system in which the radioisotopes can migrate in and or out of the system. It is not like putting the sample in a box, a safe, and closing the door for 1 million years. There's no such thing on the Earth. So the basic assumption is of a closed system is wrong. They've tried to get around it in many ways, in different ways, but there's no real way around it. And the initial conditions that the sample started with of the parent and the daughter isotopes is an unknown. It cannot be known. And no matter how much you try to estimate what the initial conditions were in the sample, there's really no way to accurately estimate what type of daughter products or parent products, what the relative quantities of each were in the sample initially. So when I was a graduate student, I learned how to calculate dates using the basic equations. I was pretty good with math as an engineer, and I kind of could excel in that area, you might say. But what the professor didn't tell me is that whenever he gave me a problem to solve, it assumed that the sample, again, was in a closed system, and there's no migration of the parent or the daughter isotopes being formed over time in or out of the system. It's closed. And then you can take the math to it and come up with millions of years of Earth history. But it was many years later that I realized what I was doing in graduate school, working with a closed system, the math, it doesn't relate to the real world.
Well, that's a great response. And before we get on the 2-hour mark, there was a question that came in a while ago from Hate Love Nothing. And I want to make sure I get to it before I forget, because he's asking Sal if you've ever faced any kind of pushback in your specific field.
When I worked as an engineering geologist for a whole number of years, I kind of worked with engineers and stuff, and we really didn't really touch on the evolutionary issues that much. Of course, everything they dated was considered to be, in terms of geology, in millions of years. And I at the time had kind of gone along with that, thinking that what I was taught in graduate school was correct. As I just gave you like an example of the closed system, and the math seems to work, but the basic assumptions is wrong. So I was under the assumption as a geologist, as I worked professionally, that the Earth was millions of years. It wasn't until years later. So I didn't get any pushback, but it wasn't until later that when I realized, I began to read the creation literature with a more open mind and think of the things that I observed in the past. I realized that a lot of the things I was told just do not add up. So I didn't get a whole bunch of pushback in my professional career, because I was basically inclined to think in evolutionary terms as it was
Right.
at the time.
Right. Right.
But I do know geologists, several personally, that are creationists, and they work in the field, and they have to be very careful of what they say and what they do with their employer, because their job could be in a tenuous position if they were to be thought to be known that they were really creationists.
That's right. That's great. And we've had actually a show specifically, George, you might remember a few months ago, I think, with Professor David McQueen on young Earth creation discrimination, I think we called it, where we had some real cases of that. So that's a great answer. I appreciate that, Sal. There's a follow-up question from the same person pertaining to evolutionary biology. And what is your number one, or even just maybe something that comes to mind scientifically as to why you yourself do not hold to evolutionary biology?
Well, the primary reason is because you've heard of the SETI program, the Search for Extraterrestrial Intelligence. The private agencies, and I think the U.S. government also, in conjunction with them, have been searching for extraterrestrial intelligence in outer space using the radio telescopes for decades and decades. I think they kind of given that research up for the most part. I'm not sure with the radio telescopes. But the idea was that if they could find any kind of coded information coming in from outer space, no matter how rudimentary, even if it was just a rudimentary Morse code, they would absolutely consider that as coming from an intelligent source. But then when you look through a microscope instead of a radio telescope, and with the discovery in 1952 by Watson and Crick of the DNA molecule, and then a few years later, the realization, oh my goodness, this is not just a chemistry molecule, this is an encyclopedia of coded information of life, which is what directs life. We now know why an acorn can turn into a oak tree. No one had any idea how that a seed can produce a plant or a tree. I mean, they knew it happened, but they had no idea. But when they discovered that, not the chemistry of the DNA, but what it represented, a fantastic coded information beyond imagination, which is directs all the functions of life and growth itself, that totally busted wide open the idea that that life is not connected to an intelligent designer, because coded information, as we know from science and physics and math, can only originate from a mind, a mental source. Amen. Coded, intelligible algorithms and information can only come from a mind. It cannot come from random processes. Random processes only at best destroy information and do not produce information processes. So when we found DNA, that in itself, for any thinking person, has to come to the conclusion that life is a product of an intelligent source, because that coded information is way, way beyond anything they would have gotten in the way of communication from outer space, and in which case the scientists would have jumped on it as being a discovery of an intelligent source coming from outer space.
Amen. Well said. Well said.
Yeah.
That was perfect. I always find it fascinating too that we've got this DNA code, this information system, multi-dimensional, multifunctional, highly intricate. I mean, one single cell more complicated than, your most robust automobile on the planet, or even more complicated than the space shuttle itself. And yet some of these atheists want to say that this all came about by chance for no reason at all. But if they found this on another planet, as you're pointing out, they'd be jumping all over it. So, there's no evolutionary mechanisms, mutations, natural selection that can build this type of information storage system. So that's a great response. George, if you had any comments to that as well, go ahead. And we're now over 2 hours. I want to respect Sal's time. We've been rapidly firing questions at you, Sal, for over an hour. So I appreciate you giving us this time. But I'm gonna hand it over to you, George, for some comments, and we'll kind of start winding it down.
Yeah, I'd like to thank Sal for coming back to our channel. I'll certainly be watching this because I was distracted by a lot of the comments I was reading, so I'll be listening to his presentation again. And Sal, maybe at a future date, not too far from now, we might have you again on maybe another topic, if you wouldn't mind.
Sure, no problem.
Beautiful. I'd like to thank you again, and God bless you. Donnie, you got any closing words to say?
No, my closing words would be, I want to thank again the audience for some awesome questions all week long. We've had Genesis flood related topics since Monday. So please go back and watch the previous shows with Professor David McQueen and Michael J. Ord. And now this must-watch show with Sal Giardina. It's been a great week, a lot of information. I think it's almost 8 hours worth of amazing information confirming the flood and the post-flood ice age as well. So thank you to the audience for your support. And also thank you, Sal, for giving us your time for this. You're a blessing. God bless you for all the amazing work you have done to defend the truth. And I'd like to hand it to you, Sal, for some final words before we shut it down.
Well, thank God that we have people like yourself dedicated to try to get this information out to people. It doesn't take a rocket scientist or a physicist to understand what we observe around the earth. As it says in Romans 1:20, the entire creation declares the fact God's attributes and that he exists, and people are without an excuse. So there's no reason to be duped by the world's anti-God system of knowledge that they're trying to get through to people in the way of origin science. And so thank you for this putting this program on. And I just ask all the people to think about it with an open mind, looking at what we really observe on the earth and comparing it with what you're being told in a lot of these universities and schools.
Amen. Amen, Sal. Well said. I've also got your information in the description box for people who want to check out your website, your material, and the book that you've published. You are now a fan favorite, Sal. Your presentations have been awesome, and I appreciate you giving us this time to ask you questions. You've been a tremendous help. So thank you again. Thank you, George, and thank you to the audience. Guys, we'll see you this Saturday. We've got a debate on evidence for Christianity, so we'll see you on Saturday. Everybody, God bless. SFT is out. All right, it looks like we are live, guys, on Standing for Truth, and I am extremely excited because this is the first presentation this week on the Genesis flood. It is the Genesis flood week, guys, and we are going to be starting off with Professor David McQueen, who's going to be giving a presentation on the geologic end of the flood. And as we are going to be doing with all the presentations this week, we've got Mike Ord, who's going to be with us on Wednesday, and Sal Giardina on Thursday. Both of those gentlemen have been here before in the past. And Mike Ord is going to be specifically talking about the post-flood ice age. And Sal Giardina will be talking about the evidence from geology that supports the flood. So it's a very exciting week. I'm very excited to have Professor David McQueen back here with us today. So please, everybody, tag me with your questions. We are going to be having a short presentation at first, and then some questions from the audience, and then another presentation and some more questions. So it's going to be a lot of fun. I'm excited. Good to see people in here. Thank you so much for the super chats, the super stickers, guys. I appreciate the support. So that being said, let me bring in our amazing award-winning co-host, George Bond, and Professor David McQueen. Gentlemen, thanks so much for being here. I like it. I like it, Professor McQueen. Gentlemen, thanks for being here. And why don't we throw it over to you for a couple introductions or introductory words. Go ahead, gentlemen.
Okay, I'll start before George tells his first joke. I got dressed with my rock hammer and my hat, my geology field vest, because we're going to go to places like Nebraska and Australia and go all over the world to talk about what happened in the Great Flood. Now, George, and Standing for Truth, I've got a poem that you have to memorize in the next 2 hours. I'll introduce it and then I'll explain it more as the show goes on. 7 troubled kangaroos attacked zebras today in Australia. This is a memory aid for helping us to memorize Dr. Tim Clary's sequence stratigraphy. You know, I've taught you in the past about carry out some dinner, Cambrian, Ordovician, Silurian. Well, I got Mrs. McQueen to help me this morning with the new poem, 7 troubled kangaroos attacked zebras today. The S of 7 stands for the Salk sequence. But so much for new poems. George, what's our joke for today?
To be honest with you, I'm not going to tell a joke today because I've got a froggy throat and I might stuff it up by coughing during it. So I apologize. But I'll have 2 jokes for you next time.
That's very good. I hope
we'll make up for it next time, George.
I hope you're already laughing about the troubled kangaroos attacking the Zuni sequence and the Tejas, but we'll come more to that as time goes on. Let me introduce what George and I are going to be talking about. I'll dispense with my rock hammer for the moment there and comment that we're going to be looking, and I've got my timer running here. For the first 20 minutes, we're going to do an overview of the last 6 months of the flood, what Standing for Truth has called the geologic end of the flood, which is very, very appropriate way to talk about it. We need to start out with some vocabulary so that there's no confusion. Behind me, you'll see the red and the white to honor the Canadian Easter Monday as we think about Jesus's death and resurrection. So there's always an issue that goes back to the Bible. And when I talk in that regard, I'm speaking as a Bible geologist or a biblical geologist. But there's another vocabulary we can use, and that's a vocabulary of flood geology. Standing for Truth is working to find a debate opponent for me in the summer, in July or August, a deep time evolutionary geologist that will debate some of the aspects of what might be called flood geology. This is the idea that's been suggested for really hundreds of years, that the Earth's surface is dominated not by slow, gradual processes, but catastrophic processes. A book has been written called The Nature of the Stratigraphic Record. The author is named AGER. And this gentleman has pointed out for years, and he's not a creationist, that the nature of the stratigraphic record is long periods of boredom, much like a soldier's life, followed by brief periods of terror. And so as we talk about the waters receding during the latter part of the flood, we need to keep this in mind. George and I have talked about the engineering properties of the toy marketed in the U.S. called Play-Doh. Ironically, I've been looking at the rock mechanics of this since my high school days. And it turns out that the way that Play-Doh behaves, and I spent some time this morning robbing my grandchildren of their Play-Doh and kneading it out. It turns out the way that Play-Doh works, the way it feels, the consistency of it, the ability to form folds like this anticline here, or if I turn it over, a syncline. Mm-hmm. That ability mimics the soft nature of the rocks that were laid down in the early part of the flood and then deformed later on. So as we talk about this issue of flood geology, make sure that you're not missing what we're saying here, that if we get a color like this modeled almost igneous or metamorphic looking rock here, and we say that this rock is from creation, traditionally the geologists 200 years ago would divide the Earth's crust into what they would call primary, which is what my little finger is touching here, secondary, that would be rocks formed in the early part of the flood, tertiary, which would be rocks that were formed later on in the flood, and then quaternary, rocks that were formed after the time of the flood. Now, that is a neutral vocabulary that talks about catastrophic deposition of rocks worldwide. And George, in your reading, you've seen this, I hope, stripped of any biblical connotation. Is that correct?
Yes, I have. Actually, I managed to find my university book on geology. It was just called Geology Today, but that was back in the mid-70s, so it's quite old, and I guess they've made considerable number of amendments to that. But yeah, I do remember those sequences that you mentioned.
Yeah. And so let's briefly switch gears now to what the Bible says, and then we're going to switch from flood geology to biblical geology. And our argument here on Standing for Truth for weeks now has been that the Bible is actually a trustworthy historical document. If you go into the court of law, Standing for Truth, and you look at what people say, isn't an eyewitness account always something better than even the best forensics? Do you see what I'm saying, Standing for Truth?
I do. Yes.
Absolutely.
And so let's go back to someone who actually witnessed this and wrote it down. And so let me read the latter part of Genesis 7 and then the first part of Genesis 8 so we can get a Bible geology perspective on this. And the waters flooded the earth for 150 days. Now, this 150 days is the latter part of that first two phases of the flood that we've spoken of. But now let's go to the final geologic phase. But God remembered Noah and all the wild animals and the livestock that were with him in the ark. And he sent a wind over the earth, and the waters receded. Now, keep in mind that God didn't forget Noah. He was actively moving the ark on the surface of the waters all those months. But notice that this begins with a wind that begins to move. And I'll comment in the second hour about some rocks that are a 1 hour drive away from me in the Mississippi River that are wind-blown sediments, pronounced loess, but spelled Loess. But let's keep going. And the waters receded. Now the springs of the deep and the floodgates of the heavens were closed, and the rain had stopped falling from the sky. And so this means that the subterranean reservoirs of water that Dr. Henry Morris talked about from the 1950s on, they were closed up. The continents had already begun to separate in the Mid-Atlantic Ridge area, which would be an example of the fountains of the Great Deep. But keep in mind, as George and I talk about these things, that we're not saying that there was no more volcanic activity. We're not saying there weren't any more ash, huge ash falls on the earth. And as we talk about the origin of coal in this next few minutes, you will see that we're talking about activity that included a lot of things happening in that last 6 months. But let's read on. The water receded steadily from the earth. At the end of the 150 days, the water had gone down, and on the 17th day of the 7th month, the ark came to rest on the mountains of Ararat. And so let's be clear about what facts we have to deal with. A proverb that I've begun to teach is this. The Bible does not tell us everything we want to know, but it does tell us everything we need to know. And so the framework for a year-round flood, year-long flood, is laid in the Bible. And in publications, I often see a question, well, where did all the water go after the flood? And the idea is often an idea that looks something like this. You have mountains before the time of the flood. The model I've worked on for the last 40 years have those mountains to be around 10,000 feet in height. But at any rate, you have mountains before the flood. The flood occurs, and as the waters are receding, you have what is called technically isostatic adjustment. In other words, mountains begin to rise and ocean basins begin to open up. Let's use, for example, the southern Atlantic Ocean between Africa and South America. That opens up, and all that water flows off of the continents and begins to fill these deep ocean basins. Since my good friend is from Australia, we'll talk about what happens between the Indian subcontinent and Australia, Papua New Guinea, all that area. That's opening up, and you have large basins there. So the waters come down, the waters go up. And in our second hour, I'll talk about a very common incorrect argument that people give regarding the Great Flood. They will say, oh, we can see evidence of a global flood because we find fossils on mountaintops. I'll give a critique of that in our second hour. In the next 15 minutes, as I lay the groundwork before George asks his first question, we're going to take one part of the United States, and I'll move my map over here so I can show it to you. This mesa or butte here is in the state of Nebraska. If you're familiar with the geography of the United States, this is Western United States, and this is an area where this is in an area that borders the state of Nebraska and the state of Wyoming. And it's a national monument called Scotts Bluff National Monument in this part of Nebraska. And in the geography that you've been taught in Australia and otherwise, George, would you call that a bluff or a mesa that I'm putting up there? Is that a bluff or a mesa?
Oh, George, I think you're on mute, brother.
Oh yeah, he's on mute there. I'm sorry.
I'm sorry. I don't know what they would call that.
Okay. In the U.S., there's two vocabularies. This would be called a bluff by some or a mesa. But why would I even bring this up? It turns out this group of rocks here that you see behind that covered wagon there is a group of rocks that are supposed to be less than 100 million years old. And on the traditional time scale of the evolutionary community, you will see that these rocks fit in what's called the Quaternary period. These are words like Eocene, Oligocene, and so forth. And you'll see our ancestor there, George. Let me get my hand on old Neanderthal man. That's supposed to be our ancestor. But these rocks that I was showing you, and we'll talk about in Nebraska, are supposed to be 30, 40 million years old. And in the way that we've come to think about the rocks that we see in the Grand Canyon and beyond, these would be called late flood rocks, or rocks that are at a boundary that is an exciting part of current research. Here is volume 2 of Dr. Snelling's big book on geology. And George, I thought I'd read for you a section from page 761 that bears on this. He says this as he concludes this chapter on where is the boundary between the flood and post-flood time in the geologic record. He says, vertical earth movements and isostatic readjustments built mountains and elevated plateaus after the Cretaceous, like what I just showed you in Nebraska, while the sea level rapidly fell as floodwaters drained. Now, here comes a point of disagreement. Now, those of you that are critics of young Earth geology will say, oh, this shows that these guys can't agree. No, that's not what it shows at all. It shows that Dr. Andrew Snelling has one viewpoint. Dr. Steve Austin, who has a PhD in geology from Penn State, has another viewpoint. Dr. Tim Clary, that we're going to talk more about. Remember the poem we got to memorize, George? 7 troubled kangaroos attacked zebras today in Australia, as if there's any zebras in Australia. I don't know. But at any rate, when you think about that in those terms, listen to what he says at the end. See, this argues that we're real scientists doing science the way you should because we disagree on details. Listen to this. Continued volcanic activity declined in power and effect as the rates of global tectonic and geologic processes also declined to provide a new stable world safe enough for Noah, his families, and the animals to disembark from the ark. And so Snelling argues that it was after the Cretaceous tertiary boundary that it was the end of the flood. interesting point. And we're coming up on the first 20 minutes here and ready for George's first question. But I hope you see what we're driving toward here. There's more than one theory among creation geologists about exactly where the end of the flood is. And that should prove to an analytical audience that we're dealing with real science and real competing multiple working hypotheses. Okay, that finishes our introduction, George. What question would you like to put up on the board for us?
Just a statement to begin with. In the example you were showing, David, with your Pleistocene, where the isostatic situation where the land was going up, the ocean's going down. Yeah. Now, if we look at that from the point of view of old Earth geology, there are obviously rivers flowing on the land, and as the land rose, those rivers would gradually erode the land, and you should find massive, and I'm talking massive canyons. So why don't we find these massive canyons if this has been occurring for billions of years?
Exactly. And the point's very well made. These should form canyons as the water runs off. But it's not just one canyon like the Grand Canyon in the United States, or canyons on the Hawaiian Islands, or canyons in Northwest Africa. There are several Grand Canyons around the world, but don't miss George's point here. If we have a billion years of this kind of geologic activity happening, why don't we find a canyon almost everywhere? How in the world can we find flat lying? Since I'm using that for water, I'll pick another color here for another type of sedimentary rock. So here you've got the red, the yellow, and the orange there. We've pointed out that there are knife-edge contacts in Australia and in the Grand Canyon and in Europe. Why would you find this? You wouldn't find it if you've got a billion years of this type of erosion going on and on. Good question, George. What's the next?
Exactly. SFT, I had a sort of interesting discussion with a YouTuber by the name of Matt Smith. I've got some screenshots of some of the questions. I thought they might be interesting ones to tackle during the question and answer period. So if I can share the screen.
Sure.
I've got to remember how to do this now.
The
George
fourth button
going out.
You got it, George.
Okay, there we go.
Oh, he did have it. And then he must have left studio by accident, but he'll be back.
Okay,
in the meantime, Professor McQueen, I do have a question from the audience if you wanted me to.
Please, go ahead and give it. Yes.
Okay, so let me pull it up here.
Okay, good.
I did save it, but I lost it in the chat. So let me go.
No problem.
So here it is.
Okay, good.
A question from Andrew P. Professor McQueen.
Okay, good.
He asks, if Professor McQueen doesn't cover it in his talk, could you ask him about the post-flood boundary, as in where he believes it is, and what are the reasons for believing so?
Okay, good. As I have commented a few minutes ago, I hope you heard it. I think that in many parts of the world, the post-flood boundary is above what would be called Cretaceous. Now, remember the word Cretaceous in the geologic column is given the letter K. Well, that's from the German word chalk. And so around the Earth, there are all kinds of chalk deposits in what's called the Cretaceous. And there's the Austin chalk in Texas and so forth. And let me look on my handy dandy chart here. And this is associated with finding Triceratops and pteranodons and other large dinosaurs in late Cretaceous. And then you go up into what's called the Paleocene. So that's where I would put it. Dr. Andrew Snelling puts it later on in the geologic column. So there is a discussion. George, you're back. What was that question you were going to read?
Sorry, I pressed the wrong tab.
That's okay.
I'll share the screen again.
Yeah.
Yes, please.
You had us worried there, George. We missed you. Remember, you're the award-winning co-host. We need you here, brother.
That's
okay,
right.
Here we go.
Can you see that?
Oh, yes.
All right, I'll go to this one. What's happening now? Oop. Here we go. He says, you don't need a PhD in geology to know that desert dunes and other desert deposits do not form under roaring flood waters. These require not only time but also dry land. The flood of Noah supplies neither. Okay, so he talks about the red sandstone, the old red sandstone, which looks for all the world like a collection of fossilized desert dunes, was formed in Devonian times. So what I did was, this is an old one. I mean, we've sort of debunked this a number of times, but this is how sand dunes form underwater, and we know that it was water because of the angle of repose. I think David would know what an angle of repose is. It's the natural angle of the material forming.
Yeah.
And just to show you an example, here's a recent tsunami off the coast of Japan, which showed that these sand dunes formed over the course of the tsunami and not the long periods of time secular geologists had predicted. This is observable. This is observable science, Matt.
Yeah, very, very good point. I want to respond to that myself.
Yeah.
I too, in the early 70s, when I went through undergraduate school, was taught that if you look at the sandstones in the Grand Canyon, like Coconino sandstone, for example, it is cross-bedded, evidence of a dune, and therefore must have been a moving body of sand going across the western United States. Well, the kicker to that is when I have gone, and I have hiked the canyon 5 times in 4 years, and I've actually looked at the contact between the Coconino and the rocks above it and below it. What it looks like is this. Let's let the yellow here be the Coconino sandstone. And let me move my model around a little bit. And the contact between these things, I'm sorry, let me say it more clearly. The contact between the Coconino and the units above and the units below is knife edge. You would never get a knife edge contact if you buried moving sand dunes. A far better explanation for this is deposition under moving water. How do you like that response there, George?
Yeah, it's very, very good. It's an easy one to refute, but I've got a few other ones from Mr. Matt Smith. If SFT hasn't got any from the audience, I'll share screen again.
Yeah, go ahead. We answered one of the audience questions when you dropped out, George. So if you want, share your screen and we can do.
Okay.
There we go.
This is the first one. He says, scientific analysis has refuted the key tenets of flood geology. Well, I beg to differ there. Flood geology is contradicted by the scientific consensus in geology. So he's appealing to consensus. Stratigraphy, geophysics, physics, paleontology, biology, anthropology, and archaeology. Modern geology, its subdisciplines and other scientific disciplines utilize the scientific method. In contrast, he says, flood geology does not adhere to the scientific method, making it a pseudoscience.
Okay, let me respond to that. As I pick this trowel up, if you've watched movies involving archaeology, you know this is an archaeologist trowel. And as we go looking at the geology involved in archaeology, I've had the privilege of working on an archaeological dig in Israel, in 2 different places, near the biblical town of Ai. What correctly should be pronounced. A is silent in Hebrew, much like the word pterodon. You know, the P is silent, George, in the word pterodon. Yep. And pterodactyl. That's why if one comes to your house and uses the restroom, you can't hear them because the P is silent. You see that. But at any rate, let's go back to the serious part. So any archaeological, I'm sorry, I said the wrong word. Any architectural pyramid or building that was formed or was built in the pre-flood world, because we're talking about a 12-month-long catastrophic worldwide flood, every one of those structures would have been knocked down. And so it's not true to say that the evidence of archaeology supports deep time geology. It's actually quite the contrary. When you go digging through those layers, you're seeing the development of civilizations after the time of Babel. Now, the fellow that's asking you these questions may counter-argue. He may say, oh, no. You guys are off base because we're talking about the Stone Age and the Bronze Age and the Iron Age. Well, there's an argument that is not true. But let me tell you something that we would expect, we would predict, and Ms. McQueen let me borrow her bell. This is what she uses when she needs me standing for truth. She rings the bell, and I come running. And what about a bell like this? Well, there have been isolated reports in coal seams of objects like this. Now, this is obviously, for those of you that are not in America, this is the Liberty Bell, famous in American history. But people have claimed that they found brass or bronze bells in coal seams. And if those coal seams were laid down, and we can use our Plato model here once again, let's imagine that we get another color here, like this color, and we put it on top of the Coconino sandstone and more layers on top of that. If this is coal, that formed by floating mat of vegetation. Now, we're talking about a huge floating mat. We're talking about a floating mat the size of the state of Arkansas or the Australian state of New South Wales or the whole province of Ontario. We're talking about huge amounts of vegetative material knocked down by the flood and floating as these waters are receding. And then you would find it. In areas like that, you would predict that somewhere you might find human footprints or artifacts like bells associated with dinosaur footprints. And there are anecdotal reports. Now, is there a place that I can go show you a bell and coal today? Not an easy place, but I think you see the logic, George. Is that correct?
Yes. His other point was it's not empirical. I'm sorry, but yes, it is empirical. I've witnessed flume experiments where we've actually formed those layers through moving water with those knife edge boundaries that you mentioned, David. So
Yeah.
I don't know where Mr. Smith is getting his information from,
Right.
but he obviously doesn't know a lot about the empirical evidence that is out there.
Okay, we're 40 minutes into our first hour here, so let me answer Mark's question. Where
Yes.
did all that coal come from? Well, recall what I just said. If we have a floating mat of vegetative material that is not a few square kilometers, a few square miles, but hundreds and thousands of kilometers that's floating on the waters of the Great Flood, as the floodwaters recede, that we know happen, that we're talking about today, those mats of coal would then be deposited on the receding continental land surface. And then, let me use a different color, more rocks would be laid down on top of it, and these would form the compression and the temperature that would form the coal measures. Now, whether it's this hour or next, George has done some very good research on carbon-14 in coal. Now, keep in mind, if these coal measures are supposed to be in rocks that would be older than the Triassic period, in other words, older than 200 million years ago, you shouldn't find any carbon-14 in a coal measure at all, should you, George?
Definitely not. Even their own geologists state that after 100,000, you shouldn't find any measurable C14 in anything. And let alone even in a million years, you shouldn't find any. So, I mean,
like
do you want
me to point out, George, it looks like Mark has a follow-up question asking, how did all that oil get so deep?
Okay, let me respond to that, and then maybe in the second hour, George can elaborate more on the research he's done about carbon-14 in coal and volcanic ash and so forth. But let's talk about petroleum deposits for a moment. And let me bring in this poem that we're memorizing, 7 Troubled Kangaroos Attacked Zebras Today. This is what's called sequence stratigraphy. The 7, S-E-V-E-N, stands for the Salk sequence, which is very, very low in the early part of the flood. And we'll skip the T and the K and the A for right now, and we'll go to the Z, which is a unit in sequence stratigraphy that's called Zuni, and then the T is Tejas, which is the Spanish word for Texas. So that's where attacked zebras today comes from. Now, why would I be emphasizing this? I have taught you before the poem that I was taught 40 years ago about remembering Triassic, Jurassic, Cretaceous. Carry out some dinner, Miss Penny Pearl, to Johnny Clock, Triassic, Jurassic, Cretaceous, to Johnny Clock, the Queen. I was taught this years ago. And so I'm trying to mimic a memory aid like that to give you an introduction to Dr. Tim Clary's excellent book that's called Carved in Stone. Now, how in the world does this apply to petroleum geology? Well, let's go to Western South America and look at his diagram here. Let me try to get it in the field of view. You see, there's Western South America. And notice that if I can move the book correctly, you notice he's got stratigraphic sections there from oil wells in that part of the world. And so in South America, you have an awful lot of what's called Zuni and Tejas rocks there on the western side of Australia. And you also find the other units lower. Now, let's be sure to teach this clearly so that you can have something to think about as we go on, or as we take a break, for example. Now, these words, Salk, Zuni, and Tejas, Tejas, I didn't make my J very clear there. That is a division of stratigraphy that's quite commonly used in the oil companies, and it's called SEQUENCE. It's called sequence stratigraphy. And so sequence stratigraphy is routinely used in petroleum geology. Now, how does that answer Mark's question? Well, if the red layer here is some of that organic material knocked down before the flood, inorganic organisms like clams and snails, plesiopods, gastropods, if they all get involved in this layer and they're buried very quickly as the floodwaters recede, then you have a situation where this layer is cut off from oxidation and it's buried deep, 10,000, 20,000, 30,000 feet. This is called, in the lingo of petroleum geologists and Standing for Truth, I hope this summer we can get a deep time petroleum geologist to argue this with me. This is called a source rock, and this source rock may be on the edge of a mountain building event where the mountains are bent up in an anticlinal shape like this. Let me move it where you can see it more clearly. So this would be called an anticline here. And so the crude oil, natural gas, and water that's in this layer deep goes up into this anticline, and it's not the systematic application of evolutionary geology that allows petroleum geologists to find crude oil. This is called a source rock. It migrates to a reservoir, or a trap as it's called, and that's where the petroleum is trapped. And now let me find a pin here. And so the stratigraphic section I showed you is an oil well going down through this anticline in 20,000 feet. Can you see it's going all the way through there?
Yep.
And that is the oil well that allows the crude oil to come to the surface. So that's a quick answer to how the crude oil got that deep.
Well, that was a highly detailed and informative answer as well, Professor McQueen. So I really want to thank you for that. Very good answer. Very good question. George, I'll hand it over to you, brother. Go ahead.
Yeah, and we know we need heat to produce that oil. Excuse me.
Yes.
Yeah, we need heat to produce that oil. But the issue is the location of that oil is a bigger problem for secular geologists, because if that oil has been sitting there for hundreds of millions of years under that kind of pressure, you wouldn't expect to find that oil. That should have leaked out many, many eons ago.
Exactly. And let me follow up on what George said there, because it's a very good point. If you look at the classic anticlinal trap, a lot of things happened in 1859. Darwin published Origin of Species, but an American entrepreneur named Drake discovered the first oil well in Pennsylvania in 1859. And he was looking for structures like this. Well, what is the kicker on a structure like this? Let me go back and ruin a second pin by piercing through my Play-Doh here. If you pierce through this rock, like George was talking about, if you pierce through it with an oil well, get it to the correct side, there will be, let me get some of the Play-Doh off the bottom here so you can see. This is the oil well going through. Many of these reservoirs have what's called overpressured shale. So there's a tremendous pressure there. And if the driller is not competent, he will pierce through and 10,000 feet of pipe will go flowing, not flowing, excuse me, 10,000 feet of pipe will go flying out of the well and kill everybody around. The natural gas and so forth will come up, start a fire that it takes weeks to get out. So what George says is really true. Not only should the crude oil and natural gas have come through, and let's create a fault in this. Let's say we've got a fault in these rocks that's up at the top of the anticline. And George is enough of an engineer to know that if you bend some wet concrete, it's going to crack at the top, and all that crude oil and the pressure there would flow out. So the issue of overpressured shales is a young earth petroleum geology argument, because if the earth were millions of years old, there should be no overpressured shales. All that pressure should have diminished, because, George, is it not true that in a pressured vessel, the pressure is always looking for a relief valve someplace?
Oh, definitely. Yeah.
And so if you think that you can take a flowing group of rocks, and I brought a rock from my collection to show here. Here is a well-rounded igneous rock that had been transported during the early phases of the flood and lifted up and then transported in this tsunami-like thing, and then it ends up being incorporated in a group of rocks like this, in a mesa or a butte. Those are above the covered wagon. There is a series of sandstones and shales in this locality called Scott's Bluff, and there are conglomerates in there, evidence of very rapid movement of rocks, what would be called boulders, actually, this size, moving in the flood waters. So a gravel like this can be explained in a butte or a bluff like this by the receding flood waters. And the way that this ties in to the whole idea of sequence stratigraphy and this vocabulary that's now popularized by Dr. Tim Clary of Salk, troubled kangaroos attacking zebras today, the Zuni and the Tejas, is when you get up to this part of the record, this is the area of the post-flood world. And so the boundary, the attacking is an A that is pronounced two ways. Absaroka or Absarica is the way I was taught to pronounce it. Don't lose the point and don't lose the criticism of traditional geology. What sequence stratigraphy is saying is you can go worldwide and you can find rocks with trilobites in them very low in the rock record as a packet or a sequence. Forget about Cambrian, Ordovician, Silurian. Forget about 600, 500, 400 million. Forget about all that. Just look at it as a group of yellow rocks and we'll call those the Sunni sequence. And then above that, we will build, let me flatten the next layer as it would be flattened by the year-long flood. And you got another layer laid on top of that. And then the colors of this oil well that I did on top of that. The petroleum industry identifies these sequences. One of my former students went to work for an oil company in New Orleans. And during a vacation time that we invited he and his family to our house, he brought me some geophysical sections of seismic sections through a group of rocks off the coast of Western Africa. And he said, I've gone to a class, Professor McQueen. They told me how they would pick the unconformities between all these and the traps. What do you think? So we spread it out on my kitchen table, and I took a sheet of paper and began to draw the sequences that I would view as important. And my former student was amazed. He said, you know, that's exactly what we were taught to look for in this class we took. So my final point before we go to our 1 hour break is this. When you look at what is actually in the rock units worldwide, the evolutionary geologists will say, oh, there's a trilobite here, so that shows that it's Cambrian, 600 million years old. Oh, look up here, there's a certain type of dinosaur bone. That proves that it's Cretaceous. Oh, look here, and let's look at a type of plesiopod called MYA. I don't recall the correct pronunciation, Maya maybe. And, oh, that would mean that it is Pleistocene. Well, it turns out that for all the good that this does in petroleum geology, they might as well be paper clips, nuts, and bolts. Exactly. Are you saying a paper clip evolved into a nut and a bolt? No, the evolutionary sequence is meaningless when it comes to pragmatic petroleum geology. George?
I agree, David. We actually did over 2 hour stream on oil exploration with SFT and Steph Harima. I think we covered that subject quite well, but that boulder, the igneous rock boulder that you showed, I mean, that's small in comparison to the ones we actually find out in the open. I mean, we find ones that are tons and tons in that shape.
Yes.
That's. Are you going to take a break now, David, or can I ask you one question?
I'm okay. We're at 57 minutes by my clock, so go ahead and ask a question, my friend.
Okay, I'm surprised that this keeps coming over and over again. It's the question about the origin of granite. Now,
yes.
We've discussed this before, and we looked at the individual ingredients that make the granite, the feldspar, the mica, the quartz, and so on, and they each have a different density. Now, according to secular geology, the Earth was molten at one stage. If it was molten, we would expect those specific elements of the granite to be in order of increasing density, but that's not what we find. So that's another piece of evidence that suggests that the Earth was never a molten ball of rock.
Exactly. Now, this is a granite, and I'm going to put it dangerously close to the camera here, and you'll notice 3 colors. You'll notice white, black, and then a clear color. The clear is quartz, the white is feldspar, and the black is mica, hornblende, and plagioclase. And your point is very well taken. If this, I'm going to be careful not to drop it on my computer. If this were a molten ball, you would predict as an engineer, George, that all the heavy black minerals would be at the bottom, and then the lighter quartz and feldspar above, correct?
Yeah, well, that was exactly my point. So, just based on that one single empirical evidence, Matt Smith, that's empirical evidence, you would have to disregard the theory of the Earth being a molten ball of rock for 500 million years.
Now, recall the argument that I gave in last week's debate on accelerated radioactive decay. Bob Gentry had the viewpoint that if you find a rock that looks like this and you look at the halos in the mica, some of those halos are polonium halos, one of which has a half-life of less than 3 minutes. And so the creationist view that God spoke into existence granites that would have formed the bedrock for the Garden of Eden, for example, that begins to make sense, because it looks to me like something like this cooled as quickly as, George, you're probably old enough to remember the old cameras that had the flash bulb in them.
Oh, yes, I
so
do.
The flash goes off and it forms this. Now, as we pointed out last week, Dr. Andrew Snelling, Dr. John Baumgartner, and others disagree with aspects of Gentry's idea. But nonetheless, even in that area of disagreement, Dr. Snelling believes that there are several places on Earth that he could take me and we could walk from rocks of the flood, walk for several hours eating our oranges, and then end up in pegmatitic contact metamorphic rocks that would show that that this particular granite formed during the flood. Well, we'll see that another day. The audience needs to recognize that, let's see, how can we most clearly say this? If we were talking only Bible geology and people were coming to us and saying, oh, McQueen, where do you find granite in the Bible? Where do you find sandstone in the Bible? Well, there are some places, but they're not used in that vocabulary. So remember what we talked about at the beginning. The Bible contains answers to everything we need to know. It doesn't contain an answer for everything we want to know. Okay, that's where the science comes in. So if we make the transition from Bible geology to flood geology, we're making a group of assumptions that allows us to say that we can do experiments on powders of quartz and feldspar and mica, and we can look at it. I noticed a question go across the screen about saying, well, Egyptian mummies aren't fossils. May I take up that question after a break?
Of course, yes. And that came in through a super chat. So thank you for the support and donation. Alec, thank you as well. Raymond for the $5 super chat. This isn't a question, Professor McQueen, but the super chat says, if cookie dough melted and solid again, never will become cookie dough or chocolate chip cookie.
Well, it's a clever way to do it. And the consistency of the chocolate chip cookies that Ms. McQueen makes for the grandchildren, it's true. It's very pliable and so forth. But when we get back, George needs to remind me that if we're talking about the bending of rocks into anticlines and synclines, if we would take something as rigid as my cell phone and put pressure on it over year after year after year, what would it do, George? Would it break in two or would it fold?
Oh, it would definitely break. It would definitely break. But just to make one point about the cookies,
yeah,
empirically, I believe. Correct me if I'm wrong here, David. I believe granite has a melting temperature of around 3,000 degrees Celsius.
Okay, let's go with that. I don't have that memorized. Go ahead.
Yeah. Well, okay. What they've actually done empirically in the lab is they've heated granite, and when they've allowed it to cool, it actually forms a different substance called rhyolite, which goes to that question about, or not the question, the statement about the cookie dough. Granite, when molten and allowed to cool, does not become granite.
That's exactly right. And this issue of granite, granodiorite, rhyolite, Standing for Truth has encouraged me in the summer to do a session with you, George, called Geology 101 or Flood Geology 101. And we'll define those terms better. That requires about 10 minutes of itself. So with your permission, Standing for Truth, I'll ask you to drop my video feed and I'll be back in 5 minutes.
Yes. It is break time. Well-deserved, Professor McQueen. Some great questions in this first hour. Great presentation, Professor McQueen, and great answers. So we'll go into a 5-minute break. I want to point out as well, now that we're kind of in a intermission, we talked a lot about coal, natural oil, the production of coal and oil, right? And we talked a lot about heat. And there was a question that came in earlier at the beginning about the so-called heat problem. Well, Raw Matt and myself did a full video on it last week. We've talked about it in great detail. I don't think anybody has talked about, the so-called heat problem more than us. Isn't that right, George? So I wanted to make a point that people need to stop looking at it like it's a bug. Okay. And there was a so-called rebuttal to the points Raw Matt and myself were making. And there was no response or no real rebuttal given to my point about the pre-flood world being the perfect battery to suck up and absorb most of that heat. Okay. So people need to start thinking more in terms of heat being an aspect or being a feature of the flood and not actually a bug, because the global flood event, as we've discussed, provides the perfect conditions for that massive amount of heat that's produced during the flood through accelerated nuclear decay, catastrophic plate tectonics, right? Subduction, friction, for example, to be absorbed. And that's where we go back to the coal and oil that we're talking about here, George, where in order to produce coal and oil quickly, there is a process that requires heat. So given the pre-flood world and how it was 90% green and very tropical, okay, that would then be the perfect battery to suck up that heat, because all of that heat can now be used, heat and pressure, to produce all the coal, all the oil that we see today. And there's massive amounts of coal and oil, and therefore that heat and pressure could have been responsible in terms of a mechanism to produce coal and oil in the first place. So, I just want people to stop thinking about it as if it's a bug or a problem. It's a feature. Necessary. Go ahead, George. Go ahead.
Just for the benefit of the audience, there is research currently on that particular issue, the heat issue. But SFT, you've seen some of my preliminary work on this stuff that Jordan had done, and when you consider the ringwoodite and the volume of water that's actually stored in the ringwoodite, when you take that into consideration in combination with the volumes of water in the ocean, I believe from memory, my figures showed that the specific heat of the water alone can absorb 37% of that heat that Jordan mentioned. And in combination to what you said, obviously you need heat to make the coal and the oil and who knows what else. There's a
And
limestone.
I'll interject this, George. Even the heat just to get the plates moving in the first place.
Exactly.
Right?
Yeah, exactly.
So yeah. Go ahead.
And just to touch up on it, I mean, Jordan's whole argument can be defeated with Walt Brown's HPT model. Okay, in that HPT model, Walt Brown suggests that the origin of some or all of the radioactive materials would have formed during the breakup of the deep.
Right.
And we know from Z-pinch experiments that those radioactive elements are formed at the same parent-daughter ratio as you find them naturally today. But also they find that the process is adiabatic. Now, adiabatic is a process where heat isn't produced or expelled. It's sort of like a neutral process. I'll correct myself here. In a previous stream, I actually called it adiabatic, but gave a definition of endothermic. So I apologize for that. But adiabatic means there's no heat produced, no heat expelled. So it's a neutral process. So Jordan's numbers can be defeated purely by citing Walt Brown's HPT model. That's all I have to say to that.
Right.
But as you mentioned, we do need heat to make the interconnecting layers viscous enough so that the tectonic plates can move quickly.
Right.
So it's a plus for us.
It's a plus. It's a good thing.
Yeah, it's a good thing.
It's like God knew through his foreknowledge, right? That this the heat would be perfect for the mechanisms required for the rapid movement of the plates, the rapid formation of coal and oil. Okay. And Sister Joe says, SFT, did you get my question above? Let me go real quick. Chat's moving quick. Oh, here we go. Question SFT. How do EVOs account for the evidence for accelerated nuclear decay? So that's a good question. So the evidence that I typically point to, and you can chime in on this too, George, has to do with radio halos, fission tracks, helium and zircon crystals, for example. I haven't really seen much in pertaining to the radio halos and fission tracks coming from the evolutionist side because
they have no answer.
Right. They have no answer. There's just too many scars in a short amount of time within the rocks themselves, right, that cannot be explained through uniformitarian processes that show there had to have been one or two periods in Earth's history where nuclear decay was accelerated, greatly accelerated. And I want to point this out. I watched the so-called rebuttal to our video last week on the heat problem, and it's not impressive. These critics are not impressive because still they keep ignoring, George, as you know, they keep ignoring the fact that we have the scars themselves. We have the radio halos, the fission tracks, and we always point out that these lines of evidence suggesting accelerated nuclear decay would be obliterated. We wouldn't have them, okay, because radio halos and fission tracks, for example, are obliterated at relatively low temperatures. So if there was a heat problem where there was no mechanism to remove or absorb the heat or some type of supercooling mechanism, well, guess what? There wouldn't be those observations in the rocks themselves, and they ignore this. They ignore this. In my mind, what they do is they it's a quote mine from Dr. Andrew Snelling, because he points this out actually. Yeah, he goes over the numbers. He admits there's going to be a lot of heat produced during the flood, but then he also points out that we shouldn't find the radio halos and fission tracks in the rocks today if the heat was actually an unsolvable problem, and they just ignore that. Yeah, go ahead, George. What's your answer to that? What are your thoughts?
You can go one step further and say if there was a heat problem, we shouldn't have granite. It should all be rhyolite. We shouldn't have granite. So you can defeat that specific argument just by those empirically found evidences.
Gentlemen, I've been listening to your discussion and fascinated by it. Here's my copy of Bob Gentry's book, and it's called Creation's Tiny Mystery. Now, where'd that come from? That came from a very well-known radiochronologist in America named Brent Dalrymple, who's a longtime critic of what Gentry did. And he was a witness at the Arkansas and Louisiana, I think, creation evolution trial. And he dismissed the radioactive halo argument. Oh, that's just creation's tiny mystery. Well, the more we pursue this and the more we think about, okay, we all recognize that there are aspects of a heat problem in creation week and in the time of the flood. But that heat problem isn't sufficient to dismiss the whole idea of rapid radioactive decay, accelerated radioactive decay, leading to catastrophic plate tectonics. So the argument that you guys gave is an excellent argument. May I go back now to one of the questions from the previous hour, talking about, well, McQueen, how in the world would you explain Egyptian pyramids and so forth? Can I take that one up now, George?
Yeah.
Okay. I had a chance several years ago to visit the Chichen Itza archaeological site in Mexico. This is to the west of the Chicxulub meteorite impact area that we've talked about. And this remarkable pyramid must have been after the time of the flood. And so when we talk about the latter part of the flood, the post-flood time, that's a critical bit of information, because no structure this size could have withstood the catastrophic worldwide flood. That applies to Egyptian pyramids, that applies to buildings in the Andes, like Machu Picchu in Peru. And so when you see buildings like this is a post-flood construction. And so people will try to argue with me, and have argued over the years, oh, McQueen, the ancients were not that smart. The ancients were cave dwellers, dragon clubs, took a long time to invent the wheel, all that kind of stuff. Well, ancient man did remarkable things. And so one of the negative aspects of evolutionary geology and how it spills over to evolutionary archaeology and anthropology is it's diminished the genius of ancient man. And there are books that you can find of a title like that, The Genius of Ancient Man, that argues about this. Let's not forget that when we're talking about this time after the flood, the boundary is a critical thing to understand. And let me draw this out on a sheet of paper so that you can better understand that what was happening in eastern Turkey, what Noah saw with his own eyes in the last month of the flood that he saw. Here is Mount Ararat in eastern Turkey at 17,000 feet. And let's come over to the state of Texas in the United States across the Atlantic Ocean. And let's talk about the latter part of the flood. There is Noah's Ark resting on this, what is now a 17,000 foot mountain. And Noah very carefully observed by sending out birds when an olive leaf was brought back and how much time it took for the waters to recede. And so he saw by using these birds that it would take several weeks, several months for things to dry up. Well, that's what he saw in eastern Turkey. When you come over to Texas in the United States, what might have been happening there? Could there have been huge floating mats of vegetation that come to form the brown coal deposits of East Texas going on there at the same time? What is the Bible mandate? What do we know? Well, what we know is after 1 year, recall that everyone had a birthday on the ark. After 1 year, when Noah and his wife and his sons and their wives, when the 8 people got off the ark, they must have been the only people still alive. 100 million people perhaps died in the events of the flood, and an additional millions of animals died in the time of the flood. And so when we come to this post-flood world, we have to realize that there are some constraints that are put on us by the Bible. And so certainly when we look at what is happening in Genesis 8 and 9 and 10, building up to the time of the Tower of Babel in Genesis chapter 11, there's a lot going on, and the focus is in that part of the world. That doesn't mean that mountain building, uplift, and down warp and so forth wasn't happening in the Rocky Mountains and in the Atlas Mountains of Morocco. And so you've got to have a worldwide perspective on this. Do you see where I'm driving with this, George?
Yeah. I'd like to add something. It sort of fits the evolutionary timescale to refer to the ancients as dumb people. Whereas when we show examples of these pyramids, that takes a lot of engineering knowledge to build that. And even today, David, I, as an engineer, cannot figure out how they actually lifted those blocks, weighing so many tons at that height. No way. Actually, I haven't heard a plausible answer to that from anyone.
Yeah. Well, I would challenge Standing for Truth, and also you, George, to vacation in the Caribbean and actually go on a tour of Chichen Itza. It's fascinating. The tour guide will stand at the bottom of the pyramid, and he'll have the 20 people clap. And when it echoes, this is acoustical engineering. When it echoes off of the pyramid, it comes back, oi, oi, oi. So you've got, and then it comes back, oi, oi, oi. The Mayan culture drew pictures of what to me looked like pteranodons and pterodactyls that they saw that made that kind of noise. And if you know anything about Mayan archaeology, you know that they have gods that are flying serpents and so forth. And so a lot of this fits in a way that the evolutionary community, and your point's very well taken, the mechanical engineering, the structural, the architecture of these pyramids indicate a very sophisticated knowledge that was carried on board the ark, disseminated through Shem, Ham, and Japheth.
It goes further than just engineering knowledge, David. If you've ever been to Greece, go and visit some of the ancient amphitheaters. And if you want to test it out, stand at the stage, have someone climb the very top of the tiers, and ask the person down at the stage to whisper. I guarantee you, I've done it myself. I've heard it. I was at the very top tier of the amphitheater. Our tour guide whispered at the stage, and we could hear her at the very top of the pier. Now, that kind of knowledge, it doesn't it's not just engineering and architecture. There's more than just that in designing a structure like that.
Yeah. Well, next year, the three of us will have to meet in Athens, and you'll have to take us and show us some of this stuff. Very, very good stuff. What is our next question, Standing for Truth, that's come through the super chat?
I've got quite a few of them.
Yeah, I've saved a ton of questions. We've had a lot of good questions from the audience, so I'm not too sure if you wanted me to go to a few more questions, Professor McQueen, or if you had a couple.
Yeah, why don't we? We're at the 20-minute after the hour mark, so we have more time. Let's go ahead and go to a question from the audience, and then George has got some questions. I still want him to discuss more about carbon-14 and volcanic issues, but go ahead, Standing for Truth.
Yeah.
Okay. Well, I've got a question here. I'm just going to go right back to the beginning then, Professor McQueen. Let me see. Question here from Chris Peacock. His question is, what does David McQueen think about the Younger Dryas impact that hit the northern ice cap, causing a lot of the floods we hear about?
Okay. As this geology emphasis week goes on, Michael Ord is going to talk about the Ice Age, but I will make this comment. In the centuries after the flood, sheets of ice, illustrated by my white paper here, flowed over the rocks of the Great Flood, and they would pick up enormous boulders from that and carry them down in the ice. And so if you go to areas of Canada and Northern Europe, you will find these boulders that are called erratics there. Now, the question has to do, if you go north of Ohio, if you go north of southern Canada and go all the way up to the North Polar region and the South Polar region, there were meteorite impacts there, and some creation geologists and certainly some deep time geologists realize that if you have a meteorite impact in that area of Canada, some people believe in the Hudson Bay area there's a meteorite impact structure there. At any rate, that would break up the rocks. Would break up the ice, and there'd be a tremendous amount of heat involved in that impact, and it would cause water to flow. I would put that to be in the post-flood time. Okay.
Well, great response, Professor McQueen. And I'll go right to the next one because there's a lot here, which is awesome. We have a great interactive chat with a lot of great points, comments, and questions coming through. So everybody's loving this, Professor McQueen. You are a fan favorite. So thanks again for all you do for us.
Well, that's
David.
kind of you. Thank you, sir.
My pleasure. So question from Alec Cox. The boundary for the lake of water that filled the Kaibab Plateau, how far north does it extend? Into Montana or more south? Question mark.
Okay. Over the last 2 years, I've worked with Dr. Steve Austin and Ed Hollerwood on a model for the erosion of the Grand Canyon that involves the spillover from a impounded lake that was called Lake Hopi. Now, to show you, again, I want to constantly emphasize the fact that even though there may be 100 university-trained flood geologists worldwide, that doesn't mean that all 100 of us agree on every point. Let me give you an example. My colleague at ICR that wrote this book, Dr. Tim Clary, disagrees with me and Austin and Ed, and he thinks that there was another explanation that doesn't involve spillover for the erosion of the Grand Canyon. Without looking back I can't remember how far north it goes, but I can tell the Standing for Truth audience how to find it. If you will go to the internet and do a search on Steve Austin, and then Ed is the secondary author. I'm the third author. Andrew Snelling edits a online journal that has our extensive paper on it. It prints out to 50 or 60 pages, depending on what font you use. And it's got copious references that Dr. Austin's put together. So do some research on that, and it'll show you how far north it goes.
I've seen your paper on Answers in Genesis recently.
Good.
And like you said, it's very lengthy. I think it comes out to about 50 pages, and it's extremely informative. So I'll put that in the description box of this video when we're done for people to look at.
George, you want to make a brief comment about what we have talked about your research regarding carbon-14, volcanoes, and trees?
Yeah, I'd like to share the screen, please, SFT. So just bear with me for a sec.
Of course.
I'm getting to be a real whiz kid on this. Okay.
You've mastered. Actually, George, before you go, I just wanted to thank Raymond for the $5 super chat. He says, "Where is our brother Ord? Ord's a critic. We want his geology objections." So, yes, thank you for the support. Thank you for the super chat. And I want to point out, as Professor McQueen was saying earlier, so we've got a ton of great debates coming up for April, but we're working on some debates for May and the summer. Specifically, hopefully, some debates on some geology-related topics. So put the word out there. We're looking for some evolutionists or some critics, some strong evolutionists to defend uniformitarianism and hopefully debate a topic pertaining to the Genesis flood with Professor McQueen. So reach out to me. As you know, we are always hosting debates and discussions. So
yeah, I would enjoy that. I hope we can do that in July.
Okay. Can you see my screen?
Yes, sir.
Yes.
Okay, for those in the audience, please take note of the title of that particular article, because whenever I try and put a link in YouTube, for some reason it gets removed. I don't know whether that's their algorithm or whether they won't allow links anymore, but just take note of that. And I'm going to read. You can actually read the entire article yourself, but I'm going to read some excerpts of it. Right. Just take note of what I've said. Volcanoes can tell big lies with big consequences. It's not just volcanoes that do that, by the way. A number of other people do that too. Okay, so what you'll find there, it says radiocarbon dating of organic material is based on the concentrations of radioactive carbon-14 in a sample remaining after the organism's death, which is something that we've known. Over the past 2 decades, the method has been refined greatly by combining it with dendrochronology. I'll talk about dendrochronology a little bit later, which is the study of the environmental effects on the width of tree rings through time. Radiocarbon dating of tree rings records has allowed scientists to construct a reliable record of the concentration of carbon-14 in the atmosphere through time. In principle, they say, I've lost myself now. In principle, this composite record allows eruptions to be dated by matching the wiggly trace of carbon-14 in a tree killed by an eruption to the wiggly trace of atmospheric carbon-14 from the reference curve. You can check what wiggle match means from Wikipedia. Scientists presently use wiggle match dating as a method of choice for eruption dating, but the technique is not valid if carbon dioxide gas from a volcano is affecting a tree's version of the wiggle. Just take note of that. It's not valid if carbon dioxide gas from the volcano is affecting a tree's version of the wiggle. Okay, this enlarged influence of volcano can be explained by an influence of groundwater beneath the lake and its surroundings. The topo wiggle match tree grew in a dense forest in swampy land where volcanic carbon dioxide was seeping out of the ground and was incorporated in the trees. The ratio of carbon-13 to carbon-12, the two, which are the two stable isotopes of carbon, in the modern water of Lake Tapu and Wakatu River tells us that volcanic carbon dioxide is getting into the groundwater from an underlying magma body. And this is the diagram they show there. You can see those red arrows. That's your carbon dioxide percolating through the groundwater system. That's absorbed into the trees, giving you a false indication of the ratio of carbon-14 to carbon-12. Okay, so the last bit there says the dilution of atmospheric carbon-14 by volcanic carbon made the radiocarbon dates for tree material from the topo eruption appear somewhere between 40 and 300 years too old. Now, if I'll just stop sharing and I'll explain a few things. Now, what I found with this whole business with dendrochronology, I've got a friend of mine, a Facebook friend of mine, who sent me some information. This is empirical science now, guys. Listen, he apparently planted 3 silver birch trees, so they're all the same species. He planted them at the same time within his own block of land, within 10 to 12 meters of each other. So they've all had the same watering. They're in the same substructure, soil. And listen to this. The 3 of them grew in different rates. One was, when he measured it at 1 meter high from the ground, one tree was 3.5 centimeters thick in diameter. The other one was just over 7 centimeters, and the third one was 15 centimeters. So there's a variation in tree diameter of the same species of tree that varied from 3.5 centimeters to 15 centimeters, all in the same period. To go further,
let me let George catch his breath, and I want you to do an experiment. Go get a cup of water like I have here, and open up a carbonated drink like Coca-Cola, or drop an Alka-Seltzer in it, and you will see the bubbles form. This is an analogy to the diagram that George showed us, where the CO2 moves out of the aquifer and up through and ends up actually screwing up, damaging the statistics of dendrochronology. Right, George?
Yeah, yes. Before people start to pinpoint on silverbird, say, oh, that's just one species. Well, this friend of mine actually went into the street where his house is located, and the street trees are actually a different species. They're called pin oaks. And even in those pin oaks, he measured the diameter of the trees at 1 meter from the ground, and he found varying diameters of the pin oaks as well. This is why I don't place any credence on dendrochronology, but also because the carbon-14 to carbon-12 ratios that they look at can also vary as well. So when they show you these graphs, these nice-fitting graphs, they just cherry-pick that data to make it look really impressive. So okay. I don't, yeah.
Yeah, let me,
go ahead.
We're at 1:40 now, and I want to address one other thing here that we had talked about earlier. A lot of people that try to simplify evidence for flood geology will say, like, oh, we see evidence of the global flood when we find sea fossils on mountaintops. So here is my pre-flood largest mountain 10,000 feet tall in the pre-flood. And then there's trees to show I'm drawing a cross section. And then I'm going to pull back and show Mount Everest. And everyone knows it's a lot taller than 10,000 feet, right? Well, it's true that since Hillary climbed it all those years ago, people have found rocks as you go up Everest that have marine fossils in them. But people think about it incorrectly. And let me show you the correct way to think about it. The rocks of the Great Flood were laid down horizontally as the floodwaters receded. And then in the mountain building, as India pressed up against China, these flat-lying rocks, in the case of Everest, were tilted up like this. So you can imagine a mountain climber going up and then going down the other side of Everest. They're not finding they're not finding fossils that have been lifted up and then stuck on the outside of Everest. They are units within Everest that are eroding away. So that's what I was taught to call a pet peeve. It's a burr that gets under my saddle. You understand what I'm saying, standing for truth?
Yes, I do.
And so just be careful about that.
Standing, can I finish my point on the dendrochronology? What
yes,
they found?
Yes. And George, I just want to say one thing too. When you're done finishing your point, I got a super chat recently with a question attached to it. So I want to make sure I get to the super chat. Go ahead, Brother George.
Okay, what they found in that study is when they looked at trees closer to the caldera, that's the edge of the volcano, and this is the first time they've ever done this. They actually went 30 kilometers away and looked at the ratios of C14 to carbon dioxide, and they found varying differences between the trees that were closer to the caldera to those that were 30 kilometers away. That just adds to that argument about the carbon dioxide that was probably taken up by the tree through the groundwater. So the dendrochronology is by no way an exact science. It isn't. There's just so many discrepancies with it that they don't actually tell you. Like we keep saying, they don't report the discordant data. They cherry pick their stuff to prove their narrative.
Right. Amen. And there's so much discordant data as well that typically they don't want to talk about or even bring up in the first place.
But keep in mind what my old statistics professor used to say: there are liars, there are big liars, and then there are statisticians. So statistics can be made to cherry pick data. Standing for truth?
Amen. Amen. Well said.
The other thing with statistics is you can make statistics say anything you want to. All you got to do is make sure you pick the right questions.
Yeah. Awesome. So I've got a super chat that came in here, $10 from Dr. James Carter. I appreciate the support, brother, and we look forward to having you on again soon. We're going to be doing a second part to our abiogenesis series. Last month we had Dr. Carter and Dr. Hayes on, so we're going to be continuing that series at the end of the month. So his super chat is a question for you, Professor McQueen. Do you think petroleum degradation, both chemically and via microbes, would outpace formation if the Earth is millions of years old?
Oh,
yes.
Good question. Good question.
Excellent point. In the summer, I want to give a whole presentation on research I began 40 years ago on a chemical called porphyrin, which is found in crude oil. Now, you have a porphyrin in your body, standing for truth, and you have a porphyrin growing in your grass, George, there in Australia. Hemoglobin, or the heme molecule in our blood, is a porphyrin. tetrapyrrole structure, and chlorophyll also is a tetrapyrrole structure. And the research by a group of two men that are called Tissot and Velta. You can Google me on icr.org, and you can find the essay I wrote in the 80s that deal with the origin of petroleum. And you can also go to Dr. Andrew Snelling's big 2-volume book, and he's got a section in it that deals with the origin of crude oil and updates this Tissot and Velta argument. The answer to your super chat is that you're absolutely right. If this crude oil was in the ground for millions of years, having been slowly deposited, not cut off from oxygen, not cut off from bacteria, it would have been eaten up, and we would all have to be running our cars on solar cells, which would be an industrial revolution nightmare.
That's another piece of evidence, David, that says whatever that oil came from had to be buried very quickly.
Exactly.
Under great pressure, and the oxygen would have had to be removed. Otherwise, you wouldn't have had the oil.
So I thank the good doctor for his question there.
Yeah.
Well, thank you for the question, James, and thank you for the great answer, David. George, unless you had anything else you wanted to say, I can.
Yeah, I've got
another one. Yeah, go ahead, brother. Go ahead.
I've got one question. I think it's a good one actually to cover, but I need to share my screen so that David can actually read it.
Yeah, and while he does that, let me make an offer that is based on this week-long discussion by the three of us. If you will send your name and address to Standing for Truth, the first 3 people that send your name and address, I will send you an autographed and inscribed copy of my book, which I just happen to have right here beside me, called The Mineral Book. And it's got a section in it back on page 69 that deals with some of the issues that we're talking about. So Standing for Truth, what's your email over the next week? And first 3 people that come through, you send me their name and address, and we will consider this a Geology Week bonus. 3 of us talking, like 3 books.
Oh, David, I had to buy that book.
Well, when I come to Australia or when we meet in Athens, Greece, you bring it in your suitcase. I'll autograph it for you.
Oh, beautiful, yeah.
I got to say, I'm looking forward to my autograph copy. Real quick, George. So I like the sounds of that, Professor McQueen. And it's a Genesis Flood Week bonus. So I'm going to put my email in the chat, and the first 3 that send me an email get an autographed copy of Professor McQueen's book. So,
okay, George, go on, take it back now. Share your screen and show us.
Check your email, Standing. I just sent you an email. No. Okay.
George, you sent me 3 emails. You get 3 books. Okay, here we go. Share screen.
All right. I wouldn't even bother with the first one. I don't like people that say things like that. But in the second part of it, he says, successive dryings of the Mediterranean produced hundreds of meters of evaporites. Not only did evaporites form, but also land deposits like sun-baked mud cracks, wind-blown sand, and subcar anhydrite nodules. Since algae can only grow where sunlight reaches, the stromatolites, a common algae deposit found in deep sea core samples, show that the Mediterranean seafloor, now 2 miles deep, was once dry land.
Okay, let me respond to that. There are 5 different issues there. I will pick only one, and that's the issue of salt deposits or evaporites in the Mediterranean basin. In the 1980s, one of my graduate students at the Institute for Creation Research graduate school named David Nutting did a study of evaporites in the Gulf of Mexico south of New Orleans. There's a very famous, very thick salt deposit there called the Luan Salt. And there's ample evidence that that wasn't an evaporite from oceans coming and going over tens of millions of years, but rather it had a hydrothermal origin. Now, does that mean that there was no salt evaporating on the one world continent in the days of Adam and Eve and the hundreds of years leading up to the flood? Of course not. So there are some legitimate evaporites, but to present an argument that flood geology must not be true based on the presence of stromatolitic groups, stromatolitic mounds, some of which may not be algal at all, but that's a story for another time. Let's focus on the evaporites. We're coming up to the last 10 minutes here, so I'll simply say that the evaporites can have a hydrothermal origin. And notice in the vocabulary that George and I use, we keep coming back to ways that this heat problem suggested by Jordan can be dealt with. It does indeed take heat to mature crude oil. It does indeed take hydrothermal or heated brines to produce the hydrothermal evaporite layers. So the more we talk, George, our list goes from 5 to 10 and beyond ways that we can have what people that have suffered through thermodynamics call heat sinks.
Heat sinks. Heat sinks.
Yeah, heat sinks. Yeah, good.
And I think it all comes down to us looking at it more like, as I was saying earlier, a feature and an aspect. And all of a sudden, as Professor McQueen said, we've got, 5 different heat sinks, 10 different heat sinks, eventually an unlimited amount. So good point. And I'm sorry to cut you off, George. Go ahead, brother.
Yeah, I was just going to add to what David was saying, because I watched this Kurt Wise video about, correct me here, David, whether I'm actually saying this correctly, seismatites. It's a cone.
Okay. That's a part. I think you're pronouncing the word seismatite, which is the result of a earthquake.
Yes.
Hitting muds and fat clays and jarring them and producing. I think Steve Austin has studied some of these in Israel, if I recall. But go ahead.
Yes, correct. What they found when they do find the seismatites, they can actually correlate them to the strength of the earthquake. But I think Kurt, I can't remember the actual location of this place, but he found one that was either 6 feet or 60 feet. Usually you find them like maybe an inch or two.
Yeah, a few centimeters. Yes.
But to find one so big through rock strata that was obviously, according to secular geology, hundreds of millions of years through hard rock, that's almost impossible. And the fact that this seismatite was so huge suggested that was one massive volcano or earthquake eruption.
Yes,
that caused it. And we keep going back to this. The initial the breakup of the deep was catastrophic. You would have had volcanoes, earthquakes of immeasurable measure and quantity. So
yes,
yeah. How do they explain that?
Well, that is an evidence for catastrophic geologic activity. We're coming up on the 2-hour break, and so can I make my summary comments and then turn it over to you and George, standing for truth?
Absolutely. So what I'm going to do as well is, because we've got questions for forever, essentially. So I'm going to save. I've got the questions saved on my phone. Therefore, the next time we have you on, Professor McQueen, we've always got a stash of questions for you. I want to thank Raymond for the super sticker. And also, looks like I've got some emails already. Emails are flying in,
good.
Professor McQueen.
That's good.
Looks like I've got
email them to me when the time comes.
I will. It looks like I've got 2 of the 3. So whoever's the third one, there's the prize. So go ahead, Professor McQueen.
The mailing of these books, the taking away of my valuable time from washing dishes for Mrs. McQueen, this is $100 value here, these 3 books, but we won't go into that. Let's get serious for a moment. We've argued all along that the Bible can be trusted. So we've argued forward from Genesis to the book of John. So we've said, since there's evidence for young earth creationism, that shows the Bible is true. And so when we go to the book of John and it talks about Jesus as Lord, then we can trust that. Well, since it's Easter Monday in Canada, and we've got the red and the white of Jesus's blood, his atonement, his death, his real burial as a dead man, and the resurrection behind me here, let's now take it in reverse. One of the most, one of the bits of Bible archaeology that is very strong evidence for the truth of the Bible is the evidence of the resurrection. Hundreds of people saw the Lord Jesus after he was raised from the dead. The scribes and Pharisees and Pilate and the Romans, if somebody had stolen the body and took it someplace, you can be sure that the scribes, the Pharisees, the Sadducees, they had decades to find it. They never found the body of Christ. So now let's do the reverse argument. Since we have proved that Jesus is the risen Lord and is alive right now at the right hand of God, we can work the sequence backwards. We've said many times that Jesus is the creator, the savior, and the coming king. Well, if there's evidence right in the middle dealing with the cross of Christ, I can get a cross here, dealing with the cross of Christ, proving the resurrection, then we can go backwards and say, well, we can trust the Bible, what it records in 30 AD. Why can't we trust it 4,000 years earlier? Makes sense, gentlemen?
Definitely.
Amen. Amen, Professor McQueen.
And happy Easter to all, by the way.
And with that comment, gentlemen, I will go ahead and X out of the chat and look forward to our discussion next week sometime, Standing for Truth.
Right.
Okay?
Yep.
Amen. Amen. I look forward to next week, Professor McQueen. Thank you. As always, you are a blessing. Some great answers to some great questions, Professor McQueen. So we will see you next
I look
week.
forward to listening to my 2 colleagues as the week goes on, Brother Sal and Mike Ord. Goodbye, gentlemen.
Goodbye,
See you, David.
Brother McQueen. So I want to thank the audience. Yeah, we just hit the 2-hour mark. So thank you so much for all the support, super stickers, super chats. You guys are the reason why we are able to do things like this. The Genesis Flood Week. In the summer, we want to do a Standing for Truth creation conference where we've got all sorts of topics pertaining to creation and going into the genetics, geology, biology, astronomy, so on and so forth. So your support is helping us do these awesome events. So I hope this was informative to everybody. I want to remind you this Wednesday, same time, 4:00 EST, Michael J. Ord will be here for a presentation on the post-flood ice age, followed by questions from you guys, just like we did today. And then the Thursday, we've got Sal Giardina, who will be with us here as well all week between Professor McQueen, Michael J. Ord, and Sal, all experts on these topics. So these are the men that you're going to want to ask these types of questions to. So George, any final words, brother?
Yeah, sneak preview. We're trying to get John McKay back on the stream, but I'm having some negotiation issues. I'm trying to get him down from his $1 million appearance fee. I think that's a bit too much for us, isn't it?
Well, we've had him on. Well, we've had John McKay on twice. That's $2 million. So now we got to raise another $1 million to get him on the third time.
Yeah, exactly.
So anybody new to the channel, go to the playlist section. I've organized it nicely. You can find answers to pretty much every objection to young Earth creation. Check out the interviews hosted by SFT, and you can find over 40 interviews with top PhDs on every subject possible. So we're doing it for you guys. We are here to serve. I think we've got about 1,200 videos on the channel. Also, check out, we've got a black and white version of my new book on independent origins, as well as the colored edition. I'm overwhelmed by how many people are picking it up and enjoying it. So the feedback is great.
Joke.
And Sal in the chat, Evidence and Reason, says, that's the other brother Sal, not me, Sal Giardina. I'm Sal Cordova. So we've got two brother Sals, one in geology and one in physics. Brother Cordova, correct me if I'm wrong, but he's a physics guy. So we've got experts on every topic, every field. So thanks again. And George, I know you're about to say a joke. You got to say two jokes because you skipped the joke at the introduction, brother. Go ahead.
No, I'll tell you one joke. I just remembered this joke. There's a Japanese emperor who's worried about being assassinated, so he puts out an ad in the paper to get some bodyguards. And he specifically says they must be master swordsmen. So 3 people applied: a Japanese samurai, a master swordsman from Korea, and a master swordsman from Israel. So he brings in the first one, the Japanese samurai, and he says, hello, goes through the interview processes. He shows him this matchbox. He says, in this matchbox, he says, I have a fly. I'm going to let him go, and you do your thing with your mastery, and we'll see how you go. So the emperor lets out the fly. Bzzz, there he goes in the sky. The samurai pulls out his sword and goes, swish, swish, and chops the fly into 4 pieces. The emperor's very impressed. He says, thank you very much. The Korean master swordsman comes in, goes through the same process, opens the matchbox, lets the fly out, swishes his sword out, and he goes, swish, 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 swish. 8 pieces. 8 pieces. The emperor's really, really impressed. So in comes the swordsman from Israel, and he goes through the same interview process, opens up the matchbox, lets the fly out. The swordsman from Israel pulls out his sword and goes, swish, 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 swish. And the fly is still buzzing around. And the empress looks at the Israeli and says, I'm bemused. He goes, what happened? You didn't kill the fly. He goes, no. He says, circumcision, not fatal.
All right, you made up for your lack of joke in the introduction, George. I think we've got our George back. So, George, we got to get you. We got to get you better because we got a big week ahead of us, brother, and I suspect a big summer ahead of us as well. So, anyways, guys, thanks so much in the chat. We will see you Wednesday with Michael J. Ord and Thursday with Sal Giardina. Also, we've got a debate on Saturday, I believe it is. Check the upcoming live stream section, guys, for the exact days and times for these events. But we got a debate between Nephilim Free and Mark Reed on evidence for the Christian God on Saturday. Next week, we've got Dr. Dan Biddle from Genesis Apologetics, who puts out some great videos. Their website is awesome. They touch on pretty well all the topics, kind of like we do. He's going to be with us. He's going to give a brief presentation on human evolution. Him and I have been talking back and forth through email, so I am pumped. He's going to give a presentation on human evolution. Then we're going to have an audience Q&A, some questions from us. We're going to demolish human evolution. We're going to touch on all the so-called transitional forms. Okay, guys, so you're definitely going to want to be here for that one. And then the following week, we've got the big debate between Joseph Hubbard and Taylor, who goes by Snake Was Right on YouTube, on young Earth creation and the global flood. So lots to look forward to. George, you get the final words, brother, and then we're going to shut it down.
Thanks, SFT. Yeah, look, sorry, but my voice might be a bit croaky. I've had a kind of nasty cold for the last week and a half. But I spent it out in the mountains with the clean air and the sunshine, and I'm getting better. So a happy Easter to everyone, and God bless you all.
Happy Easter. God bless everybody. I'll be praying for you, George. You sounded good today, though. You brought up some great points. Love the screen share. You're a screen share master now. So keep up the good work, George. When I say you are the award-winning co-host, I mean that. And there should be an award making its way to Australia at some point. So thanks so much, everybody. Yeah, go ahead, George.
I keep looking at the mailbox. There's nothing there.
Nothing yet.
Nothing.
I'm going to personally deliver it to you, George. And then I'll have some of that famous pizza you're constantly sending me pictures of over WhatsApp. Every time you send me a picture of that amazing looking pizza, I tell my wife, honey, we got to order pizza tonight. So you're feeding my addiction, brother.
I was gonna send you a picture of the smorgasbord we had in the mountains a couple of days ago, but I thought I won't rub it in.
Yeah. So is that the secret behind those biceps of yours? All that pizza?
That plus all the work my friends make me do for them.
Right. And all the work I make you do as well for the ministry, right?
Yeah.
You're working overtime, brother. You're working overtime. Anyways, thanks so much, everybody. We'll see you back on Wednesday.
And SFT is out.